Think of math like building a house. You need a strong foundation. In this course, you'll start from the basics and work your way up. From figuring out the size of a cube to solving tricky math problems, I'll guide you every step of the way. You'll begin with the simple stuff: adding, subtracting, multiplying, and dividing. These are the skills you use every day, like when you're shopping or building something in your backyard. Ever wondered how numbers can be taken apart and put back together? I'll show you. You'll learn about factors, which are like the building blocks of numbers, and how they help you simplify fractions. You'll also learn to find multiples by adding the same number many or multiple times. For example, the multiples of 4 are 4, 8, 12, 16, 20, and so on. Knowing your multiples will make working with fractions a lot easier. This section is all about comparing things to solve problems to find an unknown quantity. For instance, finding the speed of a car, price per pound, or the right mix of ingredients for a recipe. You'll explore fractions like 1/2 or 3/4, and decimals like 5/10 or 75/100, and how to work with them in real-life situations like when cooking and handling money. Ever wondered how to calculate a tip or figure out a discount? You'll cover that and more in this section. You'll also learn about interest, so you can make smart financial decisions. You'll learn how to deal with numbers that are less than 0, like when you owe money or the temperature drops. Understanding negative numbers will help you solve algebraic equations. Here you'll learn about exponents, which show how many times a number is multiplied by itself, and roots, which are the opposite of exponents. These operations are used in geometry to find the area of a square or the volume of a cube. You'll also master scientific notation to show really big numbers like the distance between the sun and Earth, or very small numbers like the width of an atom. In this last section, you'll also review the correct order of operations so you can solve any math problem with confidence. In this video, I'll show you how to make the most of this course. Each section of the course covers a big topic. Inside each section, there are lessons about a skill or concept you need to learn. Each lesson starts with a video where you can see me solve problems. Then you can try solving some on your own. After that, there's a quiz to check how much you learned. Just like anything else, the more you practice, the better you'll get. That's why I suggest doing all the practice activities to get better at the new skills you're learning. Each lesson has a practice activity with multiple choice questions just like the ones in the quizzes. Each question comes with a full explanation. I recommend doing the extra practice activity too, so you can really master the skill you're learning. And don't forget to double check your answers with the answer key to make sure you're on the right track. After each section, there's a review to see what you understood. It's like a test for that topic. I suggest doing all the lessons one after the other because math skills build on each other. But if you're good at a topic, you can jump to the review and see how you do. If you get 80% or more, you can skip that topic. But if you get less, it's a good idea to do the lessons in that section. Halfway through the course, there's a review to see what you still remember from the start. At the end of the course, there's a final review to see what you've learned. You can print all the practice activities, reviews, and tests if you like using paper and pencil. They all come with answer keys to help you understand how to solve the problems step by step. Remember, math is for everyone, including you. I know that by completing this course, you'll master the basics of math and set yourself up for future success. So I'll see you in the first section. In this video, I'll introduce you to the TI-30XS Multiview Calculator. So why should you learn how to use a calculator? Whether you're a student, a professional, or just need to solve math problems in everyday life, a calculator is a helpful tool for doing math quickly and accurately. In this course, we'll cover the basic functions and features of the TI-30XS Multiview Calculator so you can use it confidently. In this course, you'll get familiar with the buttons, keys, and display screen of the calculator. You'll learn what the different keys do and what they look like. You'll practice entering numbers and using the right buttons. You'll learn how to add, subtract, multiply, and divide with the calculator. You'll also find out how to work with decimals and fractions on the calculator. Then you'll learn how to convert between them. Finally, you'll explore other helpful functions like square roots, exponents, and percentages using the calculator. A calculator is a tool for math success. The TI-30XS handheld calculator is a handy tool for doing math. By understanding its basic functions and features, you can solve problems quickly and accurately. Practice using the calculator regularly to get more comfortable with it. Remember, the more you use it, the better you'll get at using all its different features. Now let's talk about next steps. The TI-30XS Multiview Calculator is the official calculator of the GED math exam. If you buy it, you can bring it with you to the test center and use it to solve 41 of the 46 questions on the math exam. You can buy this calculator online and at many retail stores for about $20. In the next lesson, you'll learn how to turn on and off the TI-30XS Multiview Calculator and how to adjust the calculator settings for the best experience. So I'll see you there. In this lesson, you'll learn how to turn the calculator on and off, and how to switch between different modes. By mastering these basic steps, you'll be ready to use the TI-30XS calculator for all kinds of math problems. So let's get started. On the TI-30XS calculator, most keys have two functions. The main function is shown on the key itself, while the secondary function is displayed above it. To access the secondary function of a key, simply press the second key, found in the upper left corner. This allows you to use both functions conveniently, depending on your calculation needs. For example, to turn the calculator on, find the On key, located in the lower left corner. On is the main function, written on the key itself and in white. To turn the calculator on, just press the On key. To turn the calculator off, find the Off function, written above the On key and highlighted in green. Because it's written above the key and in green, that means it's a secondary function. So to turn the calculator off, you first need to press the second key, which is the green key located in the upper left corner. And then press the On button to turn it off. Make sure to turn the calculator off when you're done. So to review, to turn the calculator on, press the On key in the lower left corner. To turn the calculator off, press the second key and then the On key. Practice makes permanent, so practice turning the calculator on and off a few times so you can get the hang of it. Now let's talk about changing modes. Modes are different settings on the calculator for different kinds of math. Press the Mode key to see the mode options. The Mode key is located to the right of the second key. You can use the arrows to find the mode you want. Press Enter to select the mode you want to use. I recommend keeping the default settings for most purposes. Math Print mode is more student-friendly than Classic mode. To return to the home screen, press the Clear key. Another way to return to the home screen is to press the second key and the Mode key to quit and return to the home screen and perform your work using the chosen mode settings. To review, to change or check the mode of your calculator, click the Mode key, which is next to the second key. I recommend you use Math Print mode. To go back to the home screen, press the Clear button, or you can press the second key and the Mode key, which will return you back to the home screen. Knowing how to turn the TI-30X's calculator on and off and switch between modes is important for using it effectively. With practice, you'll become comfortable with using the calculator for all kinds of math. In this lesson, you'll learn about place values in whole numbers. So let's get started. Let's start by talking about digits. So what are digits? Digits are the numbers we use. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. They're the building blocks for all numbers. Now follow along as I solve this problem. How many digits are in the number 548? In this number, I can count 3 digits, 5, 4, and 8. So my answer is B. Now it's your turn to practice. Find how many digits are in the number 8,345. Pause the video, and when you found your answer, click play. How many digits are in the number 8,345? In this number, we can count 4 digits, 8, 3, 4, and 5. So the answer is C. So what is place value? Place value is the position of a digit in a number. Each digit has a special value depending on where it is. For example, the number 368 has 3 place values. 3 is in the hundreds place. It represents 3 hundreds, or 300 ones. 6 is in the tens place. It represents 6 tens, or 60 ones. And 8 is in the ones place. It represents 8 ones. Place values are an essential part of our everyday life, even if we may not realize it. They help us understand and communicate amounts accurately. For instance, when we go shopping, place values help us understand the prices of items. We look at the digits on the price tag to determine the cost. The digits in the ones and tens place values show us how many dollars an item costs, while the digits in the cents place value tells us how many cents we have to pay. Let's start with the ones place. The rightmost digit in a number shows how many ones we have. For example, in the number 542, the digit 2 represents 2 ones. Now follow along as I solve this problem. In the number 849, which digit is in the ones place? Well, 9 is the rightmost digit. So 9 is in the ones place. My answer is C. Now it's your turn to practice. Find the digit in the ones place for the number 572. Pause the video, and when you found your answer, click play. Which digit is in the ones place of the number 572? In this number, 2 is the rightmost digit, so 2 is in the ones place. The answer is A. Next, we have the tens place. the digit just to the left of the ones place shows how many tens we have. For example, in the number 542, the digit 4 represents 4 tens. Follow along as I solve this problem. What is the place value of the digit 7 in the number 574? Well, 7 is 2 place values to the left. So 7 is in the tens place. My answer is B. Now it's your turn to practice. Find the digit in the tens place for the number 368. Pause the video, and when you found your answer, click play. What is the digit in the tens place in the number 368? In this number, 6 is 2 place values to the left. So 6 is in the tens place. The answer is C. Follow along as I solve this problem. What is the value of the tens place in the number 745? Well, 4 is 2 places to the left, so 4 is in the tens place. 4 represents 4 tens, and 4 tens is really the same thing as 4 times 10, which is 41s. So my answer is A. Now it's your turn to practice. In the number 532, what is the value of the digit in the tens place? Pause the video, and when you found your answer, click play. In the number 532, what is the value of the digit in the tens place? Well, 3 is 2 place values to the left, so 3 is in the tens place. 3 represents 3 tens, which is the same thing as 3 times 10, which equals 31s. So the answer is D. Next, we have the hundreds place. The digit to the left of the tens place shows how many hundreds we have. For example, in the number 542, the digit 5 represents 5 hundredths. Now follow along as I solve this problem. In the number 836, which digit is in the hundreds place? Well, the 8 is 3 places to the left, so 8 is in the hundreds place. My answer is A. Now it's your turn to practice. Find the digit in the hundreds place in the number 579. Pause the video, and when you found your answer, click play. In this number, the digit 5 is 3 places to the left. So 5 is in the hundreds place. The answer is B. Now follow along as I solve this problem. How many hundreds are there in 820? Well, 8 is 3 places to the left. So 8 is in the hundreds place. So my answer is C. Now it's your turn to practice. Find how many hundreds are in the number 280. Pause the video, and when you found your answer, click play. How many hundreds are in the number 280? Well, 2 is 3 places to the left. So 2 is in the hundreds place. The answer is A. Now let's talk about the larger place values. As you go further left, each digit represents a bigger place value, like thousands, 10,000s, 100,000s, millions, and so on. Each place value is 10 times bigger than the one to the right of it. For example, in the number 1,237, the digit 1 represents 1,000. Now follow along as I solve this problem. What is the place value of the digit 6 in the number 6,409? 6 is 4 place values to the left, so 6 is in the thousands place. My answer is D. Now it's your turn to practice. What is the digit in the thousands place? Pause the video, and when you found your answer, click play. In the number 9,548, what digit is in the thousands place? Well, 9 is 4 place values to the left, so 9 is in the thousands place. The answer is A. Now follow along as I solve this problem. How many thousands are in the number 8,543? Well, 8 is 4 place values to the left, so 8 is in the thousands place. My answer is D. Now it's your turn. Find the value of the digit in the thousands place. Pause the video, and when you found your answer, click play. What is the value of the digit in the thousands place in the number 2,125? If you count 4 places to the left, you end up at 2. 2 is in the thousands place. If I multiply 2 times 1,000, I get 2,001s. So the answer is C. It's also important to know how to read and write numbers. To read a number, we start from the left and say the value of each digit along with its place name. For example, you read and write the number 9,435 as 9,435 with a dash between 30 and 5. Now follow along as I solve this problem. How do you write the number? Well, in this case, I have 9 hundreds, 2 tens, which is really 21s, and 1 1. So I would write that as 921 with the dash between 20 and 1. My answer is B. Now it's your turn to practice. How do you write the number? Pause the video, and when you found your answer, click play. How do you write the number? In this case, you have 3,000s, 500s, 0 tens, and 7 ones. So you would write that as 3,507. The answer is C. We can also write numbers in expanded form, which means showing the value of each digit separately. For example, the number 356 in expanded form is 300 plus 50 plus 6. Now follow along as I solve this problem. Write the number 305 in expanded form. Well, here I have 3 hundreds, 0 tens, and 5 ones. So I would write that as 300 plus 5. My answer is D. Now it's your turn to practice. Write the number in expanded form. Pause the video, and when you found your answer, click play. Write the number in expanded form. Here you have 1,000, 200s, 0 tens, and 7 ones. So the answer is A. Now let's review. Digits are the numbers we use: 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Place value is the position of a digit in a number. Understanding place values helps us know the value of each digit in a number. By practicing place values, we can read, write, and work with numbers better. So what's next? Review what you've learned by doing the knowledge check. Then master what you've learned by doing the practice activity. In the next lesson, you'll learn a useful tip for rounding to the nearest whole place value, which is important for estimation. I'll see you there. In this lesson, you'll learn how to round numbers so you can estimate your answers. So let's get started. So why round numbers? Rounding is a helpful tool that makes numbers simpler and easier to work with. It helps you get a general idea of how big or small a number is. You can use rounding to quickly estimate values or make your calculations easier. For example, if you round a distance of 346 miles to the nearest 10, it becomes 350 miles. If you round to the nearest 100, it becomes 300 miles. But remember, rounding is not exact, so if you need precise answers, you need to use the original numbers without rounding. Now let's learn how to round to the nearest whole place value. First, find the place you're rounding to. Then, look to the place value to the right. If the digit is 5 or more, round up. If it's 4 or less, round down. Now let's practice rounding to the nearest tens place. Here we have the number 47. 4 is in the tens place, and 7 is to the right of the tens place. Since 7 is 5 or more, we need to round up by adding 1 to the 4. So the 4 becomes 5, and 7 becomes 0. So 47 rounds up to 50. When rounding, you can use the symbol squiggly equal sign, which means approximately equal to. So 47 is approximately equal to 50. Now follow along as I solve this problem. Round 74 to the nearest 10. In this case, I have the number 74. 7 is in the tens place, and 4 is to the right of the tens place. Since 4 is 4 or less, I need to round down, which means 7 stays the same and 4 becomes 0. So 74 rounds down to 70. My answer is B. Now it's your turn to practice. Round 66 to the nearest 10. Pause the video, and when you found your answer, click play. To round 66 to the nearest tens place, you need to look at the digit to the right of the tens place, which is 6 ones. Since 6 is 5 or more, you need to round up by adding 1 to the 6 in the tens place. So 6 becomes 7, and 6 ones become 0. So 66 rounds up to 70. The answer is B. A helpful saying to remember the rounding rules is 5 or more, raise the score. 4 or less, let it rest. Now follow along as I solve this problem. Round 3,587 to the nearest 100. Here I have the number 3,587. 5 is in the hundreds place, so 8 is to the right of the hundreds place. 8 is 5 or more, so I need to round up by adding 1 to the 5. The 3 stays the same, the 5 becomes a 6, and 8 and 7 become zeros. So 3,587 rounds up to 3,600. The answer is B. Now it's your turn to practice. Round 1,245 to the nearest 100. Pause the video, and when you found your answer, click play. To round 1,245 to the nearest hundred, you need to look at the digit to the right of the hundreds place, which is 4. Since 4 is 4 or less, you need to round down. So 1 and 2 stay the same, and 4 and 5 become zeros. So 1,245 rounds down to 1,200. The answer is A. Now follow along as I solve this problem. Round 7,500 to the nearest thousand. Here I have the number 7,500. I need to look at the digit to the right of the thousands place, which is 5. Since 5 is 5 or more, I need to round up by adding 1 to the 7. So 7 becomes 8, and the 5 becomes a 0. So 7,500 rounds up to 8,000. My answer is C. Now it's your turn to practice. Round 2,499 to the nearest thousand. Pause the video, and when you found your answer, click play. To round 2,499 to the nearest thousand, you need to look at the digit to the right of the thousands place, which is 4. Since 4 is 4 or less, you need to round down. So 2 stays the same, and the 499 becomes zeros. So 2,499 rounds down to 2,000. The answer is C. So what is estimation? Estimation is a handy trick that helps you quickly guess the size of numbers without doing exact calculations. You can round numbers to a nearby value, like the nearest 10, 100, or 1,000, to make estimation easier. It's a useful tool when you want a rough idea of how big or small something is without needing an exact answer. For example, to estimate the sum of 378 and 245, round 378 up to 400 and 245 down to 200. Adding these rounded numbers, 400 plus 200, gives you an estimated sum of 600. Now follow along as I solve this problem. Estimate the sum of 64 and 95. Here I need to find an estimate for 64 plus 95. Here I can round 64 to the nearest 10. Since 4 is 4 or less, 64 rounds down to 60. Since 5 is 5 or more, 95 rounds up to 100. 60 plus 100 gives me 160. So my estimate is B, 160. Now if I add the numbers up exactly, I get 4 plus 5, which is 9, and 6 plus 9, which is 15. As you can see, 159 is approximately 160. Now it's your turn to practice. Estimate the sum of 46 and 53. Pause the video, and when you found your answer, click play. To estimate the sum of 46 and 53, you can round them to the nearest 10. Since 6 is 5 or more, 46 rounds up to 50. Since 3 is 4 or less, 53 rounds down to 50. When you add 50 and 50, you get 100. So your estimate is A, 100. If you were to add the numbers exactly, you would get 6 plus 3, which is 9, and 4 plus 5, which is 9. 99 is close to 100. Now follow along as I solve this problem. Estimate the difference between 586 and 211. Here I need to find an estimate for 586 minus 211. Here I can round to the nearest hundred. Since 8 is 5 or more, I would round 586 up to 600. Since 1 is 4 or less, I would round down to 200. 600 minus 200 is 400. So my estimate is C, 400. To solve this exactly, I would subtract 1 from 6, which is 5, and 1 from 8 is 7, and 2 from 5 is 3. As you can see, 375 is approximately 400. Now it's your turn to practice. Estimate the difference between 891 and 420. Pause the video, and when you found your answer, click play. Here you need to estimate the difference between 891 and 420. You can round to the nearest hundred. Since 9 is 5 or more, 891 rounds up to 900. Since 2 is 4 or less, 420 rounds down to 400. 900 minus 400 is 500. So the estimate is 500, which is D. To solve this exactly, you would take away 0 from 1, which is 1. 2 from 9 is 7, and 4 from 8 is 4. As you can see, 471 is close to 500. Now let's review. Rounding to the nearest tens, hundreds, and thousands is a way to make numbers simpler and estimate their values quickly. Follow these steps to round to the nearest whole place value. First, find the place you're rounding to. Then, look at the place value to the right. If the digit is 5 or more, round up. If it's 4 or less, round down. Just keep in mind that rounding and estimation give you close answers, not exact answers. So what's next? Review what you learned by doing the knowledge check. Then master what you've learned by doing the practice activities. In the next lesson, you'll learn what an operation is in math and how they help us solve problems. I'll see you there. In this lesson, you'll learn what an operation is in math. So let's get started. So what is an operation? An operation in math is an action, like add, subtract, multiply, and divide. For example, adding is an operation that combines two numbers to get a total, just like when you add up the prices of different items you want to buy to get the total cost. When performing an operation, you start with inputs, which are usually numbers, and you do something with them to get a new result or output. It's like following a recipe to create something new out of the ingredients you have. For example, 3 and 2 are the inputs. When we add them together, we get 5, which is the output. There are many other operations in math, but they all work by taking inputs and producing an output. By understanding how these operations work, you can use them to solve problems and perform calculations more easily. In this unit, you'll gain a deeper understanding of the 4 basic operations: addition, subtraction, multiplication, and division. You're already familiar with these operations because you use them in your daily life. For example, when you shop online, prepare food, and watch sports, just to name a few. Now let's review what you've learned. An operation in math is an action, like add, subtract, multiply, and divide. There are many other operations in math, but they all work by taking inputs and producing an output. You're already familiar with these operations because you use them in your daily life. So what's next? Review what you've learned by doing the knowledge check. Then, in the next lesson, you'll learn a useful tip for doing addition. I'll see you there. In this lesson, you'll learn a useful tip for doing addition. So let's get started. So what is addition? Addition is combining two or more numbers to find their total or sum. It's something we use in everyday life, like when we add up the cost of items we want to buy, or when we count how many people are in a room. Imagine you have 2 apples and you want to add 3 more. To do this, you simply put them together and count how many you have in total, which is 5 apples. So 2 plus 3 equals 5. Now let's say you have 8 candies and your friend gives you 7 more. You would add 8 and 7 together, which equals 15 candies in total. So 8 plus 7 equals 15. Now follow along as I solve this problem. What is the sum of 12 and 4? To find the sum of 12 and 4, I add them together. I can start with 12 and count 4 more. 13, 14, 15, 16. So my answer is A. Now it's your turn to practice. Find the sum of 8 and 3. Pause the video, and when you're done, click play. What is the sum of 8 and 3? To find the sum of 8 and 3, you add them together. You can start with 8 and count 3 more. 9, 10, 11. So the answer is B. Now let's talk about adding in any order. If you have 2 numbers and you add them together, it doesn't matter which number you add first. The result will always be the same. If you start with 3 apples and add 5 oranges, you end up with 8 pieces of fruit. If you start with 5 oranges and add 3 apples, you also end up with 8 pieces of fruit. So 3 plus 5 is equal to 5 plus 3. The order in which you add the numbers doesn't change the final result. And this is true for adding any numbers together. Now you know that you can add numbers in any order. This is also true for larger numbers. For instance, if you add 17 and 15, the sum is 29. If you switch the order and add 15 and 17 instead, you still get 29. So 17 plus 15 is equal to 15 plus 17 because they both add up to 29. Now follow along as I solve this problem. 3 plus 9 is equal to which of the following expressions? Well, 3 plus 9 is equal to 9 plus 3. I know this is true because 3 plus 9 is 12, and so is 9 plus 3. So my answer is D. So now it's your turn to practice. Find the expression that is equal to 7 plus 4. Pause the video, and when you found your answer, click play. To find the equivalent expression of 7 plus 4, you can use your knowledge that you can add in any order. So 7 plus 4 is equal to 4 plus 7. You can check your answer by adding 7 plus 4, which is 11. And that is equal to 4 plus 7, which is also 11. So the answer is C. Knowing that you can add numbers in any order and still get the same result is important because it allows us to rearrange numbers and make it easier to add. For example, if you need to add several numbers together, you can rearrange them in any order you like, and you'll still get the same result. For example, if we have to add 15 plus 9 plus 5, we can add 15 and 5 together first, which is easier than adding 15 plus 9 or 9 plus 5. 15 plus 5 is 20. Then I can add 9. 20 plus 9 equals 29. Follow along as I solve this problem. What is 6 plus 1 plus 4? To solve this problem, I can start by adding 6 and 4, which gives me 10. Then I can add 1. 10 plus 1 equals 11. So my answer is C. So now it's your turn to practice. Add 3 plus 9 plus 7 in the order that is easiest for you. Press pause, and when you found your answer, click play. What is 3 plus 9 plus 7? To solve this problem, you can add 3 and 7 first. 3 plus 7 is 10. Then you can add 9. 10 plus 9 is 19. So the answer is D. Now let's review what you've learned. Addition is combining two or more numbers to find their total or sum. When adding two or more numbers, the order in which you add them does not affect the final result. Addition is something we use in everyday life, like when we add up the cost of items we want to buy, or when we count how many people are in a room. So what's next? Review what you've learned by doing the knowledge check. Then, master what you've learned by doing the practice activity. In the next lesson, you'll learn some useful tips to solve word problems with addition. I'll see you there. In this lesson, you'll learn how to add numbers by hand. So let's get started. Step 1. Understand place value. Before we start adding, let's remember place value. Each digit in a number has a special place. The rightmost digit is the ones place. The next digit to the left is the tens place, and so on. Knowing place value is important for adding accurately. Here we're adding 397 plus 18. 397 has 3 place values: 7 ones, 9 tens, 3 hundreds. 18 has 2 place values: 8 ones and 1 10. Step 2. Line up the numbers. To add numbers, we need to line them up vertically, making sure the digits in each place value are under each other. In this case, we have 7 ones and 8 ones, and they're on top of each other. We have 9 tens and 1 10, and they're on top of each other. Step 3. Add the digits. Start adding the digits in the rightmost column, the ones place. Add them together and write the answer directly below. If the answer is a 1-digit number, it stays in the ones place. If it's a 2-digit number, write down the rightmost digit and carry the leftmost digit to the next column. Here we have 7 ones plus 8 ones. That gives me a total of 15 ones, which is 5 ones and 1 10. Step 4. Carrying over. If the answer in any column is a 2-digit number, carry the leftmost digit to the next column. This means adding it to the digits in that column. Keep doing this if needed, moving from right to left. Here I have 9 tens plus 1 10 is 10 tens, plus the 1 10 that I carried. That gives us a total of 11 tens, which is 110 and 100. Step 5. Add the remaining columns. Continue adding the digits in the remaining columns, carrying over when necessary. Write the answer below each column. Here I have 3 hundreds plus the 100 that I carried over. Together, that gives me 3 plus 1, which is 400. Step 6. Find the total. Once you've added all the columns, the final answer is the total sum of the numbers. Write it down in the proper place value format. In this case, when I add 397 to 18, I get a total of 415. Step 7. Practice. Now it's time to practice. Start with simple addition problems and then move to more challenging ones. Remember to line up the numbers correctly, add digit by digit, and carry over when needed. Now follow along as I solve this problem. 15 plus 7. So first, I need to add them up vertically, making sure to line up my place values. Here I have 15 plus 7. I've put the 5 ones and the 7 ones on top of each other. And then I add them together. 5 plus 7 is 12, which is 2 ones and 1 10. Then I add the 1 10 plus the other 10 that I carried over, which gives me 2 10s. Now I can see that when I add these numbers together, I get an answer of 22. Now it's your turn to practice. Add 18 plus 6 by hand, making sure to line up your place values and carry over when needed. Pause the video, and when you found your answer, click play. Here you need to add 18 plus 6. Start by lining up the numbers vertically according to their place values. Here you have 8 ones plus 6 ones. 8 plus 6 is 14, which is 4 ones and 1 10. Then you need to add up the tens place. You have 1 10 plus the other 10 that you carried over, which gives you a total of 2 10s. Your final answer is 24. Follow along as I solve this problem. Here I need to add 81 and 19. I start by lining up my place values vertically. Here I need to add my ones first. So I have 1 1 plus 9 ones is 10 ones, which is the same as 0 ones and 1 10. Next I need to add up my tens place. Here I have 8 tens plus 1 10 is 9 tens, plus the 10 that I carried over. That gives me a total of 10 tens, which is 0 tens and 100. So my answer is 100. Now it's your turn to practice. Add 92 and 57 by hand, making sure to line up your place values and carry over when needed. Pause the video, and when you found your answer, click play. Here you need to add 92 plus 57. Start by lining up your numbers vertically so that the ones and tens place are on top of each other. Here we have 2 ones plus 7 ones is 9 ones. Then add up your tens place. 9 tens plus 5 tens is 14 tens, which is the same as 4 tens and 100. So your answer is 149. Now follow along as I solve this problem. Here I need to add 1,234 and 567. I start by lining up my place values vertically. Here I have 4 ones plus 7 ones is 11 ones, which is 1 1 and 1 10. Next, I need to add up my tens place. Here I have 6 tens plus 3 tens is 9 tens, plus the 10 that I carried over gives me a total of 10 tens, which is 0 tens and 100. Next, I need to add up my hundreds place. 5 hundreds plus 2 hundreds is 7 hundreds, plus the 100 that I carried over gives me 800. And then I have 1,000, which I can bring down, giving me a total of 1,801. Now it's your turn to practice. Add 4,321 and 789 by hand. Pause the video, and when you found your answer, click play. Here you need to add 4,321 to 789. Start by lining up your numbers based on place value. Here we have 1 1 plus 9 1 is 10 ones, which is 0 ones and 1 10. Next, add up your tens place. 8 tens plus 2 tens is 10 tens, plus the 10 that you carried over, which gives you 11 tens, which is 110 and 100. Add up your hundreds place. 7 hundreds plus 3 hundreds is 10 hundreds, plus the 100 that you carried over, which is 11 hundreds, which is the same thing as 100 plus 1,000. Then add up your thousands place. 4,000 plus the 1,000 that you carried over gives you 5,000. Your sum is going to be 5,110. Now let's review. Remember to align the numbers properly and carry over whenever the sum in a column is greater than 9. Take your time and carefully solve each problem. You've learned how to add numbers using pencil and paper. This skill is helpful in everyday life and sets the foundation for more advanced math. Keep practicing, and soon you'll be a pro at adding numbers. In this lesson, you'll learn how to add numbers using a TI-30XS calculator. So let's get started. Follow along as I add the numbers 32 and 15. I'll start by entering the first number. Then I'll click the plus key, which is on the right side of the calculator towards the bottom. Then I'll enter the second number. To get my answer, I'll click the Enter button in the lower right corner. As you can see, the answer is 47. Now it's your turn to practice. Use the calculator to add the numbers 47 and 62. Pause the video, and when you found your answer, click play. To add the numbers 47 and 62, start by entering the first number, 47. Then, click the plus key. Next, enter the second number, 62. To get your answer, click the Enter button in the lower right corner. Your answer is 109. Let's do some more practice. Add the numbers 89 and 21 using your calculator. Pause the video, and when you found your answer, click play. To add the numbers 89 and 21, start by entering the first number, 89. Then click the plus key. Next, enter the second number, 21. And finally, click the Enter button in the lower right corner to get your answer. As you can see, the answer is 110. Using the TI-30X's calculator for addition helps you add numbers quickly and correctly to check your work. By following the steps, you can find the sum of numbers easily. Practice using the calculator to become comfortable with adding numbers. In this lesson, you'll learn how to solve addition word problems. So let's get started. Solving addition word problems is all about turning the words into an addition problem. Here are the steps you can follow. Step 1. Read the problem carefully and understand what it's asking you to do. Look for clues such as total, sum, altogether, or in all, which usually mean that you need to add numbers together. Step 2. Find the numbers in the problem. Step 3. Write the numbers down and add them up to find the answer. Be sure to double check your work to make sure you've added everything correctly. Let's take a look at an example. John has 11 apples and his friend gives him 7 more. How many apples does John have in all? The problem is asking you to find the total number of apples John has. The numbers in the problem are 11 and 7. John starts with 11 apples and his friend gives him 7 more. Write down the numbers and add them up. 11 plus 7 is 18, so John has 18 apples in all. Let's take a look at another example. If Jane has 14 pencils and buys 11 more, how many pencils does she have in all? The problem is asking you to find the total number of pencils Jane has. The numbers in the problem are 14 and 11. Jane starts with 14 pencils and buys 11 more. Write down the numbers and add them up. 14 plus 11 is 25, so Jane has 25 pencils in all. Now follow along as I solve this problem. Sally has 18 tickets and her friend gives her 12 more. How many tickets does Sally have in all? Let's start by reading the problem carefully and looking for clues to understand what we need to do. Sally has 18 tickets and her friend gives her friend 12 more. How many tickets does she have in all? Gives, more, and in all are clues that tell us that we need to add to find the total number of tickets that Sally has. The numbers in the problem are 18 and 12. Let's write them down and add them up. 18 plus 12 gives us 30 tickets total. So Sally has 30 tickets in all. Now it's your turn to practice. Read the problem below and follow the steps to solve. Pause the video, and when you found your answer, click play. Let's start by reading the problem carefully, looking for clues to understand what we need to do. There are 15 red apples and 12 green apples in a basket. How many apples are in the basket in all? In this case, the clue is in all. In all tells us that we need to add to find the total number of apples. The numbers in the problem are 15 and 12. Let's write those down and add them up. 15 plus 12 gives us a total of 27 apples. So there are 27 apples in the basket in all. Read the problem below for more practice and follow the steps to solve. Pause the video, and when you found your answer, click play. Let's start by reading the problem carefully, looking for clues to understand what we need to do. Jack has $10 and his mom gives him $17. How much money does Jack have now? The clue here is gives, and now. Together, the clues tell us that we need to add to find the total amount of money that Jack has. The numbers in the problem are 10 and 17. Let's write those down and add them up. 10 plus 17 gives us $27. So Jack has $27 in total. Let's review. To solve addition word problems, start by reading the problem carefully, then finding the numbers and adding them up to find the answer. Look for clues such as total, sum, altogether, and in all, which usually mean that you need to add numbers together. With practice, you'll be able to solve these problems quickly and easily. So what's next? Review what you've learned by doing the knowledge check. Then, master what you've learned by doing the practice activity. In the next lesson, you'll learn a useful tip for doing subtraction. I'll see you there. In this lesson, you'll learn some useful tips for doing subtraction. So let's get started. So what is subtraction? Subtraction is taking away one number from another number to find their difference. We use subtraction in many everyday situations, such as figuring out how much change we should receive when shopping, just to name one example. Imagine you have 5 apples and you give away 3 of them. You can use subtraction to find out how many apples you have left. The problem would look like 5 minus 3 equals 2. You start with 5 apples and then subtract the 3 apples you give away, which leaves you with 2 apples left over. Let's say you have $8 and you want to buy something that costs $3. You can use subtraction to find out how much money you'll have after buying the item. The problem would look like this. 8 minus 3 equals 5. You start with $8 and then subtract the $3 you spend, which leaves you with $5 left over. Now follow along as I solve this problem. What is 11 minus 5? I'll start with 11 and count down 5. 10, 9, 8, 7, 6. 11 minus 5 equals 6. So my answer is C. So now it's your turn to practice. Solve what is 25 minus 8, starting with 25 and counting down 8. Pause the video, and when you're finished, click play. What is 25 minus 8? To solve this problem, you'll start with 25, and then you'll count down 8. 24, 23, 22, 21, 20, 19, 18, 17. So 25 minus 8 equals 17. The answer is B. When we subtract, the order of the numbers does matter because changing the order of the numbers can change the result. For example, if I start with $5 and spend $3, I end up with $2 left over. So 5 minus 3 is 2. But if I switch the order and start with $3, and then I spend $5, I end up with no money. And in fact, I actually end up owing $2. So 3 minus 5 equals negative 2. As you can see, 5 minus 3 does not equal 3 minus 5. Now let's take the example of 8 minus 2 minus 1. Here we have to subtract twice. Let's say I decide to subtract 2 from 8. That gives me 6. And then I subtract 1 from 6, which gives me 5. But what happens if I subtract 1 from 2 first, which gives me 1, and then subtract 1 from 8, which gives me 7? As you can see, I get two different answers, but only one of them can be right. So when you subtract, it's important to subtract from left to right. So the answer that is correct is 5. First, we would subtract 2 from 8, which gives us 6, and then subtract 1 from 6 to give us 5. If we did it in a different order, we would get the wrong answer. Follow along as I solve this problem. What is 100 minus 20 minus 30? Here I have to subtract twice, and I know that I need to work left to right. So first I'll subtract 20 from 100, which gives me 80. And then I'll subtract 30 from 80, which gives me 50. So my answer is A. Now it's your turn to practice. Solve 75 minus 60 minus 5. Make sure to subtract working left to right. Pause the video, and when you're done, click play. What is 75 minus 60 minus 5? In this problem, you need to subtract twice, and you need to subtract working left to right. So first, you can subtract 60 from 75, which gives you 15. And then you subtract 5 from 15, which gives you 10. So the answer is B. Let's review. Subtraction is taking away one number from another number to find their difference. To solve a subtraction problem, start with the total amount and then subtract the amount you want to take away. Remember, when we subtract, the order of the numbers does matter. We use subtraction in many everyday situations, such as figuring out how much change we should receive when shopping, just to name one example. It's an important skill that helps us solve problems and make decisions in our daily lives. What's next? Review what you've learned by doing the knowledge check. Then, master what you've learned by doing the practice activity. In the next lesson, you'll learn some useful tips to solve word problems with subtraction. I'll see you there. In this lesson, you'll learn how to subtract numbers by hand. So let's get started. Step 1. Understand place value. Before we start subtracting, let's remember place value. Each digit in a number has a special place. The rightmost digit is the ones place. The next digit to the left is the tens place, and so on. Understanding place value helps us subtract correctly. Here we're subtracting 156 from 438. You can see here that 438 has 3 place values: 8 ones, 3 tens, 4 hundreds. 156 has 6 ones, 5 tens, 100. Step 2. Line up the numbers. To subtract, we need to write the numbers one below the other, making sure that the digits in each place value line up. Here we see that 6 ones is below 8 ones. 5 tens is below 3 tens, and 100 is below 400. Step 3. Subtract the digits. Start with the rightmost column, the ones place, and subtract the bottom digit from the top digit. Write the answer directly below. If the top digit is smaller than the bottom digit, we may need to borrow from the next column to the left. Here we're subtracting 6 ones from 8 ones. Since 8 ones is bigger than 6 ones, I can go ahead and subtract 6 from 8. 8 minus 6 is 2. Step 4. Borrowing. If the top digit is smaller than the bottom digit, we borrow from the next column. we subtract 1 from the digit in the next column and add 10 to the top digit. Then we subtract the bottom digit from the new top digit and write the answer below. Here we're subtracting 5 tens from 3 tens. Since 3 tens is smaller than 5 tens, we have to borrow from the hundreds place. I subtract 1 from 4, which gives me 3 hundreds. 100 is really 10 tens, so I add 10 to the 3, which gives me 13 tens. Now I can subtract 5 tens from 13 tens, which gives me 8 tens. Step 5. Continue subtracting. Keep subtracting digit by digit, making sure to borrow when necessary, and write the answers below each column. Here we're subtracting 100 from 300. 300 minus 100 is 200. Step 6. Find the final difference. Once we have subtracted all the columns, we have our final answer. Write it down in the correct place value format. When I subtract 156 from 438, I get an answer of 282. Step 7. Practice. Now it's time to practice. Start with easy subtraction problems and gradually move to ones that are more difficult. Remember to line up the numbers correctly. Subtract one digit at a time and borrow when needed. Follow along as I solve this problem, 74 minus 9. To solve this problem, I need to write my numbers vertically so that the place values are on top of each other. I can see here that I need to subtract 9 ones from 4 ones. Since 4 is less than 9, I need to borrow from the tens place. I can borrow 1 10 from 70, which leaves me with 6 tens. 1 10 is really 10 ones, so I need to add 10 to the 4, which gives me 14. 14 take away 9 is 5. And 6 take away nothing is 6. So my answer is 65. Now it's your turn to practice. Find the answer to 52 minus 3 by hand. Pause the video, and when you found your answer, click play. To solve 52 minus 3, you need to write your numbers vertically so the place values align. Here you need to subtract 3 from 2. Since 2 is less than 3, you need to borrow from the tens place. 5 minus 1 is 4. 1 10 is really 10 ones, so we add 10 to the 2, which gives us 12. 12 take away 3 is 9. 4 take away nothing is 4. So the answer is 49. Follow along as I solve this problem. 63 minus 48. To solve this problem, I need to write my numbers vertically, so the place values line up. Here I need to subtract 8 ones from 3 ones. Since 3 ones is less than 8 ones, I need to borrow from the tens place. 6 take away 1 is 5. 1 10 is really 10 ones, so I add those to the 3, which gives me 13. 13 take away 8 is 5. And 5 take away 4 is 1. So my answer is 15. Now it's your turn to practice. Find 92 minus 57 by hand. Pause the video, and when you found your answer, click play. To solve 92 minus 57, you need to line up the numbers vertically so the place values are on top of each other. Here, you need to subtract 7 from 2. Since 2 is less than 7, you need to borrow from the tens place. If we borrow a 10 from the 9, we end up with 8 tens. And 1 10 is really 10 ones. So 10 plus 2 is 12. 12 take away 7 is 5. And 8 take away 5 is 3. The answer is 35. Now follow along as I solve this problem. 9,321 minus 439. To solve this problem, I need to line up my numbers according to place value. Here, I need to subtract 9 from 1. Since 1 is less than 9, I need to borrow from the tens. But 3 is bigger than 2, so I need to borrow from the hundreds. But 4 is bigger than 3, so I need to borrow from the thousands place. 9 take away 1 is 8. Now I have 8,000. That 1,000 is really 10 hundreds, so 10 plus 3 is 13. Now I need to borrow 100 for the tens, so 13 take away 1 is 12. And 100 is really 10 tens, so 2 plus 10 is 12. Now I need to borrow a 10. 12 minus 1 is 11. And 110 is 10 ones. 1 plus 10 is 11. Now I can subtract 9 from 11, which is 2. 11 minus 3 is 8. 12 take away 4 is 8. And 8 take away nothing is 8. My answer is 8,882. Now it's your turn to practice. Solve for 8,547 minus 298 by hand. Pause the video, and when you found your answer, click play. To solve 8,547 minus 298, I need to line up my place values vertically. Then I have to look at the ones place. 7 minus 8 won't work because 7 is less than 8. So I have to borrow from the tens. But 9 is bigger than 4, so I need to borrow from the hundreds. 2 is less than 5, so I can borrow 100. 5 take away 1 is 4. 100 is 10 tens, so 4 plus 10 is 14. I need to borrow a 10. 14 minus 1 is 13. And 110 is 10 ones, so 7 plus 10 is 17. 17 take away 8 is 9. 13 take away 9 is 4. 4 take away 2 is 2. And 8 take away nothing is 8. So the answer is 8,249. Now let's review. Remember to align the numbers properly and borrow whenever necessary. Take your time and solve each problem step by step. You've learned how to subtract numbers using just a pencil and paper. This skill is helpful in many situations, like solving problems and doing math calculations. Keep practicing, and soon you'll become a subtraction expert. In this lesson, you'll learn how to subtract numbers using the TI-30XS calculator, So let's get started. Follow along as I solve the problem 54 minus 27. I'll start by entering the first number, 54. Then I need to click the minus key, which is above the plus key. Then I need to enter the second number, 27. To get my answer, I need to press the Enter button in the lower right corner. My answer is 27. Now it's your turn to practice. Find the answer to 98 minus 63 using your calculator. Pause the video, and when you found your answer, click play. To find the answer to 98 minus 63, first type in the number 98. Then click the minus key, followed by the second number, 63. Press Enter in the lower right corner to get your answer. The difference is 35. Now let's get some more practice. Find the answer to 103 minus 85 using your calculator. Pause the video, and when you found your answer, click play. To find 103 minus 85, first type in 103. Then click the minus key. Then enter the second number, 85. Click Enter in the lower right corner to get the difference. The answer is 18. Using the TI-30X's calculator makes it easy to subtract numbers accurately, so you can check your work. Just follow the steps to get the answer. Practice more subtraction problems to become more comfortable with the calculator. In this lesson, you'll learn some useful tips for solving word problems with subtraction. So let's get started. Let's start by talking about keywords. Sometimes in a word problem, you might see specific words that suggest that you need to use subtraction. These words include, but are not limited to, difference, decrease, less, minus, reduce, subtract, take away, remainder. Here are 5 steps to follow for solving subtraction word problems. Step 1. Read the problem carefully to understand what it's asking you to find. Find the important information and write it down if necessary. Step 2. Look for the numbers in the problem that you'll need to use for subtraction. Sometimes you may need to do a bit of math to figure out what the numbers are. Step 3. Write a subtraction problem using the numbers you found. Make sure you write the numbers in the correct order. The number you are subtracting should come after the subtraction sign. Step 4. Solve the subtraction problem. Be careful with your calculations and double-check your answer. Step 5. Write your final answer in a complete sentence that answers the question asked in the problem. Make sure you include the correct units if necessary. Follow along as I solve this problem. Let's look at an example to see how these steps work in practice. Jenny has 12 apples. She gives 5 apples to her friend. How many apples does Jenny have left? I can see here that we're looking to solve for how many apples Jenny has left. The left is a keyword, suggesting that I need to use subtraction. I can see here that Jenny starts with 12 apples. And she gives away 5 apples to her friend. Gives means remove, which is like subtraction. So I need to subtract 5 from 12. If I count down 5 from 12, I end up at 11, 10, 9, 8, 7. That means Jenny has 7 apples left. Let's practice together. Jack has 25 marbles. He gave 9 marbles to his sister. How many marbles does Jack have left? Well, what are we solving for in this problem? It says here we need to solve for how many marbles Jack has left, which suggests subtraction. We know that Jack had 25 marbles to start with. And it says here that he gave 9 marbles to his sister. The fact that he gave them away means that we need to subtract 9 from 25. If we take away 9 from 25, we can count down and get our answer. 24, 23, 22, 21, 20, 19, 18, 17, 16. 25 minus 9 is 16. So Jack has 16 marbles left. Now it's your turn to practice. Read the problem carefully, pause the video, and when you solve the problem, click play. Sarah had 15 pencils. She lost 4 pencils. How many pencils does Sarah have now? In this problem, you need to solve for how many pencils she has now. You can see that Sarah had 15 pencils to start with, and that she lost 4 pencils. Losing pencils is like taking away pencils, so if we subtract 4 from 15, we'll get how many pencils she has left. If I count down 4 from 15, I end up at 14, 13, 12, 11. That means Sarah now has 11 pencils. Read the problem carefully for more practice. Pause the video, and when you're done solving, click play. There are 20 children in a classroom. 7 children went home early. How many children are still in the classroom? Here you need to solve for how many children are still in the classroom. You can see here that there were 20 children to start with, and that 7 children went home early. The fact that they went home means we need to take away 7 children. To find 20 minus 7, I can count down 7 from 20. 19, 18, 17, 16, 15, 14, 13. So there were 13 children still left in the classroom. Now let's review. Solving subtraction word problems involves reading the problem carefully, finding the numbers involved, and writing a subtraction problem using the numbers you found. Make sure you write the numbers in the correct order. The number you are subtracting should come after the subtraction sign. With practice, you'll be able to solve these problems quickly and easily. So what's next? Review what you've learned by doing the knowledge check. Then master what you've learned by doing the practice activity. In the next lesson, you'll learn about multiplication, which is a shortcut for repeated addition. I'll see you there. In this lesson, you'll learn some useful tips for doing multiplication. So let's get started. So what is multiplication? Multiplication is combining groups of things to find out how many there are in total. For example, here we have 1 times 3, which is like one group of 3 yellow straws. So 1 times 3 is 3. Then we have 2 times 4, which is like 2 groups of 4 blue straws. There are 8 blue straws in all, so 2 times 4 is 8. Then we have 3 times 3, which is like 3 groups of 3 green straws. Altogether, there are 9 green straws, so 3 times 3 is 9. Finally, we have 5 times 4, which is like 5 groups of 4 red straws. In total, there are 20 red straws, so 5 times 4 is 20. Multiplication is like repeated addition, or taking one group of things and then copying it a certain number of times to make a bigger group. Whether you're trying to figure out how many cookies you'll need to make for a party or how much money you'll save on a sale, multiplication can help you find the answers you need. Factors are the numbers that are multiplied together to get a product. For example, if we have the multiplication problem 4 times 5, we can think of it as asking, what is the product of 4 and 5? The factors are 4 and 5. And the product is the answer we get when we multiply them together. In this case, the product is 20. Now follow along as I solve this problem. What is 9 multiplied by 3? To find the answer to 9 times 3, I can skip count by 3 9 times. In this case, I can start with 3 and then keep adding 3. So that would be 3, 6, 9, 12, 15, 18, 21, 24, and 27. I can see that I've skip counted 9 times. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So the answer to 9 times 3 is 27. My answer is C. Now it's your turn to practice. Find the answer to 4 multiplied by 10 by skip counting. Pause the video, and when you found your answer, click play. What is 4 multiplied by 10? To find the answer to 4 times 10, you can skip count by 10 4 times. That would be 10, 20, 30, 40. So 4 times 10 is 40. The answer is D. Now follow along as I solve this problem. What is the product of 5 and 6? To find the product of 5 and 6, I multiply them together. To find the answer to 5 times 6, I can skip count by 5 6 times. That would look something like this. 5, 10, 15, 20, 25, and 30. So 5 times 6 equals 30. My answer is A. Now it's your turn to practice. What is the product of 7 and 5? Pause the video, and when you found your answer, click play. What is the product of 7 and 5? To find the product of 7 and 5, you multiply them together. You can find the answer to 7 times 5 by skip counting by 5 7 times, which would look something like this. 5, 10, 15, 20, 25, 30, 35. So 7 times 5 equals 35. The answer is C. Multiplication is a shortcut for repeated addition. Imagine you have a big box of colorful blocks, and you want to know how many blocks you have in total. You can count the blocks one by one, but what if you have a lot of blocks? That would take a long time. Instead, let's say you have 5 rows of blocks. And each row has 4 blocks. You can multiply 5 by 4. You get 20 blocks in total. So 5 times 4 is 20. But guess what? You can also multiply 4 by 5 and you will still get the same answer, which is 20. That's because when you multiply, the order doesn't matter. In other words, you can multiply in any order. It's like rearranging the blocks in a different way, but you still end up with the same total number. On the left side, we have 5 rows of 4 blocks. Which gives you a total of 20 blocks. And on the right side, we have 4 rows of 5 blocks. Which also gives you 20 blocks total. So 5 times 4 is equal to 4 times 5. Now follow along as I solve this problem. 3 times 7 is equal to which expression? Well, I know that I can multiply in any order. So I can say that 3 times 7 is equal to 7 times 3. I know this is true because 3 groups of 7 gives me 21. And 7 groups of 3 also gives me 21. And 21 is equal to 21. So my answer is C. Now it's your turn to practice. Find which expression is equal to 4 times 5. Pause the video, and when you found your answer, click play. 4 times 5 is equal to which expression? To figure this out, you can realize that 4 times 5 is equal to 5 times 4, because you can multiply numbers in any order and get the same result. You can check if this is true by realizing that 4 groups of 5 gives you 20. And 5 groups of 4 also gives you 20. So the answer is A. Now let's review. Multiplication is combining groups of things to find out how many there are in total. It's like repeated addition or taking one group of things and then copying it a certain number of times to make a bigger group. Factors are the numbers that are multiplied together to get a product. Multiplication is a really useful skill to have in everyday life because it can help you solve all kinds of problems. So what's next? Review what you've learned by doing the knowledge check. Then master what you've learned by doing the practice activity. In the next lesson, you'll learn some useful tips for solving word problems with multiplication. I'll see you there. In this lesson, you'll learn some useful tips for multiplying by hand. So let's get started. Step 1. Set up the problem. Write the numbers you want to multiply one below the other. Make sure the place values of the digits line up properly. Here we're multiplying 132 by 14. You can see here that we need to line up the ones place. The 2 ones is above the 4 ones. And we have to line up the tens place. The 3 tens is above the 110. The 100 is by itself. Step 2. Multiply digit by digit. Start with the rightmost digits of both numbers, the ones place. Multiply them together and write the answer below the line. If one number has more digits, go from right to left and multiply each digit by the other number. Here we start by multiplying the ones digits. 2 times 4 is 8. Step 3. Carry over if needed. Sometimes when we multiply, the answer might be 2 digits. If this happens, write down the rightmost digit and carry over the other digit to the next column. Here I have 4 times 3. 4 times 3 is 12, which is 2 and carry the 1. Step 4. Add the partial products. After multiplying all the digits, add up the answers to get the final answer. Write the total below the line. So here I need to multiply 4 times the 1, which gives me 4 times 1 is 4, plus the 1 that I carried over gives me a total of 5. Now I have to repeat the process, starting with the tens place. 1 times 2 is 2. But since I started with the tens place, I have to put my answer in the tens place. Next, I have to multiply the 1 times the 3, which gives me 3. And finally, I have to multiply the tens by the hundreds, which will give me thousands. 1 times 1 is 1, which is 1,000. If I want, I can put a placeholder 0 in the ones place when I add the partial products. So now I need to add up the partial products, starting with the ones place. 8 plus 0 is 8. 2 plus 2 is 4. 5 plus 3 is 8. And I'll bring down the 1,000. So my answer will be 1,848. Now follow along as I solve this problem. 23 times 5. To solve this problem, I need to line up my numbers based on their place value. So the 5 ones goes below the 3 ones. And then I multiply. 5 times 3 is 15. 5 and then carry the 1. And then I do 5 times 2 is 10, plus the 1 that I carried over gives me 11. So my answer is 115. Now it's your turn to practice. Solve 17 times 3 by hand, pause the video, and when you found your answer, click play. To solve 17 times 3, we need to line up the numbers vertically according to their place value, so the 3 ones is below the 7 ones. And then you multiply. 3 times 7 is 21. 1, carry 2. 3 times 1 is 3, plus 2 gives you 5. So the answer is 51. Now follow along as I solve this problem. 42 times 23. To solve this problem, I need to line up my numbers vertically so their place values are on top of each other. Here we have 3 times 2, which gives me 6. Then we have 3 times 4, gives me 12. Since now I'm starting with the tens place, I can put a placeholder 0 in the ones place. Then I have 2 times 2 gives me 4, and 2 times 4 gives me 8. Then I can add up my partial product starting with the ones place. 6 plus 0 is 6, 2 plus 4 is also 6, and 1 plus 8 is 9. So my answer is 966. Now it's your turn to practice. Solve the problem 56 times 14 by hand. Pause the video, and when you found your answer, click play. To solve 56 times 14, you need to line up your numbers vertically so that the place values line up. Then you can start multiplying by the ones place. 4 times 6 is 24, which is 4, carry 2. 4 times 5 is 20, plus the 2 that you carried over gives you 22. Then you start multiplying by the tens place, so you can put a placeholder 0 in the ones place. Then you have 1 times 6 is 6. and 1 times 5 is 5. Then you can add up your partial products, starting with the ones place. 4 plus 0 is 4, 2 plus 6 is 8, and 5 plus 2 is 7. The answer is 784. Now follow along as I solve this problem. 127 times 34. To solve this problem, I need to line up my numbers vertically so the place values line up. Then I can start multiplying by the ones place. Here we have 4 times 7, which is 28, which is 8, carry the 2. 4 times 2 is 8, plus the 2 that I just carried over is 10, which is 0, carry the 1. 4 times 1 is 4, plus the 1 that I just carried over is 5. Now I have to start multiplying by the tens place. So I can put a placeholder 0 in the ones place. Then I have 3 times 7 is 21, which is 1, and then carry the 2. 3 times 2 is 6, plus the 2 that I just carried over gives me 8. And then finally we have 3 times 1, which is 3. Then I can add up my partial products to get my final answer. 8 plus 0 is 8. 0 plus 1 is 1. 5 plus 8 is 13, which is 3. Carry the 1. And 3 plus 1 is 4. So my answer is 4,318. Now it's your turn to practice. Solve 248 times 56 by hand. Pause the video, and when you found your answer, click play. To solve 248 times 56, you need to line up your numbers vertically so the place values line up. Then you start multiplying by the ones place. Here we have 6 times 8, which is 48. So I do 8, carry the 4. Then you have 6 times 4, which is 24, plus the 4 you carried over gives you 28, which is 8, carry the 2. 6 times 2 is 12, plus the 2 you carried over is 14. Now you have to multiply by the tens place, so you can put a 0 in the ones place as a placeholder. Then we have 5 times 8 is 40, which is 0, carry the 4. 5 times 4 is 20, plus the 4 you carried over is 24, which is 4, carry the 2. And then you have 5 times 2 is 10, plus the 2 you carried over, which is 12. Then you can add up your partial products to get your final answer. 8 plus 0 is 8. 8 plus 0 is 8 again. 4 plus 4 is 8. 1 plus 2 is 3, and bring down the 1. So the answer is 13,888. So let's review. By following these steps and practicing regularly, you'll become better at multiplying numbers by hand. Take your time, keep the place values in mind, and check your work. With practice, you'll become more confident and skilled at multiplying numbers by hand. In this lesson, you'll learn how to use the TI-30X's calculator to multiply numbers easily. So let's get started. Follow along as I solve 6 times 3 using the calculator. I'll start by entering the first number, which is 6. Then I'm going to press the times or multiply key, which is on the right side of the calculator. Then I'll enter the second number, which is 3. To get my answer, I'll press the Enter button in the lower right corner. As you can see, the answer is 18. Now it's your turn to practice. Use the calculator to solve 9 times 7. Pause the video, and when you found your answer, click play. To find the answer to 9 times 7, start by entering the first number, 9. Then click the multiply key, followed by the second number, 7. To get your answer, press the Enter key. Your answer is 63. Now let's get some practice multiplying bigger numbers. Follow along as I solve 15 times 24. To find 15 times 24, I enter the first number, 15. Then the times key, followed by the second number, 24. To get my answer, I press the Enter key. The answer is 360. Now it's your turn to practice. Find the answer to 42 times 19 using your calculator. Pause the video, and when you found the answer, click play. To find the answer to 42 times 19, you start by entering the first number, which is 42. Then click the times or multiply key, followed by the second number, 19. To get your answer, press the Enter key. As you can see, the answer is 798. Using the TI-30X's calculator for multiplication makes it easy to find the product of numbers. By following the steps in this lesson, you can confidently use the calculator for multiplication problems. Keep practicing to improve your calculator skills. In this lesson, you'll learn some useful tips for solving word problems with multiplication. So let's get started. So how do you solve word problems with multiplication? You'll learn a simple way to solve these problems step by step. Whether you're trying to figure out how many items you have in total or finding the cost of multiple things, multiplication will help you. So let's get started and become awesome at solving multiplication word problems. Step 1. Read the problem. First, carefully read the problem and understand what it's asking. You need to pay attention to the information given, like the numbers and what you need to find out. Understanding what the problem is about will help you use multiplication correctly. Step 2. Find the numbers. Next, find the numbers mentioned in the problem. Look for words that show multiplication like times, each, or groups of. These words will help you know which numbers to multiply. Key words that signal multiplication in word problems include, but are not limited to, times, double or twice, triple, product, and of. Step 3. Set up the multiplication equation. Now, write the numbers in an equation. Remember, in multiplication, the order doesn't matter. You get the same answer even if you switch the numbers around. For example, 4 times 5 equals 20. 5 times 4 also equals 20. So 4 times 5 is equal to 5 times 4. Step 4. Multiply the numbers. Now it's time to do the multiplication. Use the numbers from your equation and multiply them together. Step 5. Understand the answer. After you multiply the numbers, make sure your answer matches what the problem is asking. Step 6. Check your answer. Lastly, check your work to make sure it's correct. Look at your multiplication again and make sure you did it right. Let's say you have 3 groups of apples and each group has 4 apples. To find out how many apples you have in total, you can multiply the number of groups by the number of apples in each group. So in this case, we have 3 groups of 4. So 3 times 4 is 12. So there are 12 apples total. Now follow along as I solve this problem. Let's say you want to buy some pencils, and each pencil costs $2. If you want to buy 5 pencils, you need to use multiplication to figure out how much money you'll need to spend. In this case, I'll multiply the number of pencils, which is 5, times the cost for each pencil, which is $2. 5 times 2 is 10. So my answer is $10. Now it's your turn to practice. Read the problem carefully, find the information you need, set up an equation, solve, and check your answer. Pause the video, and when you found your answer, click play. Jack has 5 toy cars, and each car has 4 wheels. How many wheels are there in total? Well, here you can see that you need to solve for the total number of cars. And it says here each car has 4 wheels. So to find the total number of wheels, you need to multiply the number of cars, which is 5, times the number of wheels that each car has, which is 4. Now 5 times 4 is 20. So the answer is 20 wheels. Now let's review. By following the steps of reading the problem, finding the numbers, setting up the multiplication equation, doing the multiplication, understanding the answer, and checking your work, you can solve multiplication word problems easily. Keywords that signal multiplication in word problems include, but are not limited to, times, double or twice, triple, product, and of. Practice these steps to become even better at solving word problems with multiplication. So what's next? Review what you've learned by doing the knowledge check. Then master what you've learned by doing the practice activity. In the next lesson, you'll learn some useful tips for doing division. I'll see you there. In this lesson, you'll learn some useful tips for doing division. So let's get started. So what is division? Division is splitting an amount or number into same-sized parts or groups. It's kind of like cutting a cake into slices, or filling boxes with the same number of chocolates. You can think of division as equal sharing. Division involves splitting a number into equal parts. Think of it like sharing with a group of people. If you have 12 pieces of candy to share equally among 3 friends, you would need to divide the 12 pieces of candy into 3 equal groups. This is the symbol for division, and it represents splitting a number into equal parts or groups. For example, 12 divided by 3 equals 4, means dividing 12 into 3 equal groups of 4. So if I have 12 candies and I divide them into 3 equal groups, you can see that each group has 4 pieces of candy. It's important to know what the numbers in a division problem represent. When we divide, there are 3 important terms to know. Dividend. This is the number we are dividing. In the candy example, the dividend is 12 pieces of candy. Next is divisor. This is the number we are dividing by. In the candy example, the divisor is 3 friends. Quotient. This is the answer we get when we divide the dividend by the divisor. In the candy example, the quotient is 4 pieces, because 12 divided by 3 equals 4. You can also think of division as repeated subtraction. In a division problem, you're trying to figure out how many times one number can go into another number. For example, if you have 10 apples and you want to divide them into groups of 2, you can ask, how many times does 2 go into 10? In this case, we can divide 10 by 2 5 times. Each time we divide, we are essentially taking away 2 apples from the total until we can no longer take away 2 without going below 0. In this example, 2 goes into 10 5 times, so 10 divided by 2 is 5. Each time I divide by 2, it's like taking away a group of 2. And I can do that a total of 1, 2, 3, 4, 5 times. so 2 goes into 10 5 times. Therefore, 10 divided by 2 equals 5. Sometimes when you divide, you end up with the remainder. For example, if you have 10 apples to share equally among 3 people, you would have 1 apple left over. You write this as 10 divided by 3 equals 3 remainder 1. So each person would get 3 apples with 1 apple left over. The R1 means there is 1 apple left over. You can see here that if I split 10 apples into 3 equal groups, 1, 2, 3, I can make 3 groups of 3 with a remainder of 1 apple. So I would write that as 3R1. When we divide numbers, we are trying to figure out how many groups we can make or how many things each person will get. Imagine we have 12 candies to share equally among 4 friends. We want to know how many candies each friend will get. If we divide 12 by 4, we find out that each friend will get 3 candies. That's because we can divide 12 candies into 4 equal groups, and each group will have 3 candies. But if we reverse the order and divide 4 by 12, things change. Now we are trying to divide 4 candies into 12 equal groups, or think of it like splitting 4 candies amongst 12 friends. Clearly this doesn't work because we don't have enough candies to make 12 equal groups. There's not enough candies to share amongst 12 people. So 12 divided by 4 does not equal 4 divided by 12. So when you divide numbers, the order of the numbers matters. The dividend, the number being divided, goes before the division sign, and the divisor, the number you're dividing by, goes after the division sign. You start with the dividend, then divide by the divisor, which will give you the quotient. Remember, when you divide, you need to keep the numbers in the correct order to know how many things each person will get or how many groups you can make. It's important to understand the relationship between multiplication and division. Division is the opposite or inverse of multiplication. So if you know that 2 times 4 equals 8, then you also know that 8 divided by 4 equals 2, and that 8 divided by 2 equals 4. So if you know your multiplication facts, then you know your division facts. If you have 15 stickers and you want to divide them equally among 3 friends, how many stickers will each friend get? To solve the problem, you need to divide the number of stickers by the number of friends. Since 3 times 5 equals 15, you know that 15 divided by 3 equals 5, so each friend will get 5 stickers. You can think of it like this. If I multiply 3 rows of stickers, and there are 5 stickers in each row, I'll get a total of 15 stickers. So if I take 15 stickers and divide them into 3 equal rows, each row will have 5 stickers in it. So 15 divided by 3 equals 5. Now follow along as I solve this problem. What is the quotient of 48 divided by 6? To figure this out, I can use my knowledge of multiplication facts. I know that 6 times 8 equals 48. That means 48 divided by 6 must equal 8. So my answer is B. Now it's your turn to practice. Use your knowledge of multiplication facts to find the result of dividing 45 by 5. Pause the video, and when you found your answer, click play. What is the result of dividing 45 by 5? To solve this problem, you would need to know that 5 times 9 equals 45. So 45 divided by 5 must equal 9. The answer is C. Now follow along as I solve this problem. What is the quotient and remainder of 27 divided by 4? To solve this problem, I can use my knowledge of multiplication facts. I know that 4 times 6 equals 24. To get my remainder, I can subtract 24 from the dividend, which is 27. When I subtract 24 from 27, I end up with 3. Therefore, my answer will be 6, remainder 3, which I can write as 6R3. My answer is A. Now it's your turn to practice. Use your knowledge of multiplication facts and subtraction to find the quotient and remainder of 36 divided by 7. Pause the video, and when you found your answer, click play. What is the quotient and remainder of 36 divided by 7? To solve this problem, you can realize that 7 times 5 is 35. To find the remainder, you would subtract 35 from the dividend, which is 36. 36 take away 35 is 1. So the answer is 5, remainder 1, which you can write as 5R1. The answer is B. Now let's review. Division is splitting an amount or number into same-sized parts or groups. A quotient is the answer to a division problem. Knowing your multiplication facts will help you solve division problems. When you divide numbers, the order of the numbers matters. Sometimes when you divide, you end up with the remainder. So what's next? Review what you've learned by doing the knowledge check. Then master what you've learned by doing the practice activity. In the next lesson, you'll learn some useful tips to solve word problems with division. I'll see you there. In this lesson, you'll learn some useful tips for dividing by hand. So let's get started. Step 1. Set up the problem. Normally, when we write a division problem, we start with the dividend, which is the number we're dividing up, then the division symbol, followed by the divisor, the number we're dividing by, equals the quotient, the answer to the division problem. For example, here we have 189 divided by 7 equals 27. To start long division or do division by hand, you need to set the problem up differently. Write the number you're dividing, the dividend, on the inside of the division symbol. Another way to represent division is with this symbol. As you can see, the dividend, 189, is inside of the division symbol. Then write the number you're dividing by, the divisor, on the outside and to the left of the division symbol. Here you can see that 7 is outside and to the left of the division symbol. Leave space for the answer or quotient above the division symbol. You can see here that the quotient, 27, is above the division symbol. Also leave space for a remainder, if there is one. Step 2. Divide and multiply. Look at the leftmost digit of the dividend. In this case, the 1, which is 100, is the leftmost digit and has the largest place value. Then ask yourself, how many times can the divisor go into this digit? Start with the largest possible number, and then write that number above the digit. Here we can ask, how many times does 7 go into 1? Well, 7 is bigger than 1, so it can't go into it. So we write a 0 above the 1. Then multiply the number by the divisor and write the answer below the dividend. So here we have 0 times 7 is 0, which I write below the 1. Step 3. Subtract. Subtract the answer you just wrote from the dividend. So here I would subtract 0 from 1 and then draw a line. Write the result below the line. 1 minus 0 is 1. If there are more digits in the dividend, bring down the next digit and continue. So I'll bring down the 8. Step 4. Repeat. Repeat steps 2 and 3 for the remaining digits of the dividend until you've gone through all the digits. So here I can ask myself, how many times does 7 go into 18? Well, I know that 7 times 2 is 14. So I can write 14 below the 18. And then I subtract. 18 minus 14 is 4. Then I bring down the 9. How many times does 7 go into 49? Well, I know 7 times 7 is 49. So I write the 7 above the 9 and then write 49 below. Then I subtract. I'm left with a remainder of 0. So my final answer is 27. Step 5. Quotient and remainder. Once you've gone through all the digits of the dividend, the number you wrote above the line is the quotient, or the answer. If there's a remainder, write it as quotient R remainder. In the previous example, 189 divided by 7 gave us 27, so 27 is the quotient, or the answer. If we divide 17 by 5, we'll get a remainder. 5 can't go into 1, so I write 0 above the 1. 0 times 5 is 0. I'll write that below the 1, and then subtract. 1 minus 0 is 1. Then I bring down the 7. Then I ask myself, how many times does 5 go into 17? Well, I know that 5 times 3 is 15, so I'll write 3 above the line, and then I'll write 15 below the 17. And then I subtract. 17 minus 15 is 2. Since 2 is less than 5, 2 is my remainder. I can represent my remainder as R2. So my final answer is 3 remainder 2. Now follow along as I divide 126 by 6. To solve this problem, I need to write the dividend, the number we're dividing up, inside the division symbol. And then I'll write the divisor, the number we're dividing by, on the outside and to the left of the division symbol. Then I need to ask myself, how many times does 6 go into 1, the leftmost digit of the dividend? Well, 6 is bigger than 1, so it can't go into it. So I'll write 0 above the 1. Now 0 times 6 is 0, so I'll subtract 0 from 1. 1 minus 0 is 1. Then I'll bring down the 2. How many times does 6 go into 12? Well, I know that 6 times 2 is 12, so I'll write 2 above the division symbol. 6 times 2 is 12, so I'll write 12 below, and then subtract. 12 minus 12 is 0. Then I'll bring down the 6. how many times does 6 go into 6? Well, 6 goes into 6 one time, so I'll write 1 above the division symbol. And 1 times 6 is 6. I'll write that below. And then I'll subtract. 6 minus 6 is 0, so I have no remainder. That means my final answer is 21. To check my answer, I can multiply the quotient, which is 21, by the divisor, which is 6. And if I'm correct, it should give me the dividend, 126. So 6 times 1 is 6, and 6 times 2 is 12. I multiplied, and 21 times 6 is 126, which means my answer is correct. Now it's your turn to practice. Using long division, divide 312 by 8. Pause the video, and when you found your answer, click play. To divide 312 by 8, you need to set up the problem. Start by writing the dividend, the number you're dividing up, inside the division symbol. Then write the divisor on the outside and to the left of the division symbol. Then you can ask, how many times does 8 go into the leftmost digit of the dividend, which is 3? Well, 8 is bigger than 3, so it can't go in. So you can write 0 above the 3. 0 times 8 is 0, so subtract that from 3. 3 minus 0 is 3. Bring down the 1. Ask yourself, how many times does 8 go into 31? Well, 8 times 3 is 24. So write 3 above the 1 and write 24 below the 31, and then subtract. To subtract 24 from 31, borrow from the tens place. So 3 tens becomes 2 tens, and the 10 becomes 10 ones. 10 ones plus 1 is 11. So then subtract 4 from 11, which is 7. And 2 take away 2 is 0. Then bring down the 2. Then ask yourself, how many times does 8 go into 72? Well, 8 times 9 is 72, so write 9 above the division symbol and 72 below, and then subtract, giving a remainder of 0. That means the final answer is 39. Now to check your work, you can multiply the quotient, which is 39, by the divisor, 8. And if you're correct, you should get the dividend, 312. So let's check. 8 times 9 is 72. Write 2 and then carry the 7. 8 times 3 is 24, plus 7 is going to be 31. So 39 times 8 is 312, which means the answer is correct. Now follow along as I solve this problem. Divide 217 by 9. To solve this problem with long division, I need to set up my problem. I'll start by writing the dividend, the number we're dividing up, inside the division symbol. And then I'll write the divisor, the number we're dividing by, on the outside and to the left of the division symbol. Then I can ask myself, how many times does 9 go into the leftmost digit of the dividend, which is 2? Well, 9 is bigger than 2, so it can't go in. So I'll write 0 above the division symbol. 0 times 9 is 0, so I'll write 0 below the 2 and subtract. 2 minus 0 is 2. Then I'll bring down the 1. How many times does 9 go into 21? Well, I know that 9 times 2 is 18. So I'll write 2 above the division symbol, and then I'll write 18 below the 21, and then I'll subtract. To subtract 18 from 21, I need to borrow from the tens place. So the 2 tens becomes 1 10, and the 110 is 10 ones, which I'll add to my 1, which gives me 11 ones. 11 minus 8 is 3, and 1 minus 1 is 0. Then I'll bring down the 7. Then I'll ask myself, how many times does 9 go into 37? Well, I know that 9 times 4 is 36, so I'll write 4 above the division symbol and 36 below the 37, and then I'll subtract. 7 take away 6 is 1, and 3 take away 3 is 0. Since 1 is less than 9, 1 is my remainder. To show my remainder in my answer, I can write R1. So my final answer is 24 remainder 1. Now to check my answer, I'll start by multiplying 24 by 9. 9 times 4 is 36, which is 6, carry the 3. 9 times 2 is 18, plus 3 is 21. I can see here that my answer was 216, which is 1 less than the dividend 217. But that's okay because my remainder 1 means if I add 1, the remainder, I should end up with my dividend, which is 217. So that means my answer is correct. Now it's your turn to practice. Divide 369 by 8 using long division. Pause the video, and when you found your answer, click play. To divide 369 by 8 using long division, you need to start by setting up the problem. First, write the dividend, the number you're dividing up, inside the division symbol. Then, write the divisor, the number you're dividing by, outside and to the left of the division symbol. Then you can ask yourself, how many times does 8 go into the leftmost digit of the dividend, which is 3? Well, 8 is bigger than 3, so it can't go in. So write a 0 above the 3. 0 times 8 is 0, so subtract that from 3, which gives you 3. Then bring down the 6. Then ask yourself, how many times does 8 go into 36? Well, 8 times 4 is 32. So write 4 above the division symbol and 32 below the 36. Then subtract. 6 minus 2 is 4, and 3 minus 3 is 0. Then bring down the 9. Then you can ask yourself, how many times does 8 go into 49? Well, 8 times 6 is 48, so write 6 above the division symbol and 48 below the 49, and then subtract. 9 minus 8 is 1, and 4 minus 4 is 0. Since 1 is less than 8, 1 is your remainder. To show your remainder in your answer, you can write R1. So the final answer is 46 remainder 1. To check your answer, you can multiply 46 times 8 and then add your remainder to get your dividend. 8 times 6 is 48, which is 8, carry the 4. 8 times 4 is 32, plus 4 is 36. Then you need to add the remainder, which is 1. That gives you 369, which is the dividend. That means your answer is correct. Now let's review. To start long division, or division by hand, write the number you're dividing, the dividend, on the inside of the division symbol. Then write the number you're dividing by, the divisor, on the outside and to the left of the division symbol. In long division, the quotient, which goes above the division symbol, represents the whole number part of the division result, while the remainder represents the leftover amount. Take your time. Keep the place values in mind and check your work. By following these steps and practicing regularly, you'll become better at dividing numbers by hand. In this lesson, you'll learn some useful tips for dividing with the TI-30XS calculator. So let's get started. Now follow along as I solve 63 divided by 7. The first step is to type the number you want to divide, called the dividend. In this case, the dividend is 63. Then press the division key, which is in the upper right side of the calculator. Then enter the divisor, the number you are dividing by. In this case, the divisor is 7. Then, to get your answer, the quotient, press Enter in the lower right corner. As you can see here, the answer is 9. Now it's your turn to practice. Use the calculator to find the answer to 84 divided by 4. Pause the video, and when you found your answer, click play. To solve 84 divided by 4, first enter the dividend, which is 84. Then press the divide key. Then enter the divisor, which is 4. Then press Enter to get your quotient. The answer is 21. Now follow along as I solve the problem 295 divided by 5. I'll first enter the dividend, 295. Then I'll press the division key, followed by the divisor, 5. Then the Enter key. The quotient, my answer, is 59. Now it's your turn to practice. Solve 486 divided by 3. Pause the video, and when you found your answer, click play. To find the answer to 486 divided by 3, first enter the dividend, 486. Then press the divide key, followed by the divisor, 3. Then press Enter to get your quotient. The answer is 162. Using the TI-30XS calculator for division is a simple and convenient way to solve division problems. By following the steps you've learned, you can easily get the correct answers for division calculations. Just remember to enter the numbers correctly. In this lesson, you'll learn some useful tips for solving word problems with division. So let's get started. You'll learn a simple way to solve these problems step by step. Division helps us share things equally, or figure out how many groups we can make. Let's get started and become great at solving division word problems. Step 1. Read the problem. First, carefully read the problem and understand what it's asking. You need to pay attention to the information given, like the numbers and what you need to find out. Look for keywords like share, divide, or group that often signal division in word problems. Others include, but are not limited to, divided by, quotient, split equally, shared among, ratio, per, or each. Understanding what the problem is about will help you use division correctly. Step 2. Identify the numbers. Next, find the numbers mentioned in the problem. Look for the total quantity, or the dividend, and the number of groups or parts, the divisor. Step 3. Set up the division equation and divide. Now it's time to set up your division equation and then divide. If you're using a calculator, you'll first type in your dividend, or the amount you're dividing up, followed by the division sign, then the divisor, or the number you're dividing by, to get the quotient, the answer. For example, we have 189 divided by 7, which equals 27. If you're solving by hand, you want to write the dividend inside of the division symbol. The divisor goes out and to the left of the division symbol, and the quotient goes on top of the division symbol. So here we would have 189 inside the division symbol, 7 would be on the outside and to the left, and 27 would be on top. Step 4. Understand the answer. After you divide, now it's time to understand what the answer means. What does it tell you? It could be the number in each group or the number of groups you made. You need to make sure your answer matches what the problem is asking. Try explaining your solution in a simple sentence that makes sense. Step 5. Check your answer. Lastly, check your work to make sure it's correct. Try multiplying your answer by the number of groups to see if you get back to the total quantity. Checking your work helps you catch any mistakes and feel confident about your solution. Now follow along as I solve this problem. Mrs. Smith baked 36 cookies for her class. If she wants to share them equally among her 12 students, how many cookies will each student get? While reading carefully, I can see that we need to solve for how many cookies each student will get, which is a clue I might need to use division. It also says here that she wants to share them equally, which is another sign that I need to divide. Next, I need to find the dividend, or the total quantity, which in this case is 36. Next, I need to look for the divisor, or the number I'm dividing by, which in this case is 12. Now to solve this by hand, I can write the starting quantity inside of the division symbol, and 12 will go on the outside. Now 12 doesn't go into 3, but 12 goes into 36 3 times, because 3 times 12 is 36, with a remainder of 0. So my answer is each student will get 3 cookies. Now to check my work, I can multiply the divisor by the quotient, and that should give me the dividend. So if I do 12 times 3, I should get 36. Now 3 times 2 is 6, and 3 times 1 is 3. So 12 times 3 is 36. So my answer is correct. Now it's your turn to practice. Read the problem carefully, look for keywords, write the division equation, solve and check your work. Pause the video, and when you found your answer, click play. A family bought a pack of 24 juice boxes. If they want to share them equally among their 4 kids, how many juice boxes will each kid get? Well, here you need to solve for how many juice boxes each kid will get, which is a clue you might need to divide. You also can see that the family wants to share them equally, which is another clue you need to divide. Next, you need to identify the total quantity, which is 24. Then you need to identify the number of groups you are dividing by, in this case, 4. To find 24 divided by 4, ask yourself, how many times does 4 go into 24? Now 4 times 6 is 24, so there's a remainder of 0. The answer is 6 juice boxes. Now to check your work, you can multiply 4 by 6, which should give you 24, and it does. So the answer is correct. Now follow along as I solve this problem. There are 27 candies to be shared equally among 5 friends. How many candies will each friend get? And how many candies will be left over? Here we need to solve for how many candies each friend will get. And we know they're going to be shared equally. I know I'm starting with 27 candies, and I'm dividing them equally amongst 5 friends. Now, how many times does 5 go into 27? Well, I know that 5 times 5 is 25, which gives me a remainder of 2. This means that each friend will get 5 candies with 2 left over. Now to check my work, I can do 5 times 5, which is 25, and then add the 2 remainder, which gives me 27, which is the total quantity. So my answer is correct. Now it's your turn to practice. Read the problem carefully and then solve. Pause the video, and when you found your answer, click play. A farmer has 74 apples to distribute equally among 8 baskets. How many apples will be in each basket, and how many apples will be left over? To solve this problem, you can see that each and distributed equally is a clue that you need to use division. So you're starting with 74 apples, and you're sharing them equally amongst 8 baskets. So now you have to figure out how many times does 8 go into 74? Well, 8 times 9 is 72, which gives you a remainder of 2. So your answer is 9 apples in each basket with 2 left over. Now to check your work, you can multiply 9 times 8, which is 72, and then add the 2 left over, which gives you 74, which is the total quantity. So the answer is correct. Now let's review. By following the steps of reading the problem carefully, finding the numbers involved, setting up the division equation, doing the division, understanding the answer, and checking your work, you can solve division word problems easily. Keywords that signal division in word problems include, but are not limited to, shared equally, split equally, per, or each. Practice these steps to become even better at solving word problems with division. So what's next? Review what you've learned by doing the knowledge check. Then master what you've learned by doing the practice activity. In the next lesson, you'll learn a step-by-step approach to make solving multi-step word problems easy. I'll see you there. In this lesson, you'll learn how to solve multi-step word problems by breaking them down into smaller parts. So let's get started. Multi-step word problems might seem hard, but with the simple step-by-step approach, you can solve them easily. Step 1. Read the problem carefully. Start by reading the problem slowly and carefully. Look for important keywords and numbers. Make sure you understand what you need to solve for before moving on. Step 2. Figure out what operations to use and solve. Identify keywords to help you decide if you're dealing with adding, subtracting, multiplying, or dividing things. Remember, with multi-step problems, you'll need to perform more than one math operation. Then, start solving the problem step by step. Step 3. Check your answer. Once you have an answer, double-check to make sure it's correct. Look back at the original problem and see if your answer makes sense. Also, go over your calculations to avoid any mistakes. Now let's get some practice. Follow along as I solve this problem. Lisa has $50. She spends $12 on a new book, and then receives $20 as a birthday gift. How much money does Lisa have now? In this problem, I need to solve for how much money she has now. I can see here that Lisa starts with $50. And then she spends $12. Spending money means you're losing money. That's like subtraction. So I'll subtract 12 from 50. I can't subtract 2 from 0, so I need to borrow from the tens place. So the 5 tens becomes 4 tens, and the 1 10 becomes 10 ones. 10 minus 2 is 8, and 4 minus 1 is 3. After buying her book, she has $38. But then she receives $20. Receiving money means she's getting more money. That's like addition. So I'll add $20 to 38. 8 plus 0 is 8, and 3 plus 2 is 5. So Lisa ends up with $58. To solve this problem, I first had to subtract and then add. Now it's your turn to practice. Read the problem carefully, then solve. Pause the video and when you found your answer, click play. A store has 100 shirts in stock. They sell 30 shirts and then receive a shipment of 50 more shirts. How many shirts are in stock now? In this problem, you need to find how many shirts they have in stock now. You can see here that the store starts with 100 shirts in stock. And then they sell 30 shirts. Selling shirts is like taking away shirts. That's like subtraction. So you'll subtract 30 from 100. In this case, you need to borrow from the hundreds place. And 100 is really 10 tens. 0 take away 0 is 0. And 10 minus 3 is 7. So after selling the shirts, they have 70 shirts in stock. But then they receive a shipment of 50 more shirts. Receiving more shirts is like adding shirts. So add 50 to 70. 0 plus 0 is 0, and 7 plus 5 is 12. That means the store has 120 shirts in stock. To solve this problem, you had to subtract and then add. Now follow along as I solve this problem. There are 4 boxes of cookies, and each box contains 12 cookies. There are also 2 bags of candy, and each bag contains 8 pieces of candy. How many treats are there in total? To solve this problem, I need to find how many treats there are in total. In total means I'll probably need to add. It says here that there are 4 boxes of cookies, and each box contains 12 cookies. Each is a signal that I might need to multiply. So in this case, I'll multiply the number of cookies times the number of boxes. 2 times 4 is 8, and 4 times 1 is 4. That means I have 48 cookies. Then it says there are also 2 bags of candy, and each bag contains 8 pieces of candy. Once again, each signals that I need to multiply. I'll multiply the bags times the number of candies. 2 times 8 is 16. So there are 16 candies. Now to find the total number of treats, I need to add the cookies and the candies together. 48 plus 16. 8 plus 6 is 14. 4, carry the 1. 4 plus 1 is 5, plus the 1 that I carried over gives me 6. So there are a total of 64 treats. To solve this problem, I had to multiply and then add. Now it's your turn to practice. Read the problem carefully and solve. Pause the video, and when you found your answer, click play. John bought 5 packs of markers, and each pack contained 6 markers. He also bought 3 packs of colored pencils, and each pack contained 10 colored pencils. How many art supplies did John buy in total? In this problem, you need to find how many art supplies John bought in all or in total. You can see here that John bought 5 packs of markers, and each pack contained 6 markers. In this case, each signals that you need to multiply the number of packs times the number of markers in each pack. 5 times 6 is 30. So John has 30 markers. He also bought 3 packs of colored pencils, and each pack contained 10 colored pencils. Multiply the number of colored pencils in each pack times the number of packs. 3 times 0 is 0, and 3 times 1 is 3. So 10 times 3 is 30. There are 30 colored pencils. In this problem, you need to solve for the total number of art supplies. So you need to add the markers and the colored pencils together. That is 30 plus 30. 0 plus 0 is 0, and 3 plus 3 is 6. So there are 60 art supplies in total. To solve this problem, you had to multiply and then add. Now follow along as I solve this problem. Tom is organizing a charity event and has received a total of 100 tickets to sell. He decides to keep 20 tickets to himself. Then Tom wants to distribute the remaining tickets equally among 5 volunteers. How many tickets will each volunteer receive? In this problem, I need to solve for how many tickets each volunteer will receive. Each can mean multiply or divide. It says here that Tom is organizing a charity event and has received a total of 100 tickets to sell. So that means he has 100 tickets to start with. And then he decides to keep 20 tickets to himself. Since he's keeping the tickets and not giving them away, I need to subtract 20 from 100. Here I need to borrow from 100. And the 100 is really 10 tens. 0 minus 0 is 0, and 10 minus 2 is 8. So now Tom only has 80 tickets to give away to the volunteers. Because he wants to distribute the remaining tickets equally among 5 volunteers, that means I need to divide 80 by 5. To figure out 80 divided by 5, I need to ask myself, how many times does 5 go into the leftmost digit of the dividend, which is 8? Well, 5 goes into 8 one time. 1 times 5 is 5. I'll subtract 5 from the 8, which gives me 3, and then I'll bring down the 0. How many times does 5 go into 30? Well, 5 times 6 is 30. So I'll put 6 above the division symbol and I'll subtract 30 from below. 0 minus 0 is 0 and 3 minus 3 is 0. So I have no tickets remaining. That means that each volunteer will receive 16 tickets. To solve this problem, I first had to subtract and then divide. Now it's your turn to practice. Read the problem carefully and solve. Pause the video, and when you found your answer, click play. Amy has a bag of candies containing 96 pieces. She decides to keep 24 pieces for herself. Amy then wants to distribute the remaining candies equally among her 8 friends. How many candies will each friend receive? To solve this problem, you need to find how many candies each friend will receive. Each could signal multiplication or division. You can see here that Amy starts with 96 pieces of candy. And she decides to keep 24 pieces for herself. Since she's keeping 24 pieces and not giving them away, you need to subtract 24 from 96. 6 minus 4 is 2, and 9 minus 2 is 7. That means Amy has 72 pieces of candy left. Amy wants to distribute the remaining candies equally among her 8 friends. Since she wants to distribute the candies equally, you need to divide by the number of friends, which is 8. To find 72 divided by 8, you need to ask yourself, how many times does 8 go into 7? Well, 8 is bigger than 7, so it can't. So put a 0 above the 7. 0 times 8 is 0, so subtract 0 from 7, which is 7. Then bring down the 2. Then ask yourself, how many times is 8 going to 72? Well, 8 times 9 is 72. Put 9 above, subtract 72 from the bottom. 2 minus 2 is 0, and 7 take away 7 is 0. So there are no candies remaining, and each friend will receive 9 candies. To solve this problem, you had to subtract and then divide. Now follow along as I solve this problem. A farmer has a rectangular field that measures 40 meters in length and 20 meters in width. The farmer wants to divide the field into smaller square plots with equal dimensions. If each square plot has an area of 100 square meters, how many square plots can the farmer create? To solve this problem, I need to solve for how many square plots the farmer can create. I can see here that the rectangular field measures 40 meters long and 20 meters wide. To find the area of the rectangular field, I need to multiply the length, which is 40 meters, by the width, which is 20 meters. So the size or area of the field is 40 times 20. 0 times 0 is 0, and 0 times 4 is also 0. I'll put a placeholder 0, and then I'll multiply 2 times 0 is 0, and 2 times 4 is 8. And then I'll add the partial products. 0 plus 0 is 0, and 0 plus 0 is 0 again, and then bring down the 8. So the area of the field is 800 square meters. Then it says the farmer wants to divide the field into smaller plots, and each square plot has an area of 100 square meters. So in this case, I need to divide the 800 by 100. To find 800 divided by 100, I can ask myself, how many times does 100 go into 800? Well, I know that 8 times 100 equals 800. Which means I have no remainder. So that means the farmer can make 8 smaller plots. To solve this problem, I first multiplied, and then I divided. Now it's your turn to practice. Read the problem carefully and solve. Pause the video, and when you found your answer, click play. A teacher has a rectangular bulletin board with a length of 80 inches and a width of 50 inches. The teacher wants to divide the bulletin board into square sections of equal size. If each square section has an area of 200 square inches, how many square sections can the teacher create? To solve this problem, you need to find how many square sections the teacher can create from the bulletin board. You can see here that the teacher has a rectangular bulletin board with a length of 80 inches and a width of 50 inches. To find the area of the bulletin board, or how big it is, multiply the length, which is 80 inches, times the width, which is 50 inches. Zero times 0 is 0, and 0 times 8 is 0. Put a placeholder 0 in the ones place, and then multiply 5 times 0 is 0, and 5 times 8 is 40. Then add up your partial products. 0 plus 0 is 0, 0 plus 0 is 0 again. Bring down the 0 and the 4. So the area of the bulletin board is 4,000 square inches. It also says that the teacher wants to divide the bulletin board into square sections of equal size, and each square section has an area of 200 square inches. Since the teacher wants to divide the bulletin board into smaller sections, you need to divide the 4,000 by 200. To divide 4,000 by 200, start by dividing into the leftmost digit, which is 4. 200 can't go into 4. Put a 0 above. 200 can't go into 40 either. 200 can go into 400 2 times, because 2 times 200 is 400. Subtract 400 from itself, which gives 0. Then bring down the 0. 200 can't go into 0, so put a 0 in the ones place, and then subtract. You're left with the remainder of 0. So the teacher can divide the bulletin board into 20 square sections. You can solve this problem by first multiplying and then dividing. Now follow along as I solve this problem. A company produces 600 glass bottles in 4 hours. If they continue working at the same rate, how many glass bottles will they produce in 9 hours? To solve this problem, I need to figure out how many glass bottles they'll produce in 9 hours. To figure that out, I need to know how many glass bottles they produce in 1 hour. And I can see here that they produce 600 glass bottles in 4 hours. To find out how many glasses they make in 1 hour, I can divide the 600 by 4. Four goes into 6 one time. 4 times 1 is 4, and then subtract the 4, which gives me 2. I'll bring down the 0. 4 goes into 20 5 times, because 5 times 4 is 20. And then I'll subtract and bring down the 0. 4 can't go into 0, so I'll put a 0 above, which leaves me with the remainder of 0. That means the company produces 150 glass bottles in 1 hour. Since I want to find out how many glasses they'll produce in 9 hours, I would multiply the 150 times 9. 9 times 0 is 0. 9 times 5 is 45, so I'll write 5 and carry the 4. 9 times 1 is 9, plus 4 is 13. So the answer is 1,350 glass bottles. To solve this problem, I first divided and then I multiplied. Now it's your turn to practice. Read the problem carefully and then solve. Pause the video, and when you found your answer, click play. A bakery produces 120 loaves of bread in 2 hours. If they continue working at the same rate, how many loaves of bread will they produce in 6 hours? You need to find out how many loaves of bread they'll produce in 6 hours. So first, you need to find out how many loaves of bread they make in 1 hour. You can see here that they produce 120 loaves in 2 hours. So to find the number of loaves they make in 1 hour, you would divide 120 by 2. Two can't go into 1, so put 0 above the 1. 2 can go into 12 6 times, because 6 times 2 is 12. And then subtract. Bring down the 0. 2 can't go into 0, so write 0 in the ones place. 0 times 2 is 0, so subtract 0 from 0, which leaves you with no remainder. So that means they produce 60 loaves of bread in 1 hour. So to find the number of loaves they produce in 6 hours, you would multiply the 60 by 6. 6 times 0 is 0, and 6 times 6 is 36. That means the bakery produces 360 loaves in 6 hours. To solve this problem, you first divided and then you multiplied. Now let's review. Solving multi-step word problems can be made easy by following these simple steps. Remember to read the problem carefully, figure out the problem type, solve step by step, and check your answer. With practice, you'll become more confident in tackling multi-step word problems. So what's next? Review what you've learned by doing the knowledge check. Then master what you've learned by doing the practice activity. Finally, make sure you understand everything about basic operations by completing the unit test. Do your best, you got this. In this lesson, you'll learn how to find the multiples of a number. So let's get started. So what is a multiple? A multiple is the number you get when you multiply a whole number by another whole number. For example, to find the first 5 multiples of 3, just multiply 3 by the numbers 1, 2, 3, 4, and 5. So the first 5 multiples of 3 are 3, 6, 9, 12, 15. You get these multiples by multiplying 3 times 1, which is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 equals 12, and 3 times 5 gives you 15. To find a multiple of a number, multiply that number by another whole number. For example, to find the multiples of 4, you can multiply 4 by 1, 2, 3, and so on. The first 5 multiples of 4 are 4, 8, 12, 16, 20. You get the multiples of 4 by multiplying 4 times 1 equals 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, 4 times 5 is 20, and you could keep going and get more multiples by multiplying 4 by 6, 7, 8, and so on. Since multiplication is repeated addition, another way to find multiples is to skip count or start with that number and keep adding the number until you get the multiples you want. For example, to find the multiples of 4, you can start with 4 and keep adding 4. Here you would start with 4, and then add 4 to give you 8. Then add 4 to 8 to get 12, and then add 4 to 12 to get 16, and then add 4 to 16 to get 20. So the first 5 multiples of 4 are 4, 8, 12, 16, and 20. Follow along as I solve this problem. What are the first 7 multiples of 5? To find the first 7 multiples of 5, I can skip count by 5, starting with the number 5. 5 plus 5 is 10. 10 plus 5 is 15. 15 plus 5 is 20. 20 plus 5 is 25. 25 plus 5 is 30. And 30 plus 5 is 35. I can stop at 35 because I know that 5 times 1 is 5, 5 times 2 is 10, 5 times 3 is 15, 5 times 4 is 20, 5 times 5 is 25, 5 times 6 is 30, and 5 times 7 is 35. So my answer is B. Now it's your turn to practice. Find the first 6 multiples of 9 by skip counting by 9. Pause the video, and when you found your answer, click play. What are the first 6 multiples of 9? To find the first 6 multiples of 9, you would start with 9 and then skip count by 9. 9 plus 9 is 18. 18 plus 9 is 27. 27 plus 9 is 36. 36 plus 9 is 45. And 45 plus 9 is 54. You can stop there because 9 times 1 is 9. 9 times 2 is 18. 9 times 3 is 27. 9 times 4 is 36. 9 times 5 is 45. And 9 times 6 is 54. So the answer is A. Follow along as I solve this problem. What is the fifth multiple of 5? To find the fifth multiple of 5, I can multiply 5 by 5. 5 times 5 is 25. So 25 is the fifth multiple of 5. My answer is D. Now it's your turn to practice. Find the sixth multiple of 3 by multiplying. Pause the video, and when you found your answer, click play. What is the sixth multiple of 3? To find the sixth multiple of 3, you can multiply 3 by 6. 3 times 6 is 18. So the sixth multiple of 3 is 18. The answer is B. To determine if a number is a multiple of another number, check if it can be divided by the other number without any remainder. For example, to determine if a number is a multiple of 5, check if it can be divided by 5 without any remainder. For instance, 15 divided by 5 is 3 with no remainder, so 15 is a multiple of 5. Now follow along as I solve this problem. Which of the following numbers is a multiple of 7? I'll try 15 first. 15 divided by 7 equals 2 remainder 1. So 15 is not a multiple of 7 because of the remainder. 30 divided by 7 equals 4 remainder 2. Since I have a remainder of 2, 30 is not a multiple of 7. 25 divided by 7 equals 3 remainder 4. Since there's a remainder of 4, 25 is not a multiple of 7. Let me try 21. 21 divided by 7 is 3 with no remainder, because 7 times 3 is 21. So 21 is a multiple of 7. My answer is D. Now it's your turn to practice. Find which of the following numbers is a multiple of 9 by finding the number that can be divided by 9 without a remainder. Pause the video, and when you found your answer, click play. Which of the following numbers is a multiple of 9? 37 divided by 9 equals 4 remainder 1. So 37 is not a multiple of 9. 28 divided by 9 is 3 remainder 1. So 28 is not a multiple of 9. 54 divided by 9 is 6 with no remainder because 9 times 6 is 54. So 54 is a multiple of 9. The answer is C. Now follow along as I solve this problem. Which of the following numbers is not a multiple of 3? Well, let me divide the numbers by 3. 15 divided by 3 is 5 with no remainder. So 15 is a multiple of 3. 21 divided by 3 is 7 with no remainder. So 21 is a multiple of 3. 28 divided by 3 equals 9 remainder 1. So 28 is not a multiple of 3 because I have a remainder 1. So my answer is C. Now it's your turn to practice. Find the number that is not a multiple of 6. Pause the video, and when you found your answer, click play. Which of the following numbers is not a multiple of 6? First, divide 12 by 6. 12 divided by 6 is 2 with no remainder, so 12 is a multiple of 6. 21 divided by 6 equals 3, remainder 3. Since you got a remainder of 3, 21 is not a multiple of 6. So the answer is B. Now let's review. A multiple is the number you get when you multiply a whole number by another whole number. To find the multiples of a number, you can start with that number and keep adding it until you get the multiple you want. To find if a number is a multiple of another number, check if it can be divided by the other number without any remainder. Multiples are useful in many areas of math, such as adding or subtracting fractions, simplifying expressions, or solving equations. So what's next? Review what you've learned by doing the knowledge check. Then master what you've learned by doing the practice activity. In the next lesson, you'll learn how to find the least common multiple of 2 or more numbers. I'll see you there. In this lesson, you'll learn a step-by-step approach for finding the least common multiple of 2 or more numbers. So let's get started. So what is a least common multiple? The least common multiple is the smallest number that is a multiple of 2 or more numbers. For example, the least common multiple of 3 and 5 is 15. You can see here that if you skip count by 3, you end up with 3, 6, 9, 12, 15. And if you skip count by 5, you end up with 5, 10, 15. So you can see here that the least common multiple of 3 and 5 is 15. Here's a step-by-step approach for finding the least common multiple of 2 or more numbers. Step 1. Write down the numbers. Let's say you want to find the least common multiple, or LCM, of 4 and 6. Start by writing down both of these numbers, one on top of the other. Step 2. List out the multiples of each number. Start by listing out the multiples of the first number, in this case 4. The multiples of 4 are 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, and so on. Next, list out the multiples of the second number, in this case 6. The multiples of 6 are 6, 12, 18, 24, 30, 36, 42, 48, and so on. Step 3. Find the smallest multiple that the two lists have in common. Look at the two lists of multiples and find the smallest multiple that they have in common. In this case, the smallest multiple that both 4 and 6 share is 12. You can stop listing the multiples once you find the least common multiple. So in this case, after you list the first 3 multiples of 4, 4, 8, 12, and the first 2 multiples of 6, 6 and 12, you can stop. No need to keep going beyond that. Step 4. Write the final answer. Write down the smallest multiple that both numbers share as the least common multiple, or LCM, of the two numbers. In this case, the least common multiple of 4 and 6 is 12. Now follow along as I solve this problem. Find the least common multiple, or LCM, of 12 and 15. I'll start by writing down the two numbers, one on top of the other. And then I'll list the multiples of the first number, 12. I can skip count by 12, which is 12 plus 12 is 24, plus 12 is 36, plus 12 is 48, plus 12 is 60. Now I'll list the multiples of 15. 15 plus 15 is 30. 30 plus 15 is 45. And 45 plus 15 is 60. I can stop there at 60 because 60 is the smallest multiple that's shared by 12 and 15. So therefore, 60 must be the least common multiple. So my answer is B. Now it's your turn to practice. Find the least common multiple of 6 and 8 by listing out their multiples until you find the smallest multiple they have in common. Pause the video, and when you found your answer, click play. To find the least common multiple of 6 and 8, start by writing the numbers one on top of the other. Start by listing the first few multiples of 6. 6 plus 6 is 12. 12 plus 6 is 18. And 18 plus 6 is 24. Now list the first few multiples of 8 until you find the smallest multiple they have in common. 8 plus 8 is 16, and 16 plus 8 is 24. So you can stop there, because 24 is the smallest multiple they have in common. The least common multiple of 6 and 8 is D, 24. Now let's review. The least common multiple, or LCM, is the smallest number that is a multiple of 2 or more numbers. List the multiples of each number and find the smallest multiple that they have in common. Finding the least common multiple is useful when adding or subtracting fractions. So what's next? Review what you learned by doing the knowledge check. Then master what you learned by doing the practice activity. In the next lesson, you'll learn how to use the least common multiple to solve real-life problems. I'll see you there. In this lesson, you'll learn how to solve word problems by finding the least common multiple. So let's get started. The least common multiple, or LCM, is the smallest number that is a multiple of 2 or more numbers. It is helpful when dealing with problems that involve finding the smallest common unit or time interval. Let's explore the steps to solve word problems using the least common multiple. Step 1. Read and understand the problem. The first step is to read and understand the problem carefully. Identify the numbers that you need to find the least common multiple for. These numbers will be given in the problem or can be understood from the situation. Step 2. List the multiples of each number and find the least common multiple. Next, make a list of the multiples of each number. Look at the multiples you listed and find the smallest number that appears in both lists. This number will be the least common multiple of the given numbers. In this example, the least common multiple of 4 and 6 is 12. Step 3. Solve the problem and check your answer. Once you find the least common multiple, you can use it to solve the word problem. It's important to check your answer to make sure it's correct and makes sense in the context of the problem. Now follow along as I solve this problem. Emily is training for a triathlon. She swims every 4 days, bikes every 6 days, and runs every 9 days. If Emily wants to swim, bike, and run on the same day, what is the smallest number of days she needs to wait before she can do all 3 activities on the same day again? In this problem, I need to solve for the smallest number of days that she needs to wait to do all 3 activities on the same day again. This is a hint that I need to find the least common multiple of the numbers. The next step is to identify the numbers that we need to find the least common multiple for. In this case, it says that she swims every 4 days. So I'll write 4. And bikes every 6 days. I'll write 6 below that. And she runs every 9 days. Next, I need to list the multiples of these 3 numbers until I find the smallest multiple they have in common. The multiples of 4 are 4, 8, 12, 16, 20, 24, 28, 32, and 36. The multiples of 6 are 6, 12, 18, 24, 30, and 36. And the multiples of 9 are 9, 18, 27, and 36. I can stop here at 36 because I can see that 36 is the smallest multiple that all 3 numbers have in common. So 36 is the least common multiple of 4, 6, and 9. That means it'll be 36 days until Emily does all 3 activities on the same day again. Now it's your turn to practice. Read the word problem carefully and find the least common multiple to find the smallest number of days that Alex needs to wait to do both activities on the same day again. Pause the video, and when you found your answer, click play. Alex loves to swim and bike. He swims every 6 days and bikes every 8 days. If Alex wants to swim and bike on the same day, what is the smallest number of days he needs to wait before he can do both activities on the same day again? In this problem, you need to find the smallest number of days that he needs to wait before he can do both activities on the same day again. That's a clue that you need to find the least common multiple of the numbers in the problem. In this problem, you need to find the least common multiple of 6 and 8 because he swims every 6 days and bikes every 8 days. Next, list the multiples of 6. 6, 12, 18, 24. Then list the multiples of 8. 8, 16, 24. You can stop at 24 because 24 is the smallest multiple that both 6 and 8 have in common. So the least common multiple of 6 and 8 is 24, which means Alex needs to wait 24 days before he can do both activities again on the same day. Now let's review. The least common multiple, or LCM, is the smallest number that is a multiple of 2 or more numbers. It is helpful when dealing with problems that involve finding the smallest common unit or time interval. Solving problems using the least common multiple involves identifying the numbers involved, listing their multiples, finding the smallest common multiple, and using it to solve the problem. So what's next? Review what you learned by doing the knowledge check. Then master what you learned by doing the practice activity. In the next lesson, you'll learn how to find the factors of a number. I'll see you there. In this lesson, you'll learn how to find the factors of a number. So let's get started. So what is a factor? A factor is a whole number that can be multiplied with another whole number to get the original number. Let's imagine a number, say 12. Its factors are the numbers that can be multiplied together to give us 12. In this case, the factors of 12 would be 1, 2, 3, 4, 6, and 12. When we multiply these factors in different combinations, they always equal 12. Factor pairs are sets of 2 numbers that when multiplied together result in the original number. For example, 12 has 3 factor pairs, 1 and 12 because 1 times 12 is 12, 2 and 6 because 2 times 6 is 12, and 3 and 4 because 3 times 4 is also 12. Since division is the inverse or opposite of multiplication, you can think of a factor as a number that can be divided into the original number without leaving a remainder. For example, 12 can be divided by its factors 1, 2, 3, 4, 6, and 12 without leaving a remainder. Here's a step-by-step approach to find the factor pairs and the factors of a number. Step 1. Start with 1 and the number itself. You always include 1 and the number itself as a factor pair because any number multiplied by 1 and itself will equal the original number. For example, let's find the factor pairs of 24. 1 times 24 is 24, so 1 and 24 is a factor pair of 24. Step 2. Test the numbers 2 and 3. To find additional factor pairs, test the numbers 2 and 3. Check if these numbers divide the given number without leaving a remainder. 24 divided by 2 equals 12, so 2 times 12 is 24. Therefore, another factor pair is 2 and 12. 24 divided by 3 is 8, so 3 times 8 equals 24. Therefore, another factor pair is 3 and 8. Step 3. Test other numbers. Keep testing numbers until you find all the remaining factor pairs. 24 divided by 4 is 6, so 4 times 6 equals 24. Therefore, 4 and 6 is another factor pair. Step 4. List all factor pairs. Finally, list all the factor pairs you found. The factor pairs of 24 are 1 and 24, 2 and 12, 3 and 8, and 4 and 6. Step 5. Order the factors from least to greatest. You can order the factors you found from smallest to largest. The factor pairs of 24 are 1 and 24, 2 and 12, 3 and 8, and 4 and 6. Ordering these factors from least to greatest, you get 1, 2, 3, 4, 6, 8, 12, and 24. Now follow along as I solve this problem. What are the factor pairs of 16? I know that 1 times 16 equals 16. So 1 and 16 is a factor pair of 16. 16 divided by 2 is 8. So 2 times 8 equals 16. So 2 and 8 is another factor pair. 16 divided by 4 is 4. So 4 times 4 equals 16. So 4 and 4 is another factor pair. Looking at the answer choices, I can see that 4 times 6 equals 24. So B is not correct. 4 times 5 equals 20, so C is not correct. And 4 times 3 is 12, so D is not correct. So my answer is A. Now it's your turn to practice. Find all the factor pairs of 27 by finding the numbers that when multiplied together give you 27. Pause the video, and when you found your answer, click play. What are the factor pairs of 27? Well, 1 times 27 equals 27. So 1 and 27 is a factor pair of 27. 27 divided by 3 equals 9. So 3 times 9 equals 27. So 3 and 9 is a factor pair of 27. Looking at the answer choices, you can see that 6 times 6 is 36, so A is not correct. 6 times 4 is 24, so B is not correct. And 6 times 3 is 18, so D is not correct. The answer is C. Now follow along as I solve this problem. What are the factors of 15? To find the factors of 15, I can find the factor pairs of 15. I know that 1 times 15 equals 15. So 1 and 15 is a factor pair of 15. 15 divided by 3 is 5. So 3 times 5 equals 15. So 3 and 5 is another factor pair of 15. These are the only two pairs of whole numbers that I can multiply together to give me 15. So I can order my factors from least to greatest. I have 1, then 3, then 5, and 15. So my answer is C. Now it's your turn to practice. Find all the factors of 18 by finding the factor pairs of 18. Pause the video, and when you found your answer, click play. What are the factors of 18? Well, 1 times 18 equals 18. So 1 and 18 is a factor pair of 18. 18 divided by 2 is 9. So 2 times 9 equals 18. That means 2 and 9 is another factor pair of 18. 18 divided by 3 is 6. So 3 times 6 equals 18. So 3 and 6 is another factor pair of 18. These are the only three pairs of whole numbers that you can multiply together to give you 18. So next, list your factors from least to greatest, starting with 1, then 2, then 3, then 6, then 9, and finally 18. So the factors of 18 are 1, 2, 3, 6, 9, and 18. The answer is C. So let's review. A factor is a whole number that can be multiplied with another whole number to get the original number. Factor pairs are sets of two numbers that when multiplied together result in the original number. For example, 12 has three factor pairs, 1 and 12 because 1 times 12 is 12, 2 and 6 because 2 times 6 is 12, and 3 and 4 because 3 times 4 is also 12. You can think of a factor as a number that can be divided into the original number without leaving a remainder. The factors of 12 are 1, 2, 3, 4, 6, and 12. Factors are useful in many areas of math, such as simplifying fractions. So what's next? Review what you learned by doing the knowledge check. Then master what you learned by doing the practice activity. In the next lesson, you'll learn how to find the greatest common factor of two or more numbers. I'll see you there. In this lesson, you'll learn how to find the greatest common factor of two or more numbers using factor trees. So let's get started. First, we need to talk about prime numbers. So what is a prime number? A prime number is a whole number greater than 1 that has only two factors, 1 and itself. In other words, a prime number is any number that is greater than 1 that can only be divided by 1 and itself without leaving a remainder. For example, 3 is a prime number because it only has two factors, 1 and 3. Here you see a list of all the prime numbers to 20. These prime numbers are 2, 3, 5, 7, 11, 13, 17, and 19. Now follow along as I solve this problem. Which of the following numbers is a prime number? I'll take a look at A first. 12 has different factor pairs. It has 1 times 12, 2 times 6, and 3 times 4. Because 12 has more than one factor pair, it is not a prime number. Now 17 has 1 times 17, and that's it. Because 17 only has one factor pair, 1 times itself, it is a prime number. So my answer is B. Now it's your turn to practice. Find the number that is a prime number. Pause the video, and when you found your answer, click play. You can start with A. 26 has more than one factor pair. It has 1 times 26 and 2 times 13. So 26 has more than one factor pair, so it's not a prime number. 27 has 1 times 27. It also has 3 times 9. So B is not a prime number because it has more than one factor pair. 34 has 1 times 34 and 2 times 17. So 34 is not a prime number because it has more than one factor pair. Now let's take a look at 29. 29 has 1 times 29, and that's it. Since 29 has one factor pair, 1 and 29, it is a prime number. So the answer is D. So what is a factor tree? A factor tree is a visual way to break down a number into its smaller factors, including prime numbers. It helps you understand how a number can be written as a product of its prime factors. Let's learn how to create a factor tree step by step. Step 1. Choose a number. Start by picking a number that you want to break down into factors. For example, you can create a factor tree for the number 48. Step 2. Find two factors. Think of two numbers that divide into the chosen number without leaving a remainder. These numbers should be a factor pair and multiply together to give you the original number. Begin with the smallest factors possible. For 48, you can choose the factors 2 and 24 because 2 times 24 is 48. So draw two branches from 48 and then write 2 and 24. Step 3. Break down factors. Take one of the factors and see if it can be further broken down into smaller factors. If the factor is a prime number, stop. If it's not prime, continue breaking it down into its own factors. Let's start with 2. 2 cannot be broken down further because it's a prime number. Now, let's focus on 24. 24 can be broken down into 2 and 12 because 2 times 12 is 24. Continue breaking down the factors until you reach prime numbers. Well, 2 is a prime number, so we can stop here. But 12 is not a prime number. It can be broken down into 2 times 6. 2 is another prime number, and 6 can be broken down into 2 times 3. 2 and 3 are both prime numbers. Now we broke down 48 into all of its prime factors. Step 4. Complete the factor tree. Keep repeating steps 2 and 3 for each factor until all the numbers in the factor tree are prime. This process helps you create the complete factor tree. Using the example of 48, the factor tree would look like this. And as you can see, all the numbers at the ends of the factor tree are prime numbers. So you completed the factor tree with all prime numbers. Step 5. Read and write the factorization. To find the prime factorization of the original number, read the factor tree from left to right and write down the prime factors from least to greatest. You can see here that all the prime factors are at the ends of the tree. Writing them down from least to greatest, here we have 2 times 2 times 2 times 2 times 3. Now follow along as I create a factor tree for the number 36. I'll write the number 36 at the top and then branch it off into 2 factors. Well, a factor pair would be 2 times 18 equals 36. 2 is a prime number, so I can stop there, but 18 can be broken down into 2 times 9. 9 can be broken down into 3 times 3. And now I have all prime factors at the bottom of my tree. To write the prime factorization of 36, I can write 2 times 2 times 3 times 3, which equals 36. Now it's your turn to practice. Create a factor tree for the number 72, and then write the prime factorization. Pause the video, and when you found your answer, click play. To create a factor tree for the number 72, write 72 at the top. And then you can think of a factor pair of 72. Well, I know that 2 times 36 is a factor pair of 72 because 2 times 36 equals 72. 2 is a prime number, but 36 can be broken down into 2 times 18, since 2 times 18 equals 36. And 18 can be broken down into 2 times 9. And 9 can be broken down into 3 times 3. So now you have all prime factors at the bottom of your tree. To write the prime factorization of 72, you can write 2 times 2 times 2 times 3 times 3, which equals 72. So what is the greatest common factor? The greatest common factor, also known as the highest common factor, is the largest factor 2 or more numbers have in common. In other words, it is the largest number that divides into 2 or more given numbers with no remainder. Now, you'll learn a step-by-step approach to find the greatest common factor of 2 or more numbers using factor trees. Step 1. Choose 2 numbers. Start by selecting 2 numbers for which you want to find the greatest common factor. For example, you can find the greatest common factor of 24 and 36. Step 2. Make factor trees. Make separate factor trees for each of the 2 numbers. To make a factor tree, break down each number into its prime factors by finding the factors that multiply together to give the original number. In this case, 24 can be broken down into 2 times 12, and 12 can be broken down into 3 times 4, and 4 can be broken down into 2 times 2. Here you have all prime factors at the end of the factor tree. 36 can be broken down into 2 times 18. 18 can be broken down into 2 times 9. And 9 can be broken down into 3 times 3. Here there are all prime factors at the end of the factor tree. Step 3. Read and write the prime factorizations. Read the factor tree from left to right and write down the prime factors from least to greatest. Write the prime factorizations of the numbers directly on top of each other. The prime factorization of 24 is 2 times 2 times 2 times 3. And the prime factorization of 36 is 2 times 2 times 3 times 3. Step 4. Identify common factors. Look for the common prime factors shared by the factorizations. These common factors may occur more than once. Here you can see that the common prime factors of 24 and 36 are 2, 2 again, and 3. Step 5. Determine the greatest common factor. To find the greatest common factor, multiply the common prime factors together. The product of these common factors is the greatest common factor of the two numbers. In our example, the greatest common factor of 24 and 36 is 12. That's because 2 times 2 times 3, which is 4 times 3, equals 12. Therefore, 12 is the greatest common factor of 24 and 36. Now follow along as I find the greatest common factor of 18 and 24. To create the factor tree of 18, I know that 2 times 9 is 18, and 3 times 3 is 9. I found all the prime factors of 18. 24 is equal to 2 times 12, and 12 is 2 times 6, and 6 is 2 times 3. I found all the prime factors of 24. Next, I need to write the prime factorizations of 18 and 24 on top of each other. The prime factorization of 18 is 2 times 3 times 3. And the prime factorization of 24 is 2 times 2 times 2 times 3. Then I find the common prime factors. The common prime factors are 2 and 3. To get the greatest common factor, I need to multiply the common prime factors together. 2 times 3 is 6. So the greatest common factor of 18 and 24 is 6. Now it's your turn to practice. Find the greatest common factor of 42 and 56. Pause the video, and when you found your answer, click play. To find the greatest common factor of 42 and 56, you need to create prime factorization trees. 42 is the same thing as 2 times 21. 21 is the same thing as 3 times 7. You can stop there because 2, 3, and 7 are all prime factors of 42. 56 is the same thing as 2 times 28, and 28 is the same as 2 times 14. 14 is the same as 2 times 7. You can stop there because you found all the prime factors of 56. Next, you need to write the prime factorizations of 42 and 56 on top of each other. The prime factorization of 42 is 2 times 3 times 7. And the prime factorization of 56 is 2 times 2 times 2 times 7. To find the greatest common factor, you need to multiply the common prime factors together. The common prime factors are 2 and 7. 2 times 7 equals 14. So the greatest common factor of 42 and 56 is 14. Now let's review. A prime number is a whole number greater than 1 that has only two factors, 1 and itself. For example, 3 is a prime number because it only has two factors, 1 and 3. The greatest common factor, also known as the highest common factor, is the largest number that divides into two or more given numbers with no remainder. The greatest common factor is useful for simplifying fractions and solving everyday problems. So what's next? Review what you learned by doing the knowledge check. Then master what you learned by doing the practice activity. In the next lesson, you'll learn how to use the greatest common factor to solve real-life problems. I'll see you there. In this lesson, you'll learn how to solve word problems by finding the greatest common factor. So let's get started. The greatest common factor is the biggest number that can divide into two or more given numbers without leaving a remainder. It is useful when solving problems that involve finding the biggest shared factor or dividing things into equal groups. Let's learn how to solve word problems using the greatest common factor. Step 1. Read and understand the problem. First, carefully read and understand the problem. Figure out the numbers you need to find the greatest common factor for. These numbers will be given in the problem or can be understood from the situation. Step 2. Make prime factor trees to find the greatest common factor. Next, make factor trees to find the common prime factors and then multiply them together. This number will be the greatest common factor. Step 3. Solve the problem and check your answer. Once you find the greatest common factor, use it to solve the word problem. Double-check your answer to make sure it's correct and makes sense in the context of the problem. Now follow along as I solve this problem. A farmer wants to plant rows of apple trees and orange trees in his orchard. He wants to have the same number of apple trees and orange trees in each row. The farmer has 36 apple trees and 48 orange trees. What is the greatest number of rows of trees the farmer can plant? In this case, I need to solve for the greatest number of rows of trees the farmer can plant. This is a clue that I need to solve for the greatest common factor. He's planting 36 apple trees and 48 orange trees. To find the greatest common factor of 36 and 48, I can create prime factor trees. 36 is the same as 2 times 18, and 18 is the same as 2 times 9, and 9 is the same as 3 times 3. I can stop there because I have all prime factors at the end of my factor tree. 48 is the same as 2 times 24, and 24 is the same as 2 times 12, which is the same as 2 times 6, which is the same as 2 times 3. I can stop there because I have all prime factors at the end of my factor tree. Next, I need to list the prime factorizations of 36 and 48 on top of each other. The prime factorization of 36 is 2 times 2 times 3 times 3. The prime factorization of 48 is 2 times 2 times 2 times 2 times 3. To find the greatest common factor of 36 and 48, I need to multiply the common prime factors, which is 2 times 2 times 3. 2 times 2 is 4, and 4 times 3 is 12. So the greatest common factor of 36 and 48 is 12, which means the farmer can plant a maximum of 12 rows of apple and orange trees. My answer is B. Now it's your turn to practice. Read the problem carefully to solve for the maximum number of bags the bakery can make. Pause the video, and when you found your answer, click play. A bakery made 72 chocolate chip cookies and 90 oatmeal raisin cookies. The bakery wants to create bags of cookies with each bag containing the same number of chocolate chip and oatmeal raisin cookies. What is the maximum number of bags the bakery can make? In this case, you need to solve for the maximum number of bags the bakery can make, which is a clue that you need to find the greatest common factor of 72 and 90. To make a prime factor tree of 72, break down 72 into 2 times 36. 36 is the same as 2 times 18, and 18 is the same as 2 times 9, and 9 is the same as 3 times 3. You can stop there because you have all prime factors at the end of your factor tree. 90 is the same as 2 times 45, and 45 is the same as 5 times 9, and 9 is the same as 3 times 3. You can stop there because you have all prime factors at the end of your factor tree. Next, you need to write the prime factorizations of 72 and 90 on top of each other. The prime factorization of 72 is 2 times 2 times 2 times 3 times 3. And the prime factorization of 90 is 2 times 3 times 3 times 5. To find the greatest common factor of 72 and 90, multiply the common prime factors, which is 2 times 3 times 3. 2 times 3 is 6, and 6 times 3 is 18. So 18 is the greatest common factor of 72 and 90, which means the bakery can make a maximum number of 18 bags. So the answer is D. Now let's review. The greatest common factor is the biggest number that can divide into 2 or more given numbers without leaving a remainder. It is useful when solving problems that involve finding the biggest shared factor or dividing things into equal groups. Solving word problems using the greatest common factor involves understanding the problem, making prime factor trees, finding the biggest shared factor, and using it to solve the problem. So what's next? Review what you learned by doing the knowledge check. Then master what you learned by doing the practice activity. In the next lesson, you'll learn how to use the distributive property to make calculations easier. I'll see you there. In this lesson, you'll learn how to use the distributive property to rewrite numeric expressions. So let's get started. So what is the distributive property? The distributive property over addition states that when you multiply a number by the sum of two or more numbers, you can distribute the multiplication to each term inside the parentheses. On the left side of the equal sign, you have a grid that is 3 rows by 6 columns. 3 times 6 equals 18. So there are 18 boxes on the left side. And on the right side of the equal sign, you have 2 grids. One grid is 3 rows by 2 columns, and 3 times 2 is 6. And you have another grid that is 3 rows by 4 columns, and 3 times 4 is 12. If you add the 6 boxes and the 12 boxes together, you get 18 boxes. As you can see, the grid on the left side of the equal sign has the same number of boxes as the sum of the grids on the right side of the equal sign. So the numeric expression 3 times 2 plus 4 is equal to the expression 3 times 2 plus 3 times 4. So what does it mean to distribute? When you distribute in math, you take a number or operation and give it to each part or term of an expression. Let's say you have 3 times 2 plus 4. To distribute the multiplication to each number inside the parentheses, you multiply 3 by 2 and 3 by 4 separately. So first, you would do 3 times 2, which gives you 6, and then you would add that to 3 times 4, which gives you 12. On the left side of the equal sign, we have 3 times 2 plus 4. 2 plus 4 is 6, so that's equal to 3 times 6, which is 18. And on the right side, we have 3 times 2, which is 6, plus 3 times 4, which is 12. 6 plus 12 is 18. As you can see, 3 times 2 plus 4 is equal to 3 times 2 plus 3 times 4. The distributive property over addition. The distributive property over addition states that for any numbers a, b, and c, a times b plus c is equal to a times b plus a times c. It means that when you have a number multiplied by the sum of two other numbers, you can distribute the multiplication to each term inside the parentheses. For example, if a equals 3, b equals 2, and c equals 4, you can distribute the 3 to both numbers inside the parentheses, which gives you 3 times 2 plus 3 times 4. Now follow along as I solve this problem. Which expression demonstrates the distributive property over addition? For a, I can distribute the 3 to the 2, which gives me 3 times 2, plus, but here I have multiplication instead of addition, so this is not going to work. A is incorrect. B has just addition and no multiplication, so B does not work. Same thing for C. For D, I can distribute the 3 to both numbers inside the parentheses. 3 times 4 plus 3 times 2. So D demonstrates the distributive property over addition. My answer is D. Now it's your turn to practice. Find the expression that demonstrates the distributive property over addition. Pause the video, and when you found your answer, click play. For A, You see here that there's only addition and no multiplication, so A is not correct. For B, you can distribute the 5 to the 7, which gives you 5 times 7, plus 5 times 2. As you can see, B demonstrates the distributive property over addition, so the answer is B. What is the distributive property over subtraction? The distributive property over subtraction states that when you multiply a number by the difference between two numbers, you can distribute the multiplication to each term inside the parentheses. Here you would multiply the 5 times the 8, and then subtract 5 times 3. We know this is true because 8 minus 3 is 5, and 5 times 5 is 25. On the right side of the equal sign, we have 5 times 8, which is 40, minus 5 times 3, which is 15, and 40 minus 15 is 25. As you can see, 5 times 8 minus 3 is equal to 5 times 8 minus 5 times 3. The distributive property over subtraction. The distributive property over subtraction states that for any numbers a, b, and c, a times b minus c is equal to a times b minus a times c. It means that when you have a number multiplied by the difference of two other numbers, you can distribute the multiplication to each term inside the parentheses. For example, if a is 5, b is 8, and c is 3, you can distribute the 5 to both terms or numbers inside the parentheses, which gives you 5 times 8 minus 5 times 3. Now follow along as I solve this problem. Which expression demonstrates the distributive property over subtraction? For A, I only have addition, so that is not correct. For B, I can distribute the 7 to the 3, which gives me 7 times 3, but the problem is the 7 times 3 should go first, so that should be 7 times 3 minus 7 times 5. Here you cannot switch the order because it'll give you a different answer, so B is not correct. C does not have any subtraction, so C is not correct. For D, I can distribute the 7 to the 5, which gives me 7 times 5 minus 7 times 3. As you can see, D correctly demonstrates the distributive property over subtraction. My answer is D. Now it's your turn to practice. Find the expression that demonstrates the distributive property over subtraction. Pause the video, and when you found your answer, click play. For option A, there is no subtraction, so A is not correct. For B, you can distribute the 6 to the 4, which gives you 6 times 4, minus 6 times 2. As you can see, B correctly demonstrates the distributive property over subtraction, so the answer is B. Let's review. The distributive property over addition or subtraction states that when you multiply a number by the sum of or difference between two or more numbers, you can distribute the multiplication to each term inside the parentheses. That means A times B plus C is equal to A times B plus A times C. It also means that A times B minus C is equal to A times B minus A times C. So what's next? Review what you learned by doing the knowledge check. Then master what you learned by doing the practice activity. In the next lesson, you'll learn how to use the distributive property to represent word problems. I'll see you there. In this lesson, you'll learn how to use the distributive property to represent word problems using numeric expressions. So let's get started. Rewriting a factor as the sum of two or more numbers. You can also use the distributive property to break down a factor into the sum of two or more numbers. For example, you can solve 7 times 12 by using the distributive property to break up 12 into 10 and 2, and then multiplying both numbers by 7. As you can see, you can break down the 12 into 10 plus 2. And then you can distribute the 7 to both numbers inside the parentheses, which gives you 7 times 10 plus 7 times 2. Now follow along as I solve this problem. Which expression shows how the distributive property can be used to calculate 8 times 24? I can break up the 24 into 20 plus 4. And then I can distribute the 8 to both numbers inside the parentheses. That gives me 8 times 20 plus 8 times 4. So my answer is A. Now it's your turn to practice. Find the expression that shows how the distributive property can be used to calculate 9 times 17. Pause the video, and when you found your answer, click play. You can break up the 17 into 15 plus 2, and then you can distribute the 9 to both numbers inside the parentheses. That gives you 9 times 15 plus 9 times 2. The answer is C. Now follow along as I solve this problem. Which expression shows how the distributive property can be used to calculate the cost of 8 books costing $12.50 each? In this case, I can break up the $12.50 into $10 plus $2.50. And then I can distribute the 8 to both numbers inside the parentheses. That gives me 8 times 10 plus 8 times $2.50. So my answer is A. Now it's your turn to practice. Find the expression that shows how the distributive property can be used to calculate the cost of 6 t-shirts costing $18.99 each. Pause the video, and when you found your answer, click play. In this case, you can break up the $18.99 into $18 plus 99 cents. And then you can distribute the 6 to both numbers inside the parentheses. That gives you 6 times $18 plus 6 times 99 cents. So the answer is B. Rewriting factors as the difference of two or more numbers. You can also use the distributive property to break down a factor into the difference of two or more numbers. For example, you can solve 7 times 12 by rewriting 12 as 15 minus 3, since 15 take away 3 is 12, and then multiplying both numbers by 7. In this case, you can rewrite the 12 as 15 minus 3, and then you can distribute the 7 to both numbers inside the parentheses, which gives you 7 times 15 minus 7 times 3. Now follow along as I solve this problem. Which expression shows how the distributive property can be used to calculate 14 times 6? In this case, I can rewrite the 6 as 10 minus 4. And then I can distribute the 14 to both numbers inside the parentheses. That gives me 14 times 10 minus 14 times 4. So my answer is B. Now it's your turn to practice. Find the expression that shows how the distributive property can be used to calculate 23 times 9. Pause the video, and when you found your answer, click play. You can rewrite the 9 as 10 minus 1. And then you can distribute the 23 to both numbers inside the parentheses. That gives you 23 times 10 minus 23 times 1. The answer is D. Now follow along as I solve this problem. Which expression shows how the distributive property can be used to calculate the cost of 6 jackets costing $45.99 each? In this case, I can rewrite the $45.99 as $50 minus $4.01. And then I can distribute the 6 to both numbers inside the parentheses. That gives me 6 times $50 minus 6 times $4.01. So my answer is D. Now it's your turn to practice. Find the expression that shows how the distributive property can be used to calculate the cost of 9 smartphones costing $799.99 each. Pause the video, and when you found your answer, click play. In this case, you can rewrite the $799.99 as $800 minus 1 cent. And then you can distribute the 9 to both numbers inside the parentheses. That gives you 9 times $800 minus 9 times 1 cent. So the answer is B. Now let's review. You can use the distributive property to rewrite a factor as the sum or difference of 2 or more numbers. This can make calculations easier. You can also use the distributive property to write numeric expressions that represent real-life situations. So what's next? Review what you learned by doing the knowledge check. Then master what you learned by doing the practice activity. Then complete the unit review to make sure you understand everything about multiples, factors, and the distributive property. And remember, you got this. In this lesson, you'll learn how to determine which unit of measurement is most suitable for different situations. So let's get started. So what is a unit of measurement? A unit of measurement is a standard quantity used to measure or describe things. It helps you understand and talk about the size, weight, or amount of something. For example, you use inches to measure how long a pencil is, or you use cups to measure how much flour you need for a recipe. Units of measurement make it easier for you to know and communicate how big or small things are. It's important to know that there are 2 systems of measurement. The U.S. customary system, also known as the imperial system, is a system of measurement used in the United States and a few other countries. The metric system, officially known as the International System of Units, or SI, is the most used system of measurement worldwide. It's commonly used in the science, technology, engineering, and math fields. Now let's talk about the customary units of length. Inch, abbreviation IN. An inch is the smallest unit of length, often used for small measurements. Foot, abbreviation FT. A foot is equivalent to 12 inches. That's the length of a 12-inch ruler. Yard, abbreviation YD. A yard is equivalent to 3 feet or 36 inches. A yard is about the length of a guitar. Mile, abbreviation MI. A mile is equivalent to 5,280 feet. For example, the distance from Los Angeles to San Francisco is about 380 miles. Now it's your turn to practice. Read the question carefully and choose the best answer. Pause the video, and when you're ready, click play. Which unit of measurement is most appropriate for measuring the length of a football field? In this case, you would use yards because yards are about the length of a guitar. Miles would be too big, kilometers would be too big, and inches would be too small. So the answer is B, yards. Now read the question carefully and choose the best answer. Pause the video, and when you're ready, click play. Which unit of measurement is most appropriate for measuring the length of a notebook? In this case, the length of a notebook is about 12 inches, so you would use inches to measure the length. Meters would be too big, yards, which are about the size of a guitar, would be too big, and centimeters would be too small. So the answer is D, inches. Now let's talk about the customary units of weight or mass. Ounce, abbreviation OZ. An ounce is used for small weights. A slice of bread weighs about 1 ounce. Pound, abbreviation LB. A pound is equivalent to 16 ounces. For example, body weight is measured in pounds. Ton. A US ton is equivalent to 2,000 pounds. Tons are used to measure heavy objects. For example, an elephant weighs about 8 tons. Now it's your turn to practice. Read the question carefully and choose the best answer. Pause the video, and when you're ready, click play. What is the most suitable unit of measurement for measuring the weight of a pencil? In this case, a pencil is very light, so you would use a light unit of measurement such as ounces, because 1 ounce weighs about the same as 1 slice of bread. Pounds are too big, kilograms are too big, and tons are definitely too big. So the answer is C, ounces. Now read the question carefully and choose the best answer. Pause the video, and when you found your answer, click play. A construction site is receiving a shipment of gravel. What unit of measurement is commonly used to measure the quantity of gravel delivered? In this case, a pile of gravel is going to weigh a lot, so you would use tons, which are used to weigh heavy amounts, like the weight of elephants. Pounds are too small, ounces are way too small, and kilograms are too small. So the answer is C, tons. Now let's talk about the customary units of volume. Fluid ounce, abbreviation FLOZ. A fluid ounce is used for small liquid volumes. For example, a medicine cup holds about 1 fluid ounce. Cup, abbreviation C. A cup is equivalent to 8 fluid ounces. You use cups when you measure ingredients when cooking. Gallon, abbreviation GAL. A gallon is equivalent to 128 fluid ounces. For example, you can buy a gallon of milk at the market. Now it's your turn to practice. Read the question carefully and choose the best answer. Pause the video, and when you found your answer, click play. What is the most suitable unit of measurement for measuring the volume of a large container of water? In this case, you would use a larger unit of volume measurement like gallons. Remember, gallons are used to measure larger liquids like a gallon of milk. Fluid ounces would be too small, cups would be too small, and milliliters would definitely be too small. So the answer is C, gallons. Read the question carefully and choose the best answer. Pause the video, and when you're ready, click play. What is the most suitable unit of measurement for measuring the volume of a small bottle of shampoo? A small bottle of shampoo can only hold a small volume of liquid. So you need to use a small volume of liquid measurement like fluid ounces. A medicine cup can hold 1 fluid ounce. Cups are too big, gallons are too big, and milliliters are too small. So the answer is A, fluid ounces. Now let's talk about metric units of length. Millimeter, abbreviation mm. A millimeter is the smallest unit of length, often used for very small measurements. The thickness of a credit card is about 1 millimeter. Centimeter, abbreviation cm. There are 100 centimeters in a meter. A fingernail is about 1 centimeter wide. Meter, abbreviation m. Meter is the base unit of length, used for most measurements. A meter is about the length of a guitar. Kilometer, abbreviation km. A kilometer is equivalent to 1,000 meters. Kilometers are used to measure long distances, such as the distance between 2 cities. Now it's your turn to practice. Read the question carefully and choose the best answer. Pause the video, and when you're ready, click play. Which unit of measurement is most appropriate for measuring the length of a marathon race? A marathon is a long-distance race, so you would use a measurement that's used to measure long distances, like kilometers. Meters and yards, which are about the length of a guitar, would be too small, and feet would definitely be too small. So the answer is C, kilometers. Now read the question carefully and choose the best answer. Pause the video, and when you're ready, click play. What is the most suitable unit of measurement for measuring the length of a small eraser? Because the eraser is small, you would use a small unit of length, such as centimeters, which is about the width of a fingernail. Yards, which are about the length of a guitar, would be too big. Same with meters. And feet would be too big. So the answer is B, centimeters. Now let's talk about metric units of weight or mass. Milligram, abbreviation mg. A milligram is the smallest unit of weight or mass, often used for very small measurements. A milligram is about as light as a snowflake. Gram, abbreviation g. A gram is the base unit of mass. It's used for most measurements. It's also used to measure light objects. A paperclip weighs about 1 gram. Kilogram, abbreviation kg. A kilogram is equivalent to 1,000 grams. Kilograms are used to measure heavy objects. A dictionary has a mass of about 1 kilogram. Now it's your turn to practice. Read the question carefully and choose the best answer. Pause the video, and when you're ready, click play. A baker is making a special cake and needs to measure a small amount of a rare and costly spice for the best taste. What unit of measurement would the baker most likely use to measure the spice? In this case, the baker needs to use a very small unit of measurement because the spice is very light. Grams is a very small unit of measurement because it weighs about as much as a paperclip. Fluid ounces doesn't work because fluid ounces are used to measure liquids. Kilograms are too big, and pounds are too big. So the answer is D, grams. Read the problem carefully and choose the best answer. Pause the video, and when you're ready, click play. What is the most suitable unit of measurement for measuring the weight of a person? In this case, you would use a larger unit of measurement, such as kilograms. A kilogram weighs about as much as a dictionary. In many countries, weight of a person is measured in kilograms. Liters are used to measure liquids, so liters doesn't work. Ounces are too small, and tons are too big. So the answer is C, kilograms. Now let's talk about metric units of volume. Milliliter, abbreviation ML. A milliliter is used for small liquid volumes. 20 drops of water is about 1 milliliter. Liter, abbreviation L. A liter is the base unit of volume, which is used for most measurements. A bottle of soda is about 1 liter. Now it's your turn to practice. Read the question carefully and choose the best answer. Pause the video, and when you're ready, click play. A pharmacist is preparing a liquid medicine prescription. What unit of measurement would the pharmacist most likely use to measure the medicine? In this case, the pharmacist needs to measure a very small amount of liquid medicine. So they would use a very small unit of volume measurement, which is milliliters. 1 milliliter is equal to 20 drops of liquid. Cups are too big, liters is too big, and a fluid ounce is too big because a fluid ounce is the amount that's in 1 medicine cup. So the answer is B, milliliters. Read the question carefully and choose the best answer. Pause the video, and when you're ready, click play. A farmer needs to water their crop. What unit of measurement would a farmer most likely use to measure the water needed to irrigate their crop? In this case, the farmer needs to measure a large amount of water, so they need to use a larger unit of volume measurement, which is liters. 1 container of soda is about 1 liter. Cups is too small, milliliters is definitely too small, and fluid ounces are too small. So the answer is C, liters. Now let's review. A unit of measurement is a standard quantity used to measure or describe things. It helps you understand and talk about the size, weight, or amount of something. The U.S. customary system of measurement is used in the United States and a few other countries. The metric system is used in science, industry, and everyday life in most countries. So what's next? Review what you learned by doing the knowledge check. Then master what you learned by doing the practice activity. In the next lesson, you'll learn how to calculate unit rates, such as miles per hour or dollars per gallon. I'll see you there. In this lesson, you'll learn how to find unit rates to solve real-world problems. So let's get started. So what is a unit rate? A unit rate is the rate at which one quantity is compared to 1 unit of another quantity. It is often expressed as quantity per unit or quantity per 1 unit. Let's say you're driving a car and you travel 150 miles in 3 hours. The unit rate in this case would be how many miles you travel per hour, your speed. It helps you understand how fast you're going. So how do you find a unit rate? The formula for finding a unit rate is unit rate equals quantity divided by unit. The quantity represents the amount being measured, and the unit is the specific unit of measurement used for comparison. It usually comes after the per. For example, a car travels 240 miles in 4 hours. Find the speed in miles per hour. Since miles comes before the per, miles is the quantity, which is 240. Hours comes after per, so hours is the unit, which is 4. To find the unit rate, divide 240 by 4. 240 miles divided by 4 hours gives you 60 miles per hour. So how do you find a unit rate step by step? Step 1. Identify the 2 quantities being compared. Step 2. Underline or highlight the quantity and unit being used for comparison. Step 3. Divide the quantity by the unit to find the unit rate. Step 4. Write the unit rate with the appropriate units. For example, a store sells 8 bottles of water for $5. Find the cost per bottle. Since the cost comes before the per, cost is the quantity, which is $5. Since bottles comes after per, bottles is the unit, which is 8. To find the unit rate, divide 5 by 8. $5 divided by 8 bottles is 63 cents per bottle when rounded to the nearest cent. Now follow along as I solve this problem. A factory can produce 600 bottles in 3 hours. Find how many bottles the factory produces per hour. In this case, I need to find how many bottles the factory produces per hour. This is a clue that I need to find the unit rate. In this case, bottles comes before the per, so bottles is the quantity, which is 600. Hours comes after per, so hours is the unit, which is 3. To find the unit rate, I divide the quantity by the unit. 600 divided by 3 is 200, which means the factory can produce 200 bottles per hour. Now it's your turn to practice. Read the problem and solve for the cost in dollars per pound of bananas. Pause the video, and when you found your answer, click play. A grocery store sells 12 pounds of bananas for $6. What is the cost in dollars per pound of bananas? In this case, you need to solve for the cost in dollars per pound. Since dollars comes before the per, dollars is the quantity, which is 6. And pound comes after per, which means pounds is the unit, which is 12. To find the unit rate, you divide the quantity by the unit. 6 divided by 12 is 0.5, which is really 50 cents. That means bananas cost 50 cents per pound. Now it's time for more practice. Solve the following problems to practice finding unit rates. Pause the video, and when you found your answers, click play. A bicycle travels 45 kilometers in 3 hours. Find the speed in kilometers per hour. In this case, you need to solve for kilometers per hour. Since kilometers comes before the per, kilometers is the quantity, which is 45. And hours comes after per, so hours is the unit, which is 3. To find the unit rate, divide the quantity by the units. 45 divided by 3 is 15. So the bicycle is traveling at 15 kilometers per hour. A worker earns $240 for working 30 hours. Find their wage in dollars per hour. Here you need to solve for their wage in dollars per hour. Since dollars comes before the per, dollars is the quantity, which is 240. And hours comes after per, so hours is the unit, which is 30. To find the unit rate, divide the quantity by the units. 240 divided by 30 is 8, which means the worker earns $8 per hour. A printer can print 180 pages in 6 minutes. Find the number of pages the printer can print per minute. In this case, you need to solve for pages per minute. Since pages comes before the per, pages is the quantity, which is 180. Since minute comes after per, minutes are the unit, which is 6. To find the unit rate, divide the quantity by the units. 180 divided by 6 is 30. So the printer can print 30 pages per minute. So what? Why should you care? In everyday life, you encounter unit rates when you compare prices, calculate speeds, or understand how much you get for your money. For instance, when you go to a grocery store and see that a pack of 6 sodas costs $5, you can find the unit rate to know how much each soda costs. Unit rates are important because they help you make informed decisions. They allow you to compare things and figure out which option is the best value or which one is the fastest. By understanding unit rates, you can make smarter choices and solve problems in real-life situations. Now let's review. A unit rate is the rate at which one quantity is compared to one unit of another quantity. It is often expressed as quantity per unit or quantity per 1 unit. The formula for unit rate is unit rate equals quantity divided by unit. The quantity represents the amount being measured and comes before the per. The unit is the specific unit of measurement used for comparison and comes after the per. Remember, unit rate is all about comparing quantities and understanding the amount of one thing per unit of another thing. It's a helpful tool for everyday calculations and decision making. So what's next? Review what you learned by doing the knowledge check. Then master what you learned by doing the practice activity. In the next lesson, you'll learn how to use scale factors to convert between actual drawings and scale drawings. I'll see you there. In this lesson, you'll learn how to find scale factors to solve real-world problems. So let's get started. Before we talk about scale factors, we need to talk about what is a ratio. A ratio is a way to compare or describe the relationship between different parts or quantities. Ratios can be expressed using numbers like 3 to 2, or as fractions like 3 over 2, or as a scale like 3 inches equals 2 feet, depending on the context. So what is a scale factor? A scale factor is a ratio that compares the size of an object in a drawing to its actual size. For example, scale factors can be written as 1 to 10, or 1 over 10, or something like 1 inch equals 10 feet. It allows you to shrink or enlarge an object. For example, you can show the layout of a house using a scale drawing. So how do you find a scale factor step by step? Step 1. Figure out what you're working with. Is it a drawing, a model, or something else? Look for any measurements or sizes given in the problem. It could be lengths, widths, heights, or any other measurements that are mentioned. Step 2. Write the comparison as a ratio. The first number represents the size in the drawing, and the second number represents the actual size. For example, 2 inches on the drawing represents 20 feet in actual size. Step 3. Write the ratio as a fraction and simplify if needed. For example, 2 inches over 20 feet can be simplified to 1 inch over 10 feet by dividing the top and bottom quantities by their greatest common factor, which is 2. Step 4. Express the scale factor using words or numbers. For example, 1 inch on the drawing represents 10 feet in real life. Then write it as 1 inch equals 10 feet. Now follow along as I solve this problem. Olivia is making a scale drawing of a park. On her drawing, a bench measures 2 inches, while in reality it is 8 feet long. What is the scale of Olivia's drawing? To find the scale of Olivia's drawing, write the comparison as a fraction with the length of the bench on her drawing on top, which is 2 inches. Then write the actual length of the bench on the bottom, which is 8 feet. Then simplify the fraction by dividing the top and bottom quantities by their greatest common factor, which is 2. Two inches divided by 2 gives me 1 inch. And 8 feet divided by 2 gives me 4 feet. The fraction simplifies to 1 over 4, which means that 1 inch on the drawing is equal to 4 feet in real life. So the scale factor is 1 inch equals 4 feet. Now it's your turn to practice. Read the problem carefully and then find the scale of Ethan's drawing. Pause the video, and when you found your answer, click play. Ethan is creating a scale drawing of a building. The height of the building on his drawing is 9 inches, while the actual height is 108 feet. What is the scale of Ethan's drawing? To find the scale of Ethan's drawing, write the comparison as a fraction with the height of his drawing on top, which is 9 inches. Then write the actual height of the building on the bottom, which is 108 feet. Then simplify the fraction by dividing the top and bottom quantities by their greatest common factor, which is 9. 9 inches divided by 9 gives you 1 inch. 108 feet divided by 9 gives you 12 feet. So the fraction simplifies to 1 over 12, which means that 1 inch on the drawing is equal to 12 feet in real life. So the scale factor is 1 inch equals 12 feet. Now let's review. A scale factor is a ratio that compares the size of an object in a drawing to its actual size. For example, 1 to 10 or 1 over 10. The scale would be 1 inch equals 10 feet. It allows you to shrink or enlarge an object. For example, you can show the layout of a house using a scale drawing. Scale factors allow architects, engineers, and designers to represent objects accurately in drawings. So what's next? Review what you learned by doing the knowledge check. Then master what you learned by doing the practice activity. In the next lesson, you'll learn how to convert measurements between drawings and actual sizes. I'll see you there. In this lesson, you'll learn how to use scale factors to convert measurements from drawings and models to actual sizes. So let's get started. First, let's talk about proportionality. So what is proportionality? Proportionality means that two things change together in a predictable way. If one thing gets bigger, the other thing also gets bigger. And if one thing gets smaller, the other thing also gets smaller by the same scale factor. For example, the hand of a baby is a smaller version of the hand of an adult. They're proportional. Then what is a proportion? A proportion is a way to show that two ratios or fractions are equal. It's like saying that two groups of numbers are related to each other. For example, if you have a scale where 1 inch on a map represents 10 miles in real life, and you measure a distance on the map to be 2 inches, you can set up a proportion to find the actual distance. By solving this proportion, you can find the value of x, which tells you the actual distance in miles. To convert measurements between drawings or models and actual sizes, follow these 3 steps. Step 1. Understand the scale. Look for information that tells you how much a measurement in the drawing or model represents in the actual size. This is called the scale. Step 2. Set up a proportion. Use the scale to set up a proportion between the measurements in the drawing and the corresponding measurements in real life. Step 3. Solve for x. Solve the proportion by cross-multiplying and dividing to solve for the unknown measurement. Now follow along as I solve this problem. A model car is 10 centimeters long. If it was built with the scale of 2 centimeters equals 1 meter, how long is the actual car? In this case, I need to solve for the length of the actual car, which will be in meters. I can see here that the scale is 2 centimeters equals 1 meter. I can write this scale as a ratio. 2 centimeters over 1 meter. Then I can set up a proportion. I'll set this ratio equal to another ratio. Since the model car is 10 centimeters long, I'll write 10 centimeters on top. Because centimeters is on top on the left side of the proportion, so centimeters must go on top on the right side of the proportion. Since I'm solving for the size of the actual car, which will be in meters, I need to put x on the bottom, because meters is also on the bottom. Now to solve for x, I first need to multiply the numbers that are diagonal from each other, which is 1 and 10. 1 times 10 is 10. And then I need to divide by the number that is diagonal from the x, which is 2. 10 divided by 2 equals 5. which means that the size of the actual car is 5 meters. Now it's your turn to practice. Read the problem carefully and use a proportion to solve for how far apart are the actual locations. Pause the video, and when you found your answer, click play. Hillcrest and Valley View are 6.6 inches apart on a map that has a scale of 1.1 inches equals 10 miles. How far apart are the actual locations? In this case, you need to solve for how far apart the two cities actually are, which will be in miles. You can also see here that the scale is 1.1 inches equals 10 miles. You can write that scale as a ratio. 1.1 inches over 10 miles. Then you can set that ratio equal to another ratio to create a proportion. You can see here that the two cities on the map are 6.6 inches apart. Since inches is on top on the left side of the proportion, inches must be on top on the right side of the proportion. Since you're solving for the actual distance, which will be in miles, and miles is on the bottom of the proportion, you need to write x on the bottom. Then, to solve for x, you need to multiply the two numbers that are diagonal from each other, which is 10 and 6.6. 10 times 6.6 is 66. Then you need to divide 66 by the number that is diagonal from the x, which is 1.1. 66 divided by 1.1 equals 60. This means the two cities are actually 60 miles apart. Now follow along as I solve this problem. A construction company is making a scale model of a bridge. The bridge will be 150 feet long. On the model, 6 inches will represent 10 feet. How long does the model need to be? In this case, I need to solve for how long the model will be, which will be in inches. I can see here that the scale is 6 inches is equal to 10 feet. I can write that as a ratio. 6 inches over 10 feet. I can then set that ratio equal to another ratio to make a proportion. I can see here that the bridge is 150 feet long. Since feet is on the bottom on the left side of the proportion, I need to write the feet on the bottom on the right side of the proportion. Since I'm solving for how long the model needs to be, which will be in inches, and inches is on the top on the left side of the proportion, I need to write x on the top on the right side of the proportion. To solve for x, I need to multiply the two numbers that are diagonal from each other, which are 6 and 150. 6 times 150 equals 900. And then I need to divide 900 by the number that is diagonal from the x, which is 10. 900 divided by 10 equals 90, which means the model needs to be 90 inches long. Now it's your turn to practice. Read the problem carefully and use a proportion to solve for the distance on the blueprint. Pause the video, and when you found your answer, click play. On a blueprint, 8 centimeters represents 6 meters. How many centimeters would be between two rooms that are 18 meters apart? In this case, you need to solve for the length between the two rooms on the blueprint, which will be in centimeters. Here you can see the scale, which is 8 centimeters on the blueprint, is equal to 6 meters in the actual building. You can write that scale as a ratio. 8 centimeters is equal to 6 meters. Then you can set that ratio equal to another ratio to make a proportion. You can see here that the actual distance between the two rooms is 18 meters. You can also see that meters is on the bottom on the left side of the proportion, which means you need to write the meters on the bottom on the right side of the proportion. Since you're solving for the distance on the blueprint, and that's going to be in centimeters, and you can see that centimeters is on the top on the left side of the proportion, you need to write x on the top on the right side of the proportion. To solve for x, multiply the two numbers that are diagonal from each other, which is 8 and 18. 8 times 18 is 144. Then you need to divide 144 by the number that is diagonal from the x, which is 6. 144 divided by 6 equals 24, which means that on the blueprint, the two rooms are 24 centimeters apart. Now let's review. Proportionality means that two things change together in a predictable way. If one thing gets bigger, the other thing also gets bigger. Or if one thing gets smaller, the other thing also gets smaller by the same scale factor. A proportion is a way to show that two ratios or fractions are equal. It's like saying that two groups of numbers are related to each other. To convert between drawings and actual sizes, set up a proportion and solve. Proportions are practical tools for scaling, resizing, navigating, cooking, and solving many more real-life problems. So what's next? Review what you learned by doing the knowledge check. Then master what you learned by doing the practice activity. In the next lesson, you'll learn how to convert between different units of measurement. I'll see you there. In this lesson, you'll learn how to use proportions to convert between units of measurement and solve real-life problems. So let's get started. So what is a proportion? A proportion is a way to show that two ratios or fractions are equal. It's like saying that two groups of numbers are related to each other. So how do you solve problems using proportions? Proportions are a helpful way to solve word problems in math. To use proportions, you compare different numbers to find an unknown value. Here's how you do it. Step 1. Read the problem carefully and find what is known and what you need to find. Step 2. Set up a comparison using fractions or ratios based on the known information. Step 3. Solve for the unknown value by cross-multiplying and dividing. Now follow along as I solve this problem. A 3-foot-tall plant casts a shadow that is 12 feet long. If a gnome casts a shadow that is 5 feet long, how tall is the gnome? In this case, I know that the height of an object is proportional to the length of its shadow. So the taller the object, the longer the shadow. The shorter the object, the shorter the shadow. In this case, I need to solve for how tall the gnome is. To help me solve this problem, I can visualize it by drawing it out. I'm told that a 3-foot-tall plant casts a shadow that is 12 feet long. So I can draw a plant that is 3 feet tall and a shadow that is 12 feet long. I'm also told that a gnome casts a shadow that is 5 feet long. So I'll draw a shadow that is 5 feet long. And I'll draw a height and put a question mark, since I'm solving for the height of the gnome. Next, I can write a ratio with the height of the plant, which is 3 feet, over the length of its shadow, which is 12 feet. And then I can set that ratio equal to another ratio to solve for the unknown value, which is x. Since the length of the plant's shadow is on the bottom on the left side of the proportion, the length of the gnome's shadow should be on the bottom on the right side of the proportion, which is 5 feet. Since I'm solving for the height of the gnome, and the height of the plant is on the top on the left side of the proportion, the height of the gnome, which I'll call x, should be on the top on the right side of the proportion. Next, I need to multiply the two numbers that are diagonal from each other. which in this case is 3 and 5. 3 times 5 is 15. Then I need to divide my result by the number that is diagonal from the x, which is 12. 15 divided by 12 equals 1¼ So the height of the gnome is 1¼ feet tall. Now it's your turn to practice. Read the problem carefully and use a proportion to solve for the height of the flagpole. Pause the video, and when you found your answer, click play. A 10-foot tall tree casts a shadow that is 16 feet long. If a nearby flagpole casts a shadow that is 20 feet long, how tall is the flagpole? In this case, you need to solve for the height of the flagpole. To solve this problem, you can visualize it by drawing it out. You're told that a 10-foot tree casts a shadow that is 16 feet long. So you can draw a 10-foot tall tree and a shadow that is 16 feet long. You're also told that a flagpole casts a shadow that is 20 feet long. So you can draw a shadow that is 20 feet long. And you can draw a flagpole and put a question mark since you're solving for the height of the flagpole. Next, you can set up a ratio comparing the height of the tree, which is 10 feet, to the length of its shadow, which is 16 feet. Then you can set that ratio equal to another ratio to make a proportion. Since the length of the tree's shadow is 16 feet, which is on the bottom on the left side of the proportion, you need to write the length of the shadow of the flagpole on the bottom on the right side of the proportion, which is 20 feet. Since the height of the tree is on top on the left side of the proportion, you need to write the height of the flagpole on top on the right side of the proportion. Next, multiply the two numbers that are diagonal from each other, which is 10 and 20. 10 times 20 equals 200. Then divide the result by the number that is diagonal from the x, which in this case is 16. 200 divided by 16 equals 12½. So the height of the flagpole is 12½ feet. In addition to solving for unknown values, you can also use proportions to convert between different units of measurement. Here are some common units of measurement. Length is measured in meters, centimeters, inches, feet, and yards. Weight is measured in kilograms, grams, pounds, and ounces. Volume is measured in liters, milliliters, gallons, cups, and teaspoons. Distance is measured in kilometers and miles. And time is measured in seconds, minutes, and hours. In order to convert between different units of measurement, you need to use conversion factors. Conversion factors are ratios that help you convert one unit of measurement to another. They show you how the units are related to each other. For example, if you want to convert feet to inches, the conversion factor is 1 foot equals 12 inches. So how do you convert units of measurement? Step 1. Identify the starting unit and the desired unit. Step 2. Determine the conversion factor between the two units. Step 3. Set up a proportion and solve for x. For example, to convert 2 feet to inches, you would start by writing the conversion factor, which is 1 foot equals 12 inches. So 1 foot over 12 inches is equal to 2 feet over x inches. As you can see on the left side of the proportion, feet is on top and inches are on the bottom. On the right side of the proportion, feet is on top and inches are on the bottom. Once you set up the proportion, you can solve by cross-multiplying and dividing. Multiply the two numbers that are diagonal from each other, which in this case is 2 and 12. 2 times 12 equals 24. Then divide the result by the number that is diagonal from the x, which in this case is 1. 24 divided by 1 equals 24. So 2 feet is equal to 24 inches. Now follow along as I solve this problem. A flask can hold 500 milliliters of liquid. Convert this volume to liters. Hint: 1 liter equals 1,000 milliliters. In this case, I need to convert from milliliters to liters. To convert from milliliters to liters, I need to use the conversion factor to set up a proportion and solve. The conversion factor is 1 liter equals 1,000 milliliters, which I can write as a ratio: 1 liter over 1,000 milliliters is equal to x over 500 milliliters, since milliliters are on the bottom. Then I need to cross multiply the two numbers that are diagonal from each other, which in this case is 1 and 500. 1 times 500 is 500. And then I need to divide by the number that is diagonal from the x, which in this case is 1,000. 500 divided by 1,000 is equal to a half. So 500 milliliters is equal to half of a liter. Now it's your turn to practice. Set up a proportion to convert 3 pounds to ounces. Pause the video, and when you found your answer, click play. A package weighs 3 pounds. Convert this weight to ounces. Hint: 1 pound equals 16 ounces. In this case, you need to convert pounds to ounces. And the conversion factor is 1 pound equals 16 ounces. You can write this as a ratio: 1 pound over 16 ounces equals the weight of the package, which is 3 pounds, over x ounces, since ounces are on the bottom. Now that you set up your proportion, multiply the two numbers that are diagonal from each other, which in this case are 16 and 3. 16 times 3 equals 48. Then divide the result by the number that is diagonal from the x, which in this case is 1. 48 divided by 1 equals 48. So 3 pounds is equal to 48 ounces. Now let's review. A proportion is a way to show that two ratios or fractions are equal. It's like saying that two groups of numbers are related to each other. Proportions are helpful when you need to convert between units of measurement or solve certain types of problems. They work by comparing two ratios and finding an unknown value. Proportions can help you solve different types of problems, like conversions, rates, ratios, scaling, and percentages. With practice, you can use proportions to solve many real-life problems. So what's next? Review what you learned by doing the knowledge check. Then master what you learned by doing the practice activity. In the next lesson, you'll learn how to use the distance formula to find distance, time, and rate. I'll see you there. In this lesson, you'll learn how to use the distance formula to solve for distance, rate, and time. So let's get started. So what is the distance formula? The distance formula, distance equals rate times time, helps you find the distance traveled when you know how fast something is moving, the rate, and how long it takes, the time. Distance equals rate times time, or D equals RT, where D stands for distance, R stands for rate, and T stands for time. When solving word problems that involve distance, rate, and time, you need to be able to identify the distance, rate, and time in the problem. To identify the distance, look for a number followed by units of distance, such as 2 inches, 15 centimeters, 6 feet, 350 miles, or 1,200 kilometers. To identify the rate, look for a number followed by the word per between 2 units of measurement, such as 10 miles per gallon, 65 kilometers per hour, or $3 per pound. To identify the time, look for a number followed by units of time, such as 7 hours, 23 minutes, or 4 days. Solving for distance. You can use the formula distance equals rate times time to find the distance. Follow these 3 steps. Step 1. Figure out the rate or speed and time given in the problem. Step 2. Multiply the rate by the time. Step 3. The result is the distance traveled. For example, if a car is going 60 miles per hour for 2 hours, to find the distance, multiply 60 by 2. 60 times 2 equals 120, so the car traveled 120 miles in 2 hours. Now follow along as I solve this problem. A cyclist travels at a speed of 19 kilometers per hour. If he rides for 5 hours, how far has he traveled? In this question, I need to solve for how far he has traveled. How far is a measure of distance? And I know that distance equals rate times the time. To find the rate, I need to look for the keyword per, which I see here. That means that the speed or rate is 19 kilometers per hour, and I'll write an R nearby to remind myself that that's the rate. I can write 19 kilometers per hour as 19 kilometers over 1 hour, times the time. It says here that the cyclist rides for 5 hours. That's the time. I can write that as 5 hours over 1. Then I need to multiply 19 times 5. 19 times 5 is 95, and hours cross cancel, which leaves me with kilometers. So the distance traveled is 95 kilometers in 5 hours. Now it's your turn to practice. Read the problem carefully to find how far Lucas has traveled. Pause the video, and when you found your answer, click play. Lucas is hiking in the mountains. He walks at a constant speed of 13 miles per hour. If he hikes for 8 hours, how far has he traveled? In this case, you need to solve for how far he has traveled, which is a measure of distance. And distance equals rate times time. To find the rate, look for the keyword per, which you can see here, which tells you that the speed or rate is 13 miles per hour, which you can write as 13 miles over 1 hour, times the time. It says here that Lucas hikes for 8 hours, which is the time, which you can write as 8 over 1. Then, to find the distance, multiply 13 times 8, which is 104. Once again, the hours cross cancel, leaving you with miles. So Lucas travels 104 miles in 8 hours. Solving for rate. The distance formula, distance equals rate times time, can also be rearranged to solve for either the rate or speed or the time, depending on what information is given. To solve for rate, follow these 3 steps. Step 1. Identify the distance and the time values given in the problem. Step 2. Rearrange the formula to solve for rate, which gives you rate equals distance divided by time. Step 3. Divide the distance by the time to find the rate. For example, If the distance traveled is 150 miles in 3 hours, divide 150 by 3. 150 divided by 3 equals 50. So the rate of travel or speed is 50 miles per hour. Now follow along as I solve this problem. Emma is cycling along a straight path at a constant speed. After 4 hours of cycling, she has traveled a distance of 90 miles. What is Emma's average speed in miles per hour? In this case, I need to solve for Emma's average speed in miles per hour. The per is a signal that I need to solve for the rate. To find the rate, I need to rearrange the formula distance equals rate times time. To get the rate by itself, I need to move the t over to the left side of the equation. And I do that by doing the inverse operation of multiplication, which is division. So I'll divide both sides of the equation by t. T divided by t is 1, so the t's cancel out, leaving me with d, or distance, divided by t, or time, equals r, or the rate. And then I can move the r to the left side of the equation, and d over t to the right side, which gives me rate equals distance over time. In this case, Emma travels 90 miles, which is the distance. And she rides for 4 hours, which is the time. To find the rate, I divide the distance by the time. 90 divided by 4 is 22.5 miles per hour. So Emma rides 22.5 miles per hour. Now it's your turn to practice. Read the problem carefully to find Alex's average speed in kilometers per hour. Pause the video, and when you found your answer, click play. Alex is running in a marathon race. After 2.5 hours of running, he has covered a distance of 35 kilometers. What is Alex's average speed in kilometers per hour? In this case, you need to solve for Alex's speed in kilometers per hour. The per is a signal that you're solving for the rate. To solve for the rate, you need to rearrange the formula distance equals rate times the time. To get r by itself, divide both sides of the equation by t. T divided by t cancels out, leaving you with rate equals distance over time. In this case, the distance traveled is 35 kilometers. Divided by the time, which is 2.5 hours. To find the rate, divide 35 by 2.5, which is 14. That means that Alex was running at a rate or speed of 14 kilometers per hour. Solving for time. To solve for time, follow these 3 steps. Step 1. Identify the distance and rate values given in the problem. Step 2. Rearrange the formula to solve for time, which gives you time equals distance divided by rate. Step 3. Divide the distance by the rate to find the time. For example, if the distance traveled is 300 miles and the rate is 60 miles per hour, divide 300 by 60. 300 divided by 60 is 5. So the time taken to travel the distance is 5 hours. Now follow along as I solve this problem. John is driving from his home to a nearby city. He travels at an average speed of 60 miles per hour. If the distance to the city is 180 miles, how long will it take John to reach the city? In this case, I need to solve for how long it will take, which is a measure of time. To solve for time, I need to rearrange the formula distance equals rate times time. To get t by itself on one side of the equation, I need to move the r to the left side of the equation by doing the opposite or inverse of multiplication, which is division. So I'll divide both sides of the equation by r. R divided by r is 1, so the r's cancel out, leaving me with t, or time, is equal to d, or distance, divided by r, or the rate. In this case, the distance traveled is 180 miles. And the rate, or speed, is 60 miles per hour. To solve for the time, I need to divide 180 by 60, which is 3, and miles divided by miles cancels out, leaving me with hours. So it takes John 3 hours to travel to the nearby city. Now it's your turn to practice. Read the problem carefully to find out how long it will take for the car to reach City B. Pause the video, and when you found your answer, click play. A car travels from City A to City B at an average speed of 70 kilometers per hour. The distance between the two cities is 280 kilometers. How long will it take for the car to reach City B? In this case, you need to solve for how long it will take, which is a measure of time. To solve for time, you need to rearrange the formula distance equals rate times time. To get t by itself, divide both sides of the equation by r. R divided by r cancels out, leaving you with t equals d over r. The distance traveled is 280 kilometers. And the rate, or speed, is 70 kilometers per hour. To find the time it took to travel, divide 280 by 70, which is 4, and kilometers divided by kilometers cancels out, leaving you with hours. So it took the car 4 hours to travel from City A to City B. Now let's review. The distance formula, distance equals rate times time, helps you find the distance traveled when you know how fast something is moving, or the rate, and how long it takes, the time. So the distance formula is a simple way to find the distance when you know the rate and time. By rearranging the distance formula, you can solve for either the rate or the time depending on what information is provided. It allows you to find missing values in problems involving speed, time, and distance. So what's next? Review what you learned by doing the knowledge check. Then master what you learned by doing the practice activity. Then complete the unit review to check if you've mastered ratios and proportions. Do your best, and good luck! In this lesson, you'll learn how to simplify fractions. So let's get started. So what is a fraction? A fraction shows parts of a whole. It is made up of a numerator on top and a denominator on the bottom, and they're separated by a line known as a fraction bar. To remember that the denominator is on the bottom, the tip is that d in denominator can help you remember that it's down below. Here we have the fraction 7/10. The number on the bottom, or denominator, tells you the number of parts in a whole. Here the denominator is 10. So I would divide the whole amount into 10 equal parts, or 10 equal slices. The numerator on top tells you the number of parts you actually have. Here the numerator is 7, which means that 7 parts should be shaded. 1, 2, 3, 4, 5, 6, and 7. Now that shows 7/10, or 7 parts out of 10. So how do you read fractions? You read a fraction from top to bottom. So start with the numerator. The numerator on top is the number of actual slices of pizza that you have. The denominator on bottom is the total number of slices it would take to make up a whole pizza. When you put the numerator and denominator together, like in the fraction 3/8, you're saying that you have 3 out of 8 same-sized slices of pizza. Now let's talk about some common fractions. Fractions are really useful for describing parts of a whole when things are divided into smaller, equal pieces. For example, 1/2. Imagine you have a cupcake and you cut it into 2 equal pieces. If you have one piece, that's 1/2 of the whole cupcake. We can show 1/2 by dividing a whole amount into 2 equal parts and then shading in one of those parts. So that would be 1/2. Next we have 3/4. Think about a pie. If you cut it into 4 equal slices and you have 3 of those slices, then you have 3/4 of a pie. To show that, you would divide the pie into 4 equal slices and then fill in 3 of the 4 slices. 1, 2, and 3, which represents the fraction 3/4. Last we have 2/3. Picture a cake cut into 3 equal parts or 3 equal slices. If you take 2 of those slices, you have 2/3 of the cake. To show that, divide a whole into 3 equal parts and fill in 2 of the 3 parts. 1, 2, which represents the fraction 2/3. Now follow along as I solve this problem. What fraction represents the shaded portion? Well, here I can see that the whole amount has been divided into 3 equal parts, so the denominator must be 3. And one of those 3 parts is shaded, so the numerator is 1. That means 1/3 of it is shaded. Now it's your turn to practice. Pause the video and find the fraction that represents the shaded portion. When you found your answer, click play. What fraction represents the shaded portion? Start by finding the denominator. Here the whole has been split up into 5 equal parts, so the denominator is 5. And 4 of those parts are shaded, so the numerator is 4, which means that the fraction that is shaded is 4/5. Now let's talk about equivalent fractions. Fractions are equivalent when they represent the same value or the same amount of pizza or pie. Here we have 3 equivalent fractions: 1/2, which is 1 out of 2 equal slices, 2/4, which is 2 out of 4 equal slices, and 4/8, which is 4 out of 8 equal slices. Here you can see that all 3 fractions represent the same amount. So how do you make equivalent fractions? The answer is to use whole fractions. A whole fraction has the same numerator and denominator. For example, 2/2 or 2/2 is a whole fraction because 2/2 is really one whole. In fact, all whole fractions simplify to 1. When you multiply or divide a number by 1, its value stays the same. So when you multiply or divide a fraction by a whole fraction like 2/2, you get an equivalent fraction. Its numerator and denominator change, but its value stays the same. For example, here you have the fraction 1/2, and when you multiply it by 2/2 or 2/2, you get the equivalent fraction 2/4. When you take the fraction 2/4 and multiply it by the whole fraction 2/2 or 2/2, you get the equivalent fraction of 4/8. Now let's talk about simplifying fractions using division. To simplify a fraction, make the numerator and denominator smaller by dividing them by the same common factor. For example, the fraction 4/8 can be simplified by dividing the numerator and denominator by their common factor of 2. So 4 divided by 2 is 2, and 8 divided by 2 is 4. So 4/8 simplifies to 2/4. 2/4 can be simplified further, because 2 and 4 have a common factor of 2. So 2 divided by 2 is 1, and 4 divided by 2 is 2. So 2/4 simplifies to 1/2, which is a fraction in its simplest form. One way to simplify fractions is to divide the numerator and denominator by their greatest common factor. So in step number 1, you need to find the greatest common factor of the numerator and denominator. Remember, the greatest common factor is the largest number that can divide both the numerator and denominator without leaving a remainder. Then, divide both the numerator and denominator by the greatest common factor. Finally, write the simplified fraction using the new numerator and denominator. For example, let's simplify the fraction 12/18. Well, I'll start by finding the greatest common factor of 12 and 18. Here, I can use any method I want to find the greatest common factor. I can list out the factors, I can write the prime factorizations, or I can use the birthday cake method. If you use any one of those 3 methods, you'll find that the greatest common factor of 12 and 18 is 6. So I'll divide the numerator by 6, and I'll divide the denominator by 6. Which means my new fraction is 12 divided by 6, which is 2, and 18 divided by 6 is 3. So the simplified fraction is 2/3. Another way to simplify fractions is to use divisibility rules to divide and conquer. Let's review the most common divisibility rules. A number is divisible by 2 if the last digit is even. That is, the last digit is 0, 2, 4, 6, or 8. For example, the number 576 is divisible by 2 because it ends in 6, which is an even number. A number is divisible by 3 if the sum of its digits is divisible by 3. For example, if I want to know if 537 is divisible by 3, I would add up its digits, 5 plus 3 plus 7, which equals 15. And I know that 15 is divisible by 3 because 15 divided by 3 is 5, which means the number 537 is also divisible by 3. A number is divisible by 5 if the last digit is 5. For example, the number 285 is divisible by 5 because it ends in the number 5. A number is divisible by 5 and 10 if the last digit is 0. For example, the number 970 is divisible by both 5 and 10 because it ends in the number 0. Now let's use the divisibility rules to simplify the fraction 12/18. Here I can see that both the numerator and denominator end in even numbers, which means that they're divisible by 2. So I can divide the numerator and the denominator by 2. 12 divided by 2 is 6, and 18 divided by 2 is 9. But I can simplify 6 and 9 even further, because 6 and 9 have a common factor of 3. So I can divide 6 by 3 and 9 by 3. 6 divided by 3 is 2, and 9 divided by 3 is 3. And the only common factor of 2 and 3 is 1, which means that 2/3 is the fraction in simplest form. Now follow along as I simplify this fraction. Here I have the fraction 7/14. I can ask myself, what is the greatest common factor of 7 and 14? And the answer is 7, which means I'll divide the numerator and the denominator by 7. 7 divided by 7 is 1, and 14 divided by 7 is 2, which means 1/2 is the fraction in simplest form. Now it's your turn to practice. Pause the video and simplify 28/42. And when you found your answer, click play. One way to simplify this fraction is to divide the numerator and denominator by their greatest common factor. Here, the greatest common factor of 28 and 42 is 14. 28 divided by 14 is 2, and 42 divided by 14 is 3. Since the greatest common factor of 2 and 3 is 1, 2/3 is the answer in simplest form. Another way to simplify this fraction is in steps, by using the divisibility rules. Here you can see that 8 and 2 are even numbers, which means they're divisible by 2. So divide the numerator and the denominator by 2. 28 divided by 2 is 14, and 42 divided by 2 is 21. Once again, ask yourself, is there a common factor that divides into 14 and 21? And the answer is 7. So divide the numerator and denominator by 7. 14 divided by 7 is 2, and 21 divided by 7 is 3. As you can see, you get the same answer, 2/3. Now follow along as I solve this problem. Emma and her friends are sharing a sub sandwich at a birthday party. The sandwich is divided into 10 equal pieces. Emma ate 3 of those pieces, and her friend Alex ate 2 pieces. What fraction of the sandwich did Emma eat? What fraction did Alex eat? Well, in this case, we're trying to find what fraction of the sandwich Emma ate and what fraction of the sandwich Alex ate. The sandwich was divided into 10 equal slices, so in both cases, the denominator will be 10. Emma ate 3 slices, so the numerator for Emma is 3. And Alex ate 2 slices, so the numerator for Alex is 2. 3/10 cannot be simplified because the greatest common factor of 3 and 10 is 1, so Emma ate 3/10 of the sandwich. Alex ate 2/10 of the sandwich, and 2 and 10 are both even numbers, so they're both divisible by 2, which means I can simplify by dividing the numerator and denominator by 2. 2 divided by 2 is 1, and 10 divided by 2 is 5, which gives me the fraction 1/5. Since the greatest common factor of 1 and 5 is 1, 1/5 is the final answer. So Alex ate 1/5 of the sandwich. Now it's your turn to practice. Pause the video and solve the word problem. When you found your answers, click play. During a festive family gathering, a cake was divided into 16 equal slices. Lucy and her brother Max shared some of the cake. Lucy ate 4 slices, while Max ate 5 slices. What fraction of the cake did Lucy eat? What fraction did Max enjoy? In this problem, you need to solve for the fraction of cake that Lucy ate and the fraction of cake that Max ate. In both cases, the denominator is 16 because the cake was divided into 16 equal slices. Lucy ate 4 of those slices, while Max ate 5 of those slices. So Lucy ate 4/16 of the cake. But this fraction can be simplified because 4 and 16 have a greatest common factor of 4. So you can divide the numerator and denominator by 4. 4 divided by 4 is 1, and 16 divided by 4 is 4, which means that Lucy ate 1/4 of the cake. Max ate 5/16 of the cake, but the greatest common factor of 5 and 16 is 1, which means this fraction can't be simplified, so Max ate 5/16 of the cake. Now let's review. A fraction shows parts of a whole. A fraction has a numerator on top that tells you how many parts you have, and a denominator on bottom that tells you the number of parts in a whole. To simplify fractions, divide the numerator and denominator by their greatest common factor. Or you can also simplify in steps by dividing the numerator and denominator by their common factors. So what's next? Review what you learned by doing the knowledge check. Then master what you learned by doing the practice activity. In the next lesson, you'll learn how to compare fractions to determine which fraction is larger or smaller. I'll see you there. In this lesson, you'll learn how to compare fractions. So let's get started. Here's some everyday situations where you might need to compare fractions. Imagine you get your monthly paycheck. You need to decide how much of it to set aside for rent and groceries. If you have to save 1/4 of your money for rent and 1/5 for groceries, you want to see which one takes a bigger portion of your paycheck. When you're following a recipe, it might say you need 1/2 cup of sugar for one dish and 3/4 cup for another. You're just trying to figure out which recipe needs more sugar. Now let's talk about comparing fractions. On the left-hand side, we have 1/2 and 2/4. 1/2 means I'll divide the whole into 2 equal parts, and 1/2 means I have one of those 2 parts. So that would be 1/2. Next, I have 2/4, which means I'll divide the whole into 4 equal parts, and 2/4 means I have 2 of those parts. 1, 2. So that's 2/4. As you can see, 1/2 is equal to 2/4. They're equivalent fractions. So we write 1/2 equals 2/4. Next, we need to compare 5/6 and 3/6. Here, both fractions have the same denominator, which is 6, which means the wholes are divided into 6 equal parts, or 6 slices of the same size. 5/6 means I have 5 out of the 6 slices. 1, 2, 3, 4, 5. So that is 5/6. 3/6 means I have 3 out of the 6 slices. 1, 2, 3. That's 3/6. As you can see, 5/6 is greater than 3/6, which makes sense because 5/6 has more slices than 3/6, and the slices are the same size. Last, we have 5/10 and 5/9. Here, the numerators are the same. They're both 5, which means that they both have 5 slices. Here, the whole has been divided into 10 equal parts. So 5/10 would be 5 of those parts. 1, 2, 3, 4, and 5. That's 5/10. Below, the whole has been divided into 9 equal parts, and 5/9 means we have 5 of those parts. 1, 2, 3, 4, and 5. So that's 5/9. As you can see, 5/10 is a little bit less than 5/9, which makes sense because tenths are slightly smaller than ninths. Even though they have the same number of slices, the slices on top are slightly smaller than the slices on the bottom. So how do you compare fractions? First, check for a common denominator. To compare fractions, it's helpful if they have the same denominator. If the fractions already have the same denominator, you can skip to step 4. In this example, we need to compare 1/4 and 3/8. Here, the denominators are 4 and 8, which means we need to make them have the same denominator. So we need to find the least common denominator. If the fractions have different denominators, find a common denominator. The least common denominator is the lowest common multiple of the denominators. For example, if you have the fractions 1/4 and 3/8, the common denominator would be 8. That's because the least common multiple of 4 and 8 is 8. So we need to make like fractions. To do this, multiply both the numerator and the denominator of each fraction by the same number, so the denominator matches the least common denominator. For instance, for the fractions 1/4 and 3/8, with the least common denominator of 8, you would convert 1/4 to 2/8. To convert 1/4 to 2/8, you need to ask yourself, what number can I multiply 4 by to give me 8? And the answer is 2. So multiply the numerator and the denominator by 2. 1 times 2 is 2, and 4 times 2 is 8. So 1/4 is equal or equivalent to 2/8. Now we can compare the numerators. Now that both fractions have the same denominator, you can compare them by looking at the numerators. The fraction with the larger numerator is the larger fraction. For example, 2/8 is less than 3/8 because 2 is less than 3. Now follow along as I solve this problem. When comparing the fractions 7/12 and 5/12, which of the following statements is true? Well, here I need to compare the fraction 7/12 and the fraction 5/12. Here the fractions have the same denominator. They both have 12 as their denominators. So I can go ahead and compare the numerators. In this case, I always compare left to right. And 7 is greater than 5. So 7/12 is greater than 5/12. The answer is B. Here's a tip for thinking about less than and greater than. Think of them as hungry alligator mouths that always want to eat the bigger number. For example, 3 is less than 5, and 5 is greater than 3. As you can see, the alligator or Pac-Man always wants to eat the bigger number. Now it's your turn to practice. Pause the video and compare the fraction 9/15 and 11/15. When you found your answer, click play. When comparing the fractions 9/15 and 11/15, which of the following statements is true? Well, here you need to compare the fraction 9/15 with 11/15. Here the denominators are the same, so you can go ahead and compare the numerators. In this case, 9 is less than 11, so 9/15 is less than 11/15. The answer is A. As you can see, the alligator or Pac-Man eats the bigger number. Now follow along as I solve this problem. Which of the following statements is true when comparing the fraction 3/4 and 6/8? Here I need to compare the fraction 3/4 and 6/8. First I need to see if the denominators are the same. In this case, the denominators are different. I have a 4 and an 8. So now I need to ask myself, what is the lowest common multiple of 4 and 8, which will give me the least common denominator? And the lowest common multiple of 4 and 8 is 8. So I need to convert the fourths to eighths. So I need to ask myself, 4 times what equals 8? And I know that 4 times 2 equals 8. So I'll multiply the numerator and denominator by 2. In this case, I have 3 times 2, which is 6, and 4 times 2, which is 8. So 3/4 is equal to 6/8, and 6/8 is equal to 6/8. That means 3/4 is equal to 6/8. They're equivalent fractions, so the answer is C. Another way to solve this problem is to simplify 6/8 so the denominator is 4. So I can ask myself, 8 divided by what equals 4? And I know that 8 divided by 2 equals 4. So I can divide the numerator and denominator by 2. 6 divided by 2 is 3, and 8 divided by 2 is 4, which means that 6/8 is equivalent to 3/4. So 3/4 is equal to 6/8. So once again, the answer's C. Now it's your turn to practice. Pause the video and compare the fractions 15/18 and 5/6. When you found your answer, click play. Here you need to compare the fractions 15/18 and 5/6. First ask yourself, Are the denominators the same? And in this case, the denominators are different. So next you need to find the least common denominator by finding the least common multiple of 6 and 18, which is 18. So you need to ask yourself, 6 times what equals 18? And 6 times 3 equals 18. So multiply the numerator and denominator by 3. 5 times 3 is 15, and 6 times 3 is 18, which means that 5/6 is equivalent to 15/18. So 15/18 is equal to 5/6. The answer is B. Another way to solve this problem is to simplify the fraction 15/18 so it has a denominator of 6. So you need to ask yourself, 18 divided by what equals 6? And 18 divided by 3 equals 6. So divide 15 by 3 as well. 15 divided by 3 is 5, and 18 divided by 3 is 6. So once again, 15/18 is equal to 5/6. So once again, the answer is B. Now follow along as I solve this problem. When comparing the fractions 3/5 and 3/7, which of the following statements is true? Here I need to compare the fractions 3/5 and 3/7. I notice that the denominators are different, but the numerators are the same, which means I can compare the denominators. Fifths are larger than sevenths, because with fifths, the whole has been divided into 5 equal parts, so the parts are larger. Whereas with sevenths, the whole has been divided into 7 equal parts, so the parts are smaller. Since they both have the same number of parts, but the parts for fifths are larger, I can say that 3/5 is greater than 3/7. Another way to compare these fractions is to make them have the same denominator, and then compare the numerators. So to find the least common denominator of 5 and 7, I need to ask myself, what is the lowest common multiple of 5 and 7, which is 35. So I need to convert both of the fractions so their denominators are 35. So first I need to ask myself, 5 times what equals 35? And 5 times 7 equals 35. So I'll multiply the numerator and denominator by 7. 3 times 7 is 21, and 5 times 7 is 35. So 3/5 is equivalent to 21 over 35. And I need to convert the 7 to 35. So I need to ask myself, 7 times what equals 35? And that is 5. So I need to multiply the numerator and denominator by 5. 3 times 5 is 15, and 7 times 5 is 35. Now I made like fractions because they both have the same denominator, so I can compare the numerators. 21 is greater than 15, which means that 3/5 is greater than 3/7. So once again, the answer is A. Now it's your turn to practice. Pause the video, and when you compare 6/10 and 6/8 and get your answer, click play. When comparing the fractions 6/10 and 6/8, which of the following statements is true? Here you need to compare the fractions 6/10 and 6/8. Here the denominators are different, and the numerators are the same, so you can compare the denominators. Tenths are smaller than eighths, because with tenths, the whole amount has been divided into 10 equal parts, so there are more parts, which means they're smaller. Whereas eighths have been divided into fewer equal parts, so the parts are larger. Since they have the same number of parts, and the tenths are smaller parts, you can say that 6/10 is less than 6/8. So the answer is D. Another way to compare these fractions is to make them have the same denominator. Here the denominators are 10 and 8, so you need to find the least common denominator for 10 and 8. So you need to ask yourself, what is the lowest common multiple of 10 and 8, which is 40? So you need to make both fractions have a denominator of 40. So ask yourself, 10 times what equals 40? And 10 times 4 equals 40. So multiply the numerator and denominator by 4. 6 times 4 is 24, and 10 times 4 is 40. Then ask yourself, 8 times what equals 40? And 8 times 5 equals 40. So multiply the numerator and denominator by 5. 6 times 5 is 30, and 8 times 5 is 40. Now both fractions have the same denominator, so you can compare the numerators. 24 is less than 30, which means 6/10 is less than 6/8. So once again, the answer is D. Now follow along as I solve this problem. When comparing the fractions 3/5 and 4/7, which of the following statements is true? In this case, I need to compare the fractions 3/5 and 4/7. I could use one of the methods I have shown you already, but another way to solve this is to cross-multiply the fractions and then compare their products. I'll start by multiplying from the top left to the bottom right, which gives me 3 times 7, which is 21, and then from the bottom left to the upper right, which gives me 5 times 4, which is 20. And then I can compare their products. 21 is greater than 20. So 3/5 is greater than 4/7. The answer is A. You can use this method to compare any two fractions. Now it's your turn to practice. Pause the video, and when you have your answer, click play. When comparing the fractions 5/8 and 2/3, which of the following statements is true? Here I could use any of the methods I showed you before, or you could use the cross-multiply and compare method, in which case you would multiply 5 times 3, which is 15, and 8 times 2, which is 16, and then compare the results. 15 is less than 16, so 5/8 is less than 2/3. The answer is C. Now let's review. Comparing fractions involves determining which fraction is larger or smaller. Here are 4 steps to compare unlike fractions, or fractions with different denominators. First, check for a common denominator. If the fractions already have the same denominator, you can skip to step 4. Then, find the least common denominator, or the least common multiple of the denominators. Then, make like fractions, or make the fractions have the same denominator. Finally, compare the numerators. Knowing how to compare fractions is useful in everyday life. For example, you compare fractions when cooking or budgeting. So what's next? Review what you learned by doing the knowledge check. Then master what you learned by doing the practice activity. In the next lesson, you'll learn how to convert between improper fractions and mixed numbers. So I'll see you there. In this lesson, you'll learn how to convert between improper fractions and mixed numbers. So let's get started. First, let's talk about proper fractions. So what is a proper fraction? A proper fraction is like a piece of something smaller than one whole thing. Imagine you have a pizza, and you only ate a part of it. If you ate just one slice out of 8 slices, you'd have eaten 1/8 of the pizza. 1/8 is a proper fraction because the top number, the numerator, is smaller than the bottom number, the denominator. Then what is an improper fraction? An improper fraction is when the top number, the numerator, is equal to or bigger than the bottom number, the denominator. It's like having more than one whole thing. If you have 7 out of 4 slices of a cake, you have 7/4 of a cake, which is an improper fraction because you have more than one whole cake. You can visualize this as 1, 2, 3, 4, 5, 6, 7/4 of a cake. If you add up the slices, you can see that you have a whole cake plus a part of another cake. So 7/4 of a cake is really more than one whole cake. Now what is a mixed number? A mixed number is a combination of a whole number and a proper fraction. It's used to show whole things and parts together. Imagine you have a whole pie and half of another pie. You can express this as a mixed number, 1½ You can visualize this as one whole cake plus half of another cake. Follow these steps to convert an improper fraction to a mixed number. Step 1. Divide the numerator by the denominator. For example, to convert the improper fraction 5/3 to a mixed number, you would first divide the numerator, which is 5, by the denominator, which is 3. 3 goes into 5 one whole time. 1 times 3 is 3, and 5 minus 3 is 2. Step 2. Use the quotient as the whole number and the remainder as the numerator. In this case, the quotient is 1, so the whole number in the mixed number is 1. The remainder is 2, so the numerator in the fraction part of the mixed number is 2. Step 3. Keep the denominator the same. In this case, the denominator is 3, so keep the same denominator. So 5/3 is equal to 1 2/3. Now follow along as I convert 11/4 to a mixed number. Here I have the improper fraction 11/4. To convert 11/4 to a mixed number, I need to divide the numerator, which is 11, by the denominator, which is 4. 4 goes into 11 two whole times. 2 times 4 is 8, and when I subtract 8 from 11, I get a remainder of 3. The quotient becomes the whole number in the mixed number, which is 2. The remainder, which is 3, becomes the numerator of the fraction part, and the denominator, which is 4, stays the same. So 11/4 is equal to 2 3/4 as a mixed number. Now it's your turn to practice. Follow the steps you just learned to convert 8/5 to a mixed number. Pause the video, and when you found your answer, click play. To convert the improper fraction 8/5 to a mixed number, divide the numerator by the denominator. The numerator is 8, and the denominator is 5. 5 goes into 8 one whole time. 1 times 5 is 5, and 8 minus 5 is 3. The quotient, which is 1, becomes the whole part of the mixed number. The remainder, which is 3, becomes the numerator of the fraction part of the mixed number. And the denominator, which is 5, stays the same. So 8/5 is equal to 1 3/5 as a mixed number. So how do you convert a mixed number to an improper fraction? Follow these 3 steps. Step 1. Multiply the whole number by the denominator. In this case, the whole number is 1, and the denominator is 3. 1 times 3 equals 3. Step 2. Then add the numerator. In this case, the numerator is 2. 3 plus 2 equals 5. So 5 is the new numerator. Step 3. Write the sum over the same denominator. The sum is 5, and the denominator is 3. So 1 2/3 is equal to 5/3 as an improper fraction. Now follow along as I convert 2 3/4 to an improper fraction. To convert the mixed number 2 3/4 to an improper fraction, I need to multiply the whole number by the denominator. 2 times 4 equals 8. And then I need to add the numerator, which is 3. 8 plus 3 equals 11. And then I need to keep the same denominator, which is 4. So 11 over 4. As you can see, 2 3/4 as an improper fraction is equal to 11/4. Now it's your turn to practice. Follow the steps you just learned to convert 3 1/2 to an improper fraction. Pause the video, and when you're done, click play. To convert the mixed number 3 1/2 to an improper fraction, start by multiplying the whole number by the denominator, which is 3 times 2, which equals 6. Then add the numerator, which is 1. 6 plus 1 equals 7. Then write the new numerator over the denominator, which is 2. As you can see, 3 1/2 is equal to 7/2 as an improper fraction. Now let's review. An improper fraction is when the top number, the numerator, is equal to or greater than the bottom number, the denominator. It's like having more than one whole thing. A mixed number is a combination of a whole number and a proper fraction. It's used to show whole things and parts together. Converting between improper fractions and mixed numbers makes it easier to compare, solve problems, and work with fractions in different situations. So what's next? Review what you learned by doing the knowledge check. Then master what you learned by doing the practice activity. In the next lesson, you'll learn how to add fractions and mixed numbers to solve real-life problems. I'll see you there. In this lesson, you'll learn how to convert between improper fractions and mixed numbers using a TI-30XS multi-view calculator. So let's get started. First, I want to convert the improper fraction 7/15 to a mixed number. To do that, I first need to type in the numerator, which is 17. And then I need to press the fraction button, which is the n over d or numerator over denominator button. And then I need to type in the denominator, which is 5. And then I need to press the right arrow, and then the second button. And then I need to press this x times 10 to the nth power button, because as you can see on top, it'll convert n over d, which is a fraction, to un over d, which is a mixed number, and vice versa. And then I need to press enter. As you can see, the calculator converts 7/15 to a mixed number, so 7/15 is equal to 3 2/5. Now it's your turn to practice. Pause the video and convert 11/4 to a mixed number. And when you found your answer, click play. To convert 11/4 to a mixed number, first type in the numerator, which is 11. And then press the n over d button. And then enter the denominator, which is 4. And then press the right arrow, and then press second, and then press x times 10 to the nth power button to convert an improper fraction to a mixed number and vice versa. Then press enter. As you can see, 11/4 is equal to 2 3/4. Now let's practice how to convert a mixed number to an improper fraction. For example, I want to convert the mixed number 7 5/9 to an improper fraction. So first I'll type in the whole number, which in this case is 7. And then I'll press second, and then the n over d button, which changes it to a mixed number format. And then I'll type in the numerator, which is 5, and then the down arrow, and then the denominator, which is 9, and then I'll press right arrow, and then I'll press enter. As you can see, the calculator converts the mixed number 7 5/9 to an improper fraction, which is 68/9. Now it's your turn to practice. Pause the video and convert the mixed number 7 3/4 to an improper fraction. And when you found your answer, click play. To convert 7 3/4 to an improper fraction, first type in the whole number, which is 7, and then press second, and then the n over d button, which will change it to a mixed number format. And then enter the numerator, which is 3. And then press the down arrow, and then the denominator, which is 4, and then the right arrow, and then press enter. So the mixed number 7 3/4 is 31/4 as an improper fraction. Now you know how to convert between improper fractions and mixed numbers using a TI-30XS multi-view calculator. In this lesson, you'll learn how to add like and unlike fractions. So let's get started. So what are like fractions? Like fractions are fractions that have the same bottom number, which is called the denominator. The parts, or slices of pizza, are equal in size, making them like fractions. Adding like fractions is easy because you just add the top numbers, the numerators, while keeping the bottom number, the denominator, the same. Now imagine you're adding slices of pizza, and each pizza has been divided into 4 equal slices. Here you have 2 slices. 1, 2. So you have 2/4 of a pizza. And then you add another 2 slices. 1, 2, which is another 2/4 of a pizza. When you add them together, you end up with 4 slices. 1, 2, 3, 4, which equals 4/4 of a pizza, or 1 whole pizza. As you can see, you simply add the numerators. 2 plus 2 equals 4, and keep the same denominator, which is 4. And then you can simplify by dividing. 4 divided by 4 equals 1, or 1 whole pizza. Now follow along as I add 1/9 and 2/9. Here I need to add the numerators. 1 plus 2 equals 3, and keep the same denominator, which is 9, which gives me the answer 3/9. But I can simplify my answer by a factor of 3, because 3 divided by 3 equals 1, and 9 divided by 3 equals 3. So 3/9 simplifies to 1/3. Now it's your turn to practice. Add 4/7 and 1/7. Pause the video, and when you're done, click play. To add the fractions 4/7 and 1/7, simply add the numerators. 4 plus 1 equals 5, and keep the same denominator, which is 7. Here you can't simplify your answer, so your final answer is 5/7. Now follow along as I solve this word problem. You're reading a book series and you finished 1/5 of the first book and 2/5 of the second book. How much of the series have you read in total? In this question, I need to find the total amount that I've read. So I need to add the fractions 1/5 plus 2/5. In this case, I'm adding like fractions, meaning they both have the same denominator, which is 5. So I simply need to add the numerators and keep the same denominator. 1 plus 2 equals 3, and the denominator is 5. In this case, I can't simplify 3/5, so my final answer is 3/5 of the series. Now it's your turn to practice. Find how much fence is painted in total. Pause the video, and when you found your answer, click play. You and your friend are painting a fence. You've already painted 3/8 of it, and your friend painted 2/8 of it. How much of the fence is painted in total? In this case, you need to find how much of the fence is painted in total. So you need to add the fractions 3/8 plus 2/8. Here you're adding like fractions because they have the same denominator, which is 8. So you simply need to add the numerators. 3 plus 2 equals 5. That gives you the fraction 5/8, which can't be simplified So the final answer is 5/8 of the fence. So what about adding unlike fractions? Unlike fractions are fractions that have different bottom numbers or different denominators. When you want to add unlike fractions, you need to make them have the same denominator, just like making sure all the pieces or slices are the same size. Once they have the same denominator, you can add them by adding the numerators while keeping the denominator the same. For example, imagine you're adding slices of pizza, where one pizza has been divided into 6 equal slices, or 1/6. Imagine you only have one of those slices, which means you have 1/6 of a pizza. Now imagine you have another pizza that's been divided into 8 equal slices, or 1/8. And imagine you have one of those slices, which is 1/8 of a pizza. If you wanted to add 1/6 of a pizza to 1/8 of a pizza, you wouldn't be able to simply add the numerators because the slices are different sizes. So you first need to make the slices the same size, which is the same thing as making the denominators the same. This makes the fractions like fractions, so you can add the numerators and keep the same denominator. So how do you add unlike fractions? Step 1. Find the least common denominator. To find the least common denominator, you need to find the least common multiple or LCM of the denominators. Here you have the fractions 1/3 plus 1/4. The least common denominator or least common multiple of 3 and 4 is 12. So I'll rewrite the fractions with denominators of 12. Step 2. Rename each fraction. Make the fractions have the same denominator. To make 1/3 equal to something over 12ths, I can multiply the denominator by 4, which means I have to multiply the numerator by 4. 4 times 3 is 12, and 4 times 1 is 4. So 1/3 becomes 4/12ths. To convert 1/4 to something over 12, I know that 4 times 3 equals 12. So I have to multiply the numerator, which is 1, by 3 as well. 1 times 3 is 3. So 1/4 becomes 3/12ths. Step 3. Add the fractions. Now that you have like fractions, you can add the numerators and keep the same denominator. Simplify if possible. Here you have 4/12ths plus 3/12ths, so I can simply add the numerators. 4 plus 3 is 7, and keep the same denominator, which is 12, and 7/12ths can't be simplified, so the final answer is 7/12ths. Now follow along as I solve this problem. Add 4/5ths and 1/12ths. To add 4/5ths and 1/12ths, I need to make them have the same denominator. In this case, the least common denominator or least common multiple of 5 and 12 is 60. So I'll rewrite the fractions over 60. 5 times 12 equals 60. And 4 times 12 equals 48. So 4/5ths becomes 48/60ths. And 12 times 5 equals 60. So 1 times 5 equals 5. So 1/12ths equals 5/60ths. Now I have like fractions, so I can add the numerators. 48 plus 5 equals 53 over 60. I can't simplify 53 over 60, so the final answer is 53/60ths. Now it's your turn to practice. Add 3/8 and 5/16. Pause the video, and when you found your answer, click play. To add the fractions 3/8 and 5/16, you need to make them have the same denominator. The least common denominator or least common multiple of 8 and 16 is 16. So I'll rewrite the fractions over 16. Here I know that 8 times 2 equals 16. So I'll multiply the 3 by 2 as well, which gives me 2 times 3 is 6. So 3/8 is really 6/16. And I can just move the 5 over because it's already over 16. Now I can add the numerators. 6 plus 5 is 11, and keep the same denominator. 11/16 can't be simplified, so the answer is 11/16. Now follow along as I solve this problem. During your summer vacation, you traveled 2/5 of the distance by car and 1/3 of the distance by train. What fraction of the total distance have you covered so far? In this case, I'm solving for the total distance. So I need to add the fractions 2/5 plus 1/3. Here I have unlike fractions because they have different denominators. I know that the least common denominator or least common multiple of 5 and 3 is 15. So I'll rewrite the fractions over 15. Now 5 times 3 equals 15, and 2 times 3 equals 6. So 2/5 becomes 6/15. 3 times 5 equals 15, and 1 times 5 equals 5. So 1/3 becomes 5/15. Now I have like fractions with the same denominator, so I can add the numerators. 6 plus 5 equals 11 over 15. 11/15 can't be simplified, so my final answer is 11/15. Now it's your turn to practice. Solve for how much tape Samantha needs. Pause the video, and when you found your answer, click play. Samantha is taping a box. She needs to cut a piece of tape that is 1/4 of a foot long, and another piece that is 5/8 of a foot long. How much tape does she need? In this case, you need to solve for the total amount of tape that she needs. So you need to add the fractions 1/4 plus 5/8. Here you're adding unlike fractions, so you need to make them have the same denominator. The least common denominator or least common multiple of 4 and 8 is 8, so rewrite the fractions over 8. Now 4 times 2 equals 8, and 1 times 2 equals 2. So 1/4 becomes 2/8, and 5/8 stays the same. Now you have like fractions, so you can add the numerators. 2 plus 5 equals 7 over 8. And 7/8 can't be simplified, so Samantha needs 7/8 of a foot of tape. Now let's review. Like fractions are fractions that have the same bottom number, which is called the denominator. Adding like fractions is easy because you just add the top numbers or numerators while keeping the bottom number or denominator the same. Unlike fractions are fractions that have different bottom numbers or different denominators. When you want to add unlike fractions, you need to make them have the same denominator, just like making sure all the pieces or slices are the same size. Once they have the same denominator, you can add them by adding the numerators while keeping the denominator the same. Understanding how to add fractions is important because it helps you combine and work with pieces of things, like when you're cooking or building things. So what's next? Review what you learned by doing the knowledge check. Then master what you learned by doing the practice activity. In the next lesson, you'll learn how to add with mixed numbers. I'll see you there. In this lesson, you'll learn how to add with mixed numbers. So let's get started. The first method for adding with mixed numbers is to add the fractions and whole numbers separately and then combine them at the end. In step 1, you need to add the fractions. You can convert the result to a mixed number if needed. Here, I would add the fractions 1/3 and 4/5, which would be 1/3 plus 4/5. Here I have different denominators, so I need to make them have the same denominator. So I can ask myself, what is the lowest common multiple of 3 and 5? To find the lowest common multiple of 3 and 5, I can list the multiples of 3 and 5. 3, 6, 9, 12, 15. And 5, 10, 15. Here the lowest common multiple is 15. So I can ask myself, 3 times what equals 15? And 3 times 5 equals 15. So I need to multiply the 1 by 5 as well. Then I can ask myself, 5 times what equals 15? Well, 5 times 3 equals 15. So I need to multiply the 4 by 3 as well. Then I can rewrite the fractions over 15. And I know that 1 times 5 is 5, and 4 times 3 is 12. So now the fractions become 5/15 plus 12/15. Here I have the same denominator, so I can go ahead and add the numerators. 5 plus 12 is 17 over 15. Here the result is an improper fraction because the numerator on top is bigger than the denominator on the bottom. So I need to convert the result to a mixed number by dividing the numerator on top by the denominator on the bottom, which gives me 17 divided by 15. 15 goes into 17 one whole time, which means I have a remainder of 2. And the remainder becomes the numerator on top in the fraction part, and the divisor on the outside becomes the denominator. So the denominator is 15. So the result is 1 and 2/15. In step number 2, I need to add the whole numbers, which are 2, 3, and 1. So 2 plus 3 plus 1 equals 5 plus 1, which is 6. And then I need to combine the whole part and the fraction part. So in this case, I need to bring over the fraction 2/15, which means the final answer is 6 and 2/15, because 2/15 can't be simplified. Another way to solve this problem is to convert the mixed numbers to improper fractions and then add them together. So to convert 2 1/3 to an improper fraction, I need to multiply the denominator times the whole number, which is 3 times 2, which is 6, and then add the numerator, which is 6 plus 1, which gives me 7, and keep the denominator the same. So 2 1/3 becomes 7/3. 5 times 3 is 15, plus 4 is 19. So 3 4/5 becomes 19/5. Once again, the denominators are different, so I need to make them have the same denominator. The lowest common multiple of 3 and 5 is 15. So I'll multiply 3 by 5 and 7 by 5. And I'll multiply 5 by 3 and 19 by 3. 7 times 5 is 35, and 3 times 5 is 15. 19 times 3 is 57, and 5 times 3 is 15. Now I have the same denominator since they're both over 15, so I can add the numerators. 35 plus 57 is 92, and the denominator stays 15. Once again, the result is an improper fraction, so I need to convert it to a mixed number by dividing the numerator on top, which is 92, by the denominator on the bottom, which is 15. 15 goes into 92 6 whole times, because 6 times 15 is 90, which means the remainder is 2. Once again, the remainder becomes the numerator in the fraction part, and the divisor on the outside stays the denominator. As you can see, I got the same answer as using the other method. The answer is 6 and 2/15. So to review the steps, I first converted the mixed numbers to improper fractions, and then I added the fractions like normal. Last, I converted my answer back to a mixed number. Now follow along as I solve this problem. Here I need to add 5 3/4 plus 1 1/4. In this case, I'll use the first method, so I'll first add the fractions, which is 3/4 plus 1/4. Here I have the same denominators, which means I can go ahead and add the numerators. 3 plus 1 is 4 over 4. 4/4 is the same as 4 divided by 4, which is 1 whole. So next I need to add the whole numbers, which are 5, 1, and 1. So 5 plus 1 plus 1 equals 5 plus 2, which is 7. So the answer is 7 wholes. Now it's your turn to practice. Pause the video and solve this problem using any of the methods you learned. When you found your answer, click play. In this case, it would be easier to add the fractions first. That would give you 3/8 plus 5/8. Since they have the same denominator, you can go ahead and add the numerators. 3 plus 5 is 8 over 8. And 8/8 is 8 divided by 8, which is 1 whole. Now you can go ahead and add the whole numbers. 6 plus 2 plus 1. 6 plus 2 plus 1 is 8 plus 1, which is 9. So the answer is 9 wholes. Now follow along as I solve this problem. Here I have 5/6 plus 3 1/4. I'll solve using the first method, which is first adding the fractions together. So I have 5/6 plus 1/4. Here the denominators are different, so I need to ask myself, what is the lowest common multiple of 4 and 6? To figure that out, I can list the multiples of 4 and 6 until they share a common multiple. So I have 4, 8, 12. And then for 6, I have 6 and 12. So 12 is the lowest common multiple of 4 and 6. So I need to make them both have a denominator of 12. Next, I can ask myself, 6 times what equals 12? And 6 times 2 equals 12. So I'll multiply the 5 by 2 as well. Then I can ask myself, 4 times what equals 12? And 4 times 3 equals 12. So I'll multiply the 1 by 3 as well. Then I have 5 times 2 is 10, and 1 times 3 is 3. Here the denominators are the same, so I can go ahead and add the numerators. 10 plus 3 is 13 over 12. Once again, I have an improper fraction, so I need to convert it to a mixed number by dividing the numerator on top by the denominator on the bottom. And 12 goes into 13 one whole time, which means I have a remainder of 1. And the remainder becomes the numerator in the fraction part, and the divisor on the outside stays the denominator. So the result is 1 and 1/12. Next, I need to add the whole numbers, which is 3 and 1. So 3 plus 1 equals 4. And then last, I need to combine the whole number with the fraction part, which is 1/12. So my final answer is 4 and 1/12. Now it's your turn to practice. Pause the video and solve this problem using any of the two methods that you learned. When you found your answer, click play. In this case, I'll go ahead and use the second method, so I'll change the mixed number to an improper fraction. 3 times 4 is 12, plus 2 is 14, over the same denominator, which is 3. Then I have 14/3 plus 1/2. Once again, the denominators are different, so I need to ask myself, what is the lowest common multiple of 3 and 2? And the lowest common multiple of 3 and 2 is 6, because 2, 4, 6. And the multiples of 3 are 3 and 6. So 3 times what equals 6? Well, 3 times 2 equals 6. So I need to multiply the 14 by 2 as well. 2 times what equals 6? Well, 2 times 3 equals 6. So I need to multiply the 1 by 3 as well. That gives me 14 times 2, which is 28, over 6, plus 1 times 3 is 3, over 2 times 3, which is 6. Now you have like fractions, so you can go ahead and add the numerators. 28 plus 3 is 31, over 6. Here you have an improper fraction, so convert it to a mixed number by dividing the numerator by the denominator. 6 goes into 31 5 whole times, which means you have a remainder of 1. so that becomes the numerator in the fraction part, and the divisor stays the denominator. So the answer is 5 1/6. Now it's your turn to practice. Pause the video and solve the word problem. When you found your answer, click play. Miguel is building a fence around his garden. He has already installed 4 1/3 feet of fencing, and he needs to add 2 2/5 feet more to complete it. How many feet in fencing will Tom use in total for his garden fence? In this case, you need to add 4 1/3 and 2 2/5. Here you can solve this problem by converting the mixed numbers to improper fractions and then adding them up. So 3 times 4 is 12, plus 1 is 13 over 3, plus 5 times 2 is 10, plus 2 is 12 over 5. Here you have fractions with different denominators, so you need to find the lowest common multiple of 3 and 5. So list the multiples of 3 and 5 until you find a common multiple. 3, 6, 9, 12, 15. 5, 10, 15. As you can see, the lowest common multiple is 15. So you need to convert both fractions so they have a denominator of 15. So ask yourself, 3 times what equals 15? And 3 times 5 equals 15. So you need to multiply the 13 by 5 as well. 5 times what equals 15? And 5 times 3 equals 15. So multiply the 12 by 3. 13 times 5 is 65. And 12 times 3 is 36. Now the denominators are the same, so you can add the numerators together. 65 plus 36 equals 101 over 15. Here you have an improper fraction, which means you need to divide the numerator on top, which is 101, by the denominator on the bottom, which is 15. 15 goes into 101 6 whole times, because 15 times 6 is 90. And then subtract, which means the remainder is 11. So the remainder becomes the numerator in the fraction part, and the divisor on the outside stays the denominator. And 11/15 cannot be simplified, so the answer is 6 11/15 feet. Now let's review. To add improper fractions and mixed numbers, follow these steps. First, add the fractions, and then add the whole numbers. Finally, combine the whole numbers and fractions together. Another way to solve these kind of problems is to first convert any mixed numbers to improper fractions and then add them together. Knowing how to add fractions and mixed numbers helps you combine quantities in real-world situations, such as cooking, construction, or any situation where you're using fractions and whole numbers. So what's next? Review what you learned by doing the knowledge check. Then master what you learned by doing the practice activity. In the next lesson, you'll learn how to subtract like and unlike fractions. So I'll see you there. In this lesson, you'll learn how to subtract like and unlike fractions. So let's get started. So what are like fractions? Like fractions are fractions that have the same bottom number, which is called the denominator. The parts, or slices of pizza, are equal in size, making them like fractions. Subtracting like fractions is easy, because you just subtract the top numbers, or numerators, while keeping the bottom number or denominator the same. In this case, we have 3/4, which is 3 out of 4 slices of pizza, and we want to take away or subtract 2/4, or 2 out of 4 slices of pizza. When we do that, we're left with 1 out of 4 slices of pizza, which is 1/4 of the pizza. In this case, we're subtracting like fractions, because they both have the same denominator, of 4. So we simply have to subtract the numerators. 3 minus 2 equals 1. And the denominator of 4 stays the same. So the answer is 1/4, or 1/4. Now follow along as I solve this problem. Here I have 11/13, minus 5/13. In this case, I'm subtracting like fractions because they both have the same denominator of 13. So I can go ahead and subtract the numerators. 11 minus 5 is 6, and the denominator stays the same. In this case, I can't simplify 6/13, so my answer is 6/13. Now it's your turn to practice. Pause the video and solve the subtraction problem. When you found your answer, click play. Here you have 6/7 minus 3/7. Here you're subtracting like fractions because they both have the same denominator of 7. So you can go ahead and subtract the numerators. 6 minus 3 is 3, and the denominator stays the same. And 3/7 cannot be simplified, so the answer is 3/7. Now follow along as I solve this problem. John has 7/8 of a pizza left from last night's dinner. He decides to share some with his friend, so he gives away 3/8 of the pizza. How much of the pizza does John have left after sharing it with his friend? In this case, I need to figure out how much he has left, which is a sign that I need to subtract. So I start with the original amount, which is 7/8, and subtract the amount that he gave away, which is 3/8. Here I'm subtracting like fractions because they both have the same denominator of 8, so I can go ahead and subtract the numerators. 7 minus 3 is 4, and the denominator stays the same, which gives me 4/8. But in this case, I can simplify because the greatest common factor of 4 and 8 is 4. So I can divide the numerator and the denominator by the same factor, which is 4. 4 divided by 4 is 1, and 8 divided by 4 is 2. So the answer simplifies to 1/2, which means that John has half of a pizza left. Now it's your turn to practice. Pause the video and solve the word problem. When you found your answer, click play. Emily has 9/10 of a chocolate bar left from her stash. She decides to share some with her sister and gives away 7/10 of the chocolate bar. How much of the chocolate bar does Emily have left after sharing it with her sister? In this case, you're solving for how much chocolate bar Emily has left, which is a signal that you need to subtract. And Emily started with 9/10 of a chocolate bar and gave away 7/10 of a chocolate bar. Here you're subtracting like fractions because they both have the same denominator of 10, which means you can go ahead and subtract the numerators. 9 minus 7 is 2, and the denominator stays the same. But 2/10 can be simplified because 2 and 10 are both divisible by 2, so I can divide the numerator and the denominator by 2. 2 divided by 2 is 1, and 10 divided by 2 is 5, which means that Emily has 1/5 of a chocolate bar left. Now let's talk about subtracting unlike fractions. Unlike fractions are fractions that have different bottom numbers or different denominators. When you want to subtract unlike fractions, you need to make them have the same denominator, just like making sure all the pieces or slices are the same size. Once they have the same denominator, you can subtract them by subtracting the numerators while keeping the denominator the same. In this case, we have 5/6 minus 3/8. But in this case, we're subtracting unlike fractions because they both have different denominators, which means you're subtracting slices of different sizes. So in this case, you can't simply subtract the numerators and keep the same denominator. So you need to make the denominators the same. In other words, you need to make them like fractions before you can subtract. So how do you subtract unlike fractions? Step 1 is to find the least common denominator. To find the least common denominator, you need to find the lowest common multiple, or LCM, of the denominators. In this case, we have 7/12 minus 1/3. In this case, the denominators are different, so we need to make them have the same denominator, which should be the least common denominator. So to find the lowest common multiple of 3 and 12, I can list their multiples. 3, 6, 9, 12, and 12. So the least common multiple is 12. So I need to rewrite both fractions so they have a denominator of 12. Step 2. Rewrite each fraction so they have the same denominator. You can rewrite each fraction by multiplying them by whole fractions. So you need to ask yourself, 12 times what equals 12? Well, 12 times 1 equals 12. So I'll multiply 7 by 1 as well. And then I can ask, 3 times what equals 12? And 3 times 4 equals 12. So I'll multiply the 1 by 4. 7 times 1 is 7, and 1 times 4 is 4. So now I have like fractions. So I can go ahead and subtract the numerators. 7 minus 4 is 3, and the denominator stays the same. But 3/12 can be simplified, because the greatest common factor of 3 and 12 is 3. So I'll divide the numerator and denominator by 3. 3 divided by 3 is 1, and 12 divided by 3 is 4. So the simplified answer is 1/4. Now it's your turn to practice. Pause the video and solve the subtraction problem. When you found your answer, click play. Here you have 13/15 minus 1/5. In this case, the denominators are different. So first find the least common denominator, which is the lowest common multiple of 5 and 15. So to figure that out, list the multiples of 5, which are 5, 10, and 15, and the multiples of 15, which are 15. So you can see the lowest common multiple is 15. So then ask yourself, 15 times what equals 15? And 15 times 1 equals 15. So I'll multiply the 13 by 1 as well. And then you can ask, 5 times what equals 15? And 5 times 3 equals 15. So I can multiply the 1 times 3 as well. That gives me 13 times 1 is 13, and 15 times 1 is 15, minus 1 times 3 is 3, and 5 times 3 is 15. Now you have fractions with the same denominator, so go ahead and subtract the numerators. 13 minus 3 is 10, and the denominator stays the same. So you have 10/15. Since 10 ends in 0 and 15 ends in 5, they're both divisible by 5. So if you divide the top and bottom by 5, you get 10 divided by 5, which is 2, and 15 divided by 5, which is 3. And 2/3 cannot be simplified, so the answer is 2/3. Now follow along as I solve this problem. Here I have 2/3 minus 1/4. In this case, I have different denominators, which means I need to make them have the same denominator. I'll use a different method, the butterfly method, which is similar to how you used it when you added fractions with different denominators. So in the first step, I'll cross-multiply the numerators and denominators. So 2 times 4 is 8, and 3 times 1 is 3. And then in step number 2, I'll multiply the denominators. 3 times 4 is 12. So I can rewrite this as 8 minus 3 over 12, which equals 8 minus 3 is 5 over 12. And 5/12 cannot be simplified. So my answer is 5/12. Now it's your turn to practice. Pause the video and solve the subtraction problem. When you found your answer, click play. Here you have 5/6 minus 3/7, which means you're subtracting unlike fractions because they have different denominators, which means you need to make them have the same denominator. In this case, you can use the butterfly method, which means you would first cross-multiply the numerators and denominators. So 5 times 7 is 35, and 6 times 3 is 18. And 6 times 7 is 42, which you can rewrite as 35 minus 18 over 42. And then subtract the numerators. 35 minus 18 is 17. and keep the same denominator. Now you have 17 over 42. Since the greatest common factor of 17 and 42 is 1, so the final answer is 17 over 42. Now follow along as I solve this problem. Sophia has baked 2 different batches of cookies. The first batch contains 5/6 of a dozen cookies, and the second batch contains 1/2 of a dozen cookies. How many more cookies are there in the first batch than in the second batch? In this case, I need to find how many more, which is the difference, which means I need to subtract. And the first batch is bigger, with 5/6 of a dozen, and the second batch is smaller, with 1/2 of a dozen. So now I have 5/6 minus 1/2. But here the fractions have different denominators, so I need to make them have the same denominator. So I can ask myself, what is the least common denominator or lowest common multiple of 6 and 2? To figure that out, I can list the multiples of 2 and 6. 2, 4, and 6. And the first multiple of 6 is 6. So the lowest common multiple is 6, which means I need to make both of my fractions have the same denominator of 6. So then I ask myself, 6 times what equals 6? And 6 times 1 equals 6, which means I can multiply the 5 by 1 as well. And then I can ask, 2 times what equals 6? And 2 times 3 equals 6, so I can multiply the 1 on top by 3 as well. 5 times 1 is 5, and 6 times 1 is 6. 1 times 3 is 3, and 2 times 3 is 6. So now I have fractions with the same denominator, 5/6 minus 3/6. So I can go ahead and subtract the numerators. 5 minus 3 is 2, and the denominator stays the same. So I get 2/6. But 2/6 can be simplified because 2 and 6 are even numbers, so they're both divisible by 2. When I divide the numerator and denominator by 2, I get 2 divided by 2 is 1, and 6 divided by 2 is 3. So there's 1/3 of a dozen more cookies in batch 1 than batch 2. Now it's your turn to practice. Pause the video and solve the word problem. And when you found your answer, click play. Ella and Liam each have a jar of marbles. Ella's jar contains 4/5 of a pound of marbles, and Liam's jar contains 1/3 of a pound of marbles. How many more pounds of marbles are there in Ella's jar than in Liam's jar? In this case, you need to find how many more pounds there are, which means you need to find the difference or subtract. And 4/5 is bigger than 1/3. Here you're subtracting unlike fractions because they have different denominators, so you need to make them have the same denominator. In this case, you can use the butterfly method, so you can cross multiply the numerators and denominators. 4 times 3 is 12, and 5 times 1 is 5, and 5 times 3 is 15. So you can rewrite this as 12 minus 5 over 15. And 12 minus 5 is 7, and the denominator stays the same. So you get an answer of 7/15, which can't be simplified. So there are 17/15 pounds more marbles in Ella's jar than in Liam's jar. Now let's review. Like fractions are fractions that have the same bottom number, which is called the denominator. Subtracting like fractions is easy because you just subtract the top numbers or numerators while keeping the bottom number or denominator the same. Unlike fractions are fractions that have different bottom numbers or different denominators. When you want to subtract unlike fractions, you need to make them have the same denominator, just like making sure all the pieces or slices are the same size. Once they have the same denominator, subtract the numerators while keeping the denominator the same. And always remember to simplify your answer if possible. Knowing how to subtract fractions is important because it helps you find the leftover parts when cooking and building things. So what's next? Review what you learned by doing the knowledge check. Then master what you learned by doing the practice activity. In the next lesson, you'll learn how to subtract with mixed numbers. I'll see you there. In this lesson, you'll learn how to subtract with mixed numbers. So let's get started. Now follow along as I solve this problem. Here I have 4 6/7 minus 1/7. Here I'm subtracting a fraction from a mixed number. And the first thing I notice is that the fraction parts both have the same denominator of 7. And 6 is bigger than 1, which means that 6/7 is bigger than 1/7. So I can go ahead and subtract the numerators. 6 minus 1 is 5, and the denominator stays the same. And here I have 4 minus 0, so 4 minus 0 is 4. So my final answer is 4 5/7, because 5/7 cannot be simplified. Now it's your turn to practice. Pause the video and solve the problem. And when you found your answer, click play. Here you have 3 5/6 minus 1/6. Once again, you need to subtract a fraction from a mixed number. And here the denominators are the same. They're both 6. And 5 is bigger than 1, which means that 5/6 is bigger than 1/6. So you can go ahead and subtract the fractions first. 5 minus 1 is 4, and the denominator stays the same. And 3 minus 0 is 3. So you get 3 4/6, but 4/6 can be simplified. 4 and 6 are even numbers, which means they're both divisible by 2. So 4 divided by 2 is 2, and 6 divided by 2 is 3, and I'll bring over the 3 wholes. So the final simplified answer is 3 2/3. Now follow along as I solve this problem. Here I have 3 5/9 minus 8/9. Once again, I'm subtracting a fraction from a mixed number, and I notice that they both have the same denominator of 9. But then I notice that 5 is less than 8, which means that 5/9 is less than 8/9. So I can't subtract 8 from 5. So I need to borrow from the whole place. So I'll go ahead and rewrite the problem vertically. 3 5/9 minus 8/9. Since I can't subtract 8 from 5, I need to borrow from the whole place. And in this case, the 3 becomes 2 wholes. And a whole in this case, since the denominator here is 9, I need to make a whole fraction with the denominator of 9. And I know that 9/9 equals 1 whole. So I can add 9/9 to 5/9. 5 plus 9 is 14, and the denominator stays the same. So now I have 14/9 minus 8/9. And 14 minus 8 is 6. And the denominator stays the same. And then 2 minus nothing, or 2 minus 0, is 2. So I get 2 6/9. But 6/9 can be simplified, because 6 and 9 are both divisible by 3. 6 divided by 3 is 2, and 9 divided by 3 is 3, and I'll bring over the 2 wholes. So my simplified final answer is 2 2/3. Now it's your turn to practice. Pause the video, and when you found your answer, click play. Here you have 7 5/16 minus 11/16. Once again, you need to subtract a fraction from a mixed number. And you'll notice that they both have the same denominator, 16. But 5 is less than 11, which means that 5/16 is less than 11/16. And you can't subtract 11 from 5, so you need to borrow from the whole place. So in this case, you can rewrite the problem vertically. 7 5/16 minus 11/16. And when you borrow from the whole place, the 7 becomes a 6. And in this case, you have a denominator of 16. so you need to add a whole fraction with the denominator of 16. And 16/16 equals 1 whole. So now you can add 5 plus 16, which is 21 over 16. And now you can subtract 11 from 21, which equals 10. And the denominator stays the same. And 6 minus nothing, or 6 minus 0, is 6. So you get 6 and 10/16. But 10/16 can be simplified because they're both even numbers. So you can divide both of them by 2, which gives you 10 divided by 2 is 5, and 16 divided by 2 is 8, and bring over the 6. So the final simplified answer is 6 5/8. Now follow along as I solve this problem. Here I have 11 3/4 minus 5 1/4. Here I'm subtracting a mixed number from a mixed number, but I notice that they both have the same denominator of 4. And 3 is bigger than 1, so I can go ahead and subtract the fractions first, and then subtract the whole numbers afterwards. Here I have 3 minus 1, which is 2, and the denominator stays the same. And 11 minus 5 is 6. So I get 6 2/4. But 2/4 can be simplified because 2 and 4 are even numbers, so they're both divisible by 2. 2 divided by 2 is 1, and 4 divided by 2 is 2. And then I'll bring down the 6. So my final simplified answer is 6 1/2. Now it's your turn to practice. Pause the video, and when you found your answer, click play. Here you have 12 11/16 minus 3 7/16. Here you're subtracting a mixed number from a mixed number, but they both have the same denominator, 16. And 11 is bigger than 7, so you can go ahead and subtract the fractions first. 11 minus 7 is 4, and the denominator stays the same. And then subtract the whole numbers. 12 minus 3 is 9, so you get 9 4/16. But 4/16 can be simplified because the greatest common factor of 4 and 16 is 4. So divide both the numerator and denominator by 4. 4 divided by 4 is 1, and 16 divided by 4 is 4, so you get 1/4. And bring down the 9. So the final simplified answer is 9 1/4. Now follow along as I solve this problem. Here I have 6 3/7 minus 5 2/3. Here I'm subtracting a mixed number from a mixed number, and I notice that they have different denominators, 7 and 3. And 2/3 is greater than 3/7. So I would need to borrow from the whole place. Since the denominators are different, and I need to borrow from the whole place, it would be better to change both of the mixed numbers to improper fractions and then subtract. To do that, I can multiply the denominator times the whole number. 7 times 6, which is 42, and then add the numerator, which is 3. 42 plus 3 is 45, over the same denominator, which is 7, minus 3 times 5 is 15, plus 2 is 17, keeping the same denominator of 3. Now I have 45/7 minus 17/3, but I still have different denominators, 7 and 3. So in order to subtract them, I need to make them have the same denominator. So I need to ask myself, what is the lowest common multiple of 7 and 3? Which is 21. So I need to convert both fractions so they have a denominator of 21. So then I can ask myself, 7 times what equals 21? And 7 times 3 equals 21. So I'll multiply the 45 times 3 as well. And then I can ask 3 times what equals 21? And 3 times 7 equals 21. so I'll multiply the 17 by 7 as well. 45 times 3 equals 135. And 17 times 7 is 119. Since I have the same denominator, I can subtract the numerators. 135 minus 119 is 16 over 21. And 16 over 21 cannot be simplified. So my answer is 16 over 21. Now it's your turn to practice. Pause the video, and when you found your answer, click play. Here you have 4 and 2/5 minus 2 and 9/15. Here you're subtracting a mixed number from a mixed number. And you'll notice that they have different denominators, 5 and 15. And 9/15 is bigger than 2/5, which means you would have to borrow from the whole place value. Since you have different denominators and you'd have to borrow from the whole place, it would be easier to change the mixed numbers to improper fractions and then subtract. 5 times 4 is 20, plus 2 is 22 over 5, minus 15 times 2 is 30, plus 9 is 39 over 15. You can see that you still have different denominators, 5 and 15, which means you need to convert them to like fractions so they have the same denominator before you can subtract. So you need to ask yourself, what is the lowest common multiple of 5 and 15? And the answer is 15. So you need to convert both fractions so they have a denominator of 15. And then ask yourself, 5 times what equals 15? And 5 times 3 equals 15. So multiply the 22 times 3 as well. And 15 times 1 is 15, so multiply the 39 by 1 as well. That gives you 22 times 3 is 66 fifteenths minus 39 fifteenths. Now you have the same denominator, so you can go ahead and subtract the numerators. 66 minus 39 is 27 over 15. Here we have an improper fraction, so we could divide it out to change it to a mixed number. But to make the number smaller, let's simplify first. The greatest common factor of 27 and 15 is 3, so you can divide both of those by 3. 27 divided by 3 is 9, and 15 divided by 3 is 5. Now you have the fraction 9/5, which you can change to a mixed number by dividing the numerator, which is 9, by the denominator, which is 5. 5 goes into 9 one whole time, which means you end up with the remainder of 4, which becomes the numerator in the fraction part, and the divisor on the outside stays the denominator, which is 5. So the final answer is 1 and 4/5. Now it's your turn to practice. Pause the video and solve the word problem. And when you found your answer, click play. Jack had a candy bar that was 4 1/4 inches long. He decided to share a portion of it with his friend. After sharing, the candy bar was only 1 5/12 inches long. How much of the candy bar did Jack give to his friend? In this case, you need to find how much of the candy bar did he give to his friend, which means you need to subtract the amount that was left over, which is 1 5/12, from the original amount, which is 5 1/4. Here you'll notice that the denominators are different, 4 and 12. And 5/12 is bigger than 1/4, so you'd have to borrow from the whole place. Since the denominators are different, and you'd have to borrow from the whole place, it's better to convert the mixed numbers to improper fractions and then subtract. 4 times 5 is 20, plus 1 is 21 over 4, minus 12 times 1 is 12, plus 5 is 17 over 12. But you still have different denominators, 4 and 12, which means you need to convert the fractions to like fractions so they have the same denominator before you can subtract them. So ask yourself, what is the lowest common multiple of 4 and 12? And the answer is 12. So you need to convert the fractions so they both have a denominator of 12. So then ask yourself, 4 times what equals 12? And 4 times 3 equals 12. So multiply the 21 by 3 as well. And 12 times 1 is 12, so multiply the 17 times 1 as well. 21 times 3 is 63. And 17 times 1 is 17. Now you have fractions with the same denominator, so now you can subtract the numerators. 63 minus 17 is 46 over 12. And 46 twelfths can be simplified because they're both even numbers, so they're both divisible by 2. 46 divided by 2 is 23, and 12 divided by 2 is 6, which means you get an improper fraction, so you need to convert that to a mixed number by dividing 23 by 6. And 6 goes into 23 3 whole times, because 3 times 6 is 18, which means you're left with a remainder of 5. And the remainder becomes the numerator in the fraction part, and the divisor on the outside stays the denominator, 6. So the answer is 3 5/6 inches. Now let's review. You can solve problems that involve subtracting with mixed numbers in several different ways. Knowing how to subtract mixed numbers is important in real life for tasks like cooking or adjusting recipes and building things like measuring materials. So what's next? Review what you learned by doing the knowledge check. Then master what you learned by doing the practice activity. In the next lesson, you'll learn how to multiply with fractions and mixed numbers. I'll see you there. In this lesson, you'll learn how to multiply with fractions and mixed numbers. So let's get started. So how do you multiply fractions? First, multiply the top numbers or numerators together. Then multiply the bottom numbers or denominators together. Finally, if you can, simplify the fraction by dividing both the top and bottom numbers by their greatest common factor. Here you have 2/3 times 5/8. First, multiply the numerators together. 2 times 5 is 10. And then multiply the denominators together. 3 times 8 is 24, which gives you 10 over 24, or 10/24, which can be simplified because the greatest common factor of 10 and 24 is 2. And 10 divided by 2 is 5, and 24 divided by 2 is 12. And 5/12 cannot be simplified, so the answer is 5/12. Now follow along as I solve this problem. I have 2/7 times 21, and 21 can be rewritten as a fraction over 1. So that gives me 2/7 times 21 wholes. Next, I can multiply the numerators together. 2 times 21 is 42. And then multiply the denominators together. 7 times 1 is 7. And 42/7 is really 42 divided by 7. And 7 goes into 42 6 whole times. So the final answer is 6. Now it's your turn to practice. Pause the video and solve the problem. And when you found your answer, click play. Here you have 3/8 times 4/9. So first, multiply the numerators together. 3 times 4 is 12. And then multiply the denominators together. 8 times 9 is 72. Here, 12 over 72 can be simplified because the greatest common factor of 12 and 72 is 12. So divide the numerator and denominator by 12. 12 divided by 12 is 1, and 72 divided by 12 is 6. So the final answer is 1/6. Another way to solve this problem is to cross-simplify. So look at the numbers that are diagonal from each other and ask yourself, do they have a greatest common factor? And if they do, you can simplify. 3 and 9 have a greatest common factor of 3. So divide 3 by 3, which gives you 1, and 9 by 3, which gives you 3. Now look at 4 and 8. The greatest common factor of 4 and 8 is 4. So divide 4 by 4, which is 1, and 8 by 4, which is 2. That gives you 1/2 times 1/3. Then multiply the numerators together. 1 times 1 is 1, and 2 times 3 is 6. As you can see, you get the same answer. Now follow along as I solve this word problem. Lucas is preparing lemonade for a party. He needs to make 5 pitchers of lemonade, and each pitcher requires 1/3 of a cup of lemon juice. How many cups of lemon juice does Lucas need in total? In this case, you need to find the total using repeated addition or multiplication. So you can multiply 5 by 1/3. And you can rewrite 5 as 5 over 1. Then multiply the fractions. Start by multiplying the numerators on top. 5 times 1 is 5, and then multiply the denominators on the bottom. 1 times 3 is 3. Here I have an improper fraction, which I can convert to a mixed number by dividing the numerator, which is 5, by the denominator, which is 3. 3 goes into 5 one whole time, which means I have a remainder of 2, which becomes the numerator in the fraction part, and the divisor on the outside stays the denominator. That means Lucas needs 1 2/3 cups of lemon juice to make 5 pitchers of lemonade. Now it's your turn to practice. Pause the video and solve the word problem. When you found your answer, click play. A recipe calls for 3/4 cup of flour, but you only want to make half of the recipe. How much flour do you need? In this case, you want to find half of 3/4. So you can multiply 3/4 times 1/2. Start by multiplying the numerators. 3 times 1 is 3, and then multiply the denominators. 4 times 2 is 8, and 3/8 cannot be simplified, so you would need 3/8 of a cup of flour. So how do you multiply with mixed numbers? First, convert any mixed numbers to improper fractions before multiplying. Then simplify if possible. Here you have 3.5 times 1/5. So first you need to convert the mixed number to an improper fraction. 2 times 3 is 6, plus 1 is 7, over 2, times 1/5. Then multiply the numerators together. 7 times 1 equals 7, and then multiply the denominators together. 2 times 5 equals 10, and 7/10 cannot be simplified, so the answer is 7/10. Now follow along as I solve this problem. Here I have 4 3/4 times 1/3. In this case, I need to change the mixed number to an improper fraction before multiplying. 4 times 4 is 16, plus 3 is 19, over 4, times 1/3. Next, I would multiply the numerators together. 19 times 1 is 19, and 4 times 3 is 12. Here I have an improper fraction, so I'll go ahead and divide it out to make it a mixed number. 19 divided by 12, 12 goes into 19 one whole time, which means I have a remainder of 7, which becomes the numerator in the fraction part, and the divisor on the outside stays the denominator. So my answer is 1 7/12. Now it's your turn to practice. Pause the video and solve the problem. When you found your answer, click play. Here you have 2½ times 3 3/4. First, you need to change the mixed numbers to improper fractions. 2 times 2 is 4, plus 1 is 5, over 2, times 4 times 3 is 12, plus 3 is 15, over 4. Then multiply the numerators together. 5 times 15 equals 75, and 2 times 4 equals 8. Here you get an improper fraction, so convert it to a mixed number by dividing 75 by 8. And 8 goes into 75 9 whole times, because 9 times 8 equals 72, which leaves you a remainder of 3, which becomes the numerator in the fraction part, and the divisor stays the denominator. So the answer is 9 3/8, because 3/8 cannot be simplified. Now follow along as I solve this word problem. Sam is baking cookies for a school fundraiser. He plans to make 2½ batches of cookies. Each batch of cookies requires 3/4 a cup of sugar. How much sugar in cups does Sam need for all the batches of cookies? In this case, I need to do repeated addition, which is multiplication. So I'll multiply 2½ by 3/4. Here I need to change the mixed number to an improper fraction. 2 times 2 is 4, plus 1 is 5, over 2, times 3/4. Then I'll multiply the numerators together. 5 times 3 is 15, and 2 times 4 is 8. Then I can divide 15 by 8, and 8 goes into 15 one whole time, with the remainder of 7, which becomes the numerator in the fraction part, and the divisor, which is 8, stays the denominator. So my final answer is 1 7/8 cups of sugar. Now it's your turn to practice. Pause the video and solve the word problem. When you found your answer, click play. Emily is making a garden in her backyard. The garden has a length of 3½ feet, and the garden has a width of 2 3/4 feet. What is the total area in square feet of her garden? In this case, you need to find the area of her garden. And to find the area which is the inside of the garden, you need to multiply the length times the width. So you would multiply 3½ times 2 3/4. So first convert the mixed numbers to improper fractions. 2 times 3 is 6, plus 1 is 7, over 2, times 4 times 2 is 8, plus 3 is 11, over 4. Then multiply the numerators together. 7 times 11 is 77, and 2 times 4 equals 8. So then divide 77 by 8. And 8 goes into 77 9 whole times, because 9 times 8 is 72, which leaves you with the remainder of 5. So 5 becomes the numerator, and the divisor of 8 stays the denominator. So the answer is 9 5/8 square feet. Now let's review. To multiply fractions, first multiply the top numbers or numerators together. Then multiply the bottom numbers or denominators together. If possible, simplify the fraction by dividing the top and bottom by their greatest common factor. Convert any mixed numbers to improper fractions to make multiplication easier and more straightforward. Knowing how to multiply with fractions in mixed numbers is important in real-world situations like cooking and building projects. So what's next? Review what you learned by doing the knowledge check. Then master what you learned by doing the practice activity. In the next lesson, you'll learn how to divide with fractions in mixed numbers. I'll see you there. In this lesson, you'll learn how to divide with fractions in mixed numbers. So let's get started. So how do you divide with fractions? The key is to remember the phrase keep, switch, flip. In step 1, you keep the first fraction unchanged. In step 2, switch the division sign to multiplication. In step 3, flip the second fraction over so it becomes its reciprocal, and then multiply the fractions, and always simplify if possible. Here you have 3/4 divided by 2/3, so keep the first fraction unchanged. And then switch the division to a multiplication sign. And then flip the second fraction over so it becomes its reciprocal. So 2/3 becomes 3/2. And then multiply like normal. So start by multiplying the numerators on top. 3 times 3 is 9. And then multiply the denominators on the bottom. 4 times 2 is 8. So you get 9/8, which is an improper fraction, which you can convert to a mixed number by dividing the numerator, which is 9, by the denominator, which is 8. 8 goes into 9 one whole time, which means you're left with a remainder of 1. That becomes the numerator in the fraction part, and the divisor on the outside stays the denominator. So the answer as a mixed number is 1 1/8. Now follow along as I solve this problem. Here I have 6 divided by 2/3, and any whole number can be rewritten as a fraction over 1, so that becomes 6 wholes, or 6/1. So now I have 6 wholes divided by 2/3. And now I can keep the first fraction the same, so that stays 6 wholes, and then I'll change the division to multiplication, and then I'll flip the second fraction over so that it becomes its reciprocal. So 2/3 becomes 3/2. Then I can multiply like normal. 6 times 3 is 18, and 1 times 2 is 2. And 18/2 is the same thing as 18 divided by 2. And 2 goes into 18 9 whole times, because you're left with the remainder of 0. So the answer is 9. Now it's your turn to practice. Pause the video and solve the problem. When you found your answer, click play. Here you have 3/4 divided by 2. And here you can rewrite the whole number as a whole fraction, which is 2 wholes, or 2/1. So now you have 3/4 divided by 2 wholes. And then you need to keep, switch, flip. So keep the first fraction unchanged. And then switch the division to multiplication, and then flip the second fraction over so it becomes its reciprocal. So 2 wholes becomes 1/2. And then multiply like normal. 3 times 1 is 3, and 4 times 2 is 8. And 3/8 cannot be simplified, so the answer is 3/8. Now follow along as I solve this problem. Here I have 5/6 divided by 2/3. So I need to keep, switch, flip. So I'm going to keep the first fraction the same, and then I'll switch the division to multiplication, and then I'll flip the second fraction over so that it becomes its reciprocal. So 2/3 becomes 3/2. And now I can multiply the fractions. 5 times 3 is 15, and 6 times 2 is 12. And 15/12 is an improper fraction, so I'll convert that to a mixed number by dividing 15 by 12. 12 goes into 15 one whole time, and I'm left with the remainder of 3, which becomes the numerator in the fraction part, and the divisor of 12 stays the denominator. But 3/12 can be simplified, because 3 and 12 are both divisible by their greatest common factor, which is 3. 3 divided by 3 is 1, and 12 divided by 3 is 4. And I'll bring over the 1 whole. So the answer as a mixed number is 1 1/4. Another way to solve this is to cross-simplify, because I can see that 3 and 6 share the greatest common factor of 3, and 3 divided by 3 is 1, and 6 divided by 3 is 2. So that gives me 5 halves times 1 half. And 5 times 1 is 5, and 2 times 2 is 4. And then I can divide it out. 5 divided by 4 equals 1, with a remainder of 1. So the remainder becomes the numerator, and the divisor of 4 stays the denominator. As you can see, I get the same answer. I could have also simplified when I got to 15/12. I could have divided them both by their greatest common factor, which is 3. And 15 divided by 3 is 5, and 12 divided by 3 is 4. So I would have gotten 5/4, and then I would have divided out to get the answer. Now it's your turn to practice. Pause the video and solve the problem. And when you found your answer, click play. Here you have 3/5 divided by 2/7. So keep the first fraction unchanged. And then switch the division to multiplication. Then flip the second fraction over so it becomes its reciprocal. So 2/7 becomes 7 halves. And then multiply the fractions. 3 times 7 is 21, and 5 times 2 is 10. You get the result 21/10, which is an improper fraction, which you can convert to a mixed number by dividing 21 by 10. And 10 goes into 21 2 whole times, and 2 times 10 is 20, which means you're left with the remainder of 1, which becomes the numerator in the fraction part, and the divisor stays the denominator. And 1/10 cannot be simplified, so the answer as a mixed number is 2 1/10. Now it's your turn to practice. Pause the video and solve the word problem below. When you found your answer, click play. Samantha is baking cookies, and she has 12 cups of flour. She wants to divide the flour equally into 1/4 cup portions for each cookie. How many cookies can Samantha make? In this case, you need to divide 12 by 1/4. And 12 can be rewritten as 12 over 1. So you'll keep the first fraction the same, which is 12 wholes, and then change the division to multiplication. Then flip the second fraction over so it becomes its reciprocal. So 1/4 becomes 4 wholes. And then multiply like normal. 12 times 4 is 48. And 1 times 1 is 1. 48 wholes is equal to 48. So Samantha can make 48 cookies. Now let's get some more practice. Pause the video and solve the word problem. When you found your answer, click play. Liam is making a fruit salad. He has 3/4 of a cup of strawberries, and he wants to divide it equally among his friends. If each friend gets 1/8 of a cup of strawberries, how many friends can Liam serve? In this case, you need to divide 3/4 by 1/8. And then keep the first fraction the same. And then change the division to multiplication, and then flip the second fraction over so it becomes its reciprocal. And 1/8 becomes 8 wholes. And then here you can multiply across. 3 times 8 is 24, and 4 times 1 is 4. 24/4 is the same as 24 divided by 4. And 4 goes into 24 6 whole times. So the answer is 6 friends. Now how do you divide with mixed numbers? First, convert any mixed numbers to improper fractions before dividing. Then simplify if possible. Here you have 2½ divided by 1/4. 2½ is a mixed number, so you need to convert that to an improper fraction. 2 times 2 is 4, plus 1 is 5, over 2. That gives you 5 halves, divided by 1/4. Then keep the first fraction the same, and then switch the division to multiplication, and then flip the second fraction over so it becomes its reciprocal. So 1/4 becomes 4 wholes. And then multiply. 5 times 4 is 20, and 2 times 1 is 2. And 20 halves is the same thing as 20 divided by 2. And 2 goes into 2 one whole time, which leaves you with the remainder of 0, and bring down the 0, and 2 goes into 0 0 times, with the remainder of 0. So 2 goes into 20 10 whole times. So the answer is 10. Now follow along as I solve this problem. Here I have 4 2/3 divided by 5/6. I first need to change the mixed number to an improper fraction. 3 times 4 is 12, plus 2 is 14. So that gives me 14/3, divided by 5/6. And then I keep the first fraction unchanged. And then I switch the division to multiplication, and then flip the second fraction over, so it becomes its reciprocal. So 5/6 becomes 6/5. And then I can multiply across. 14 times 6 is 84. And 3 times 5 is 15. And then I can divide that out to get a mixed number. 84 divided by 15. 15 goes into 84 5 whole times, because 15 times 5 is 75, which leaves me with the remainder of 9. So the 9 becomes the numerator in the fraction part, and the divisor stays the denominator. So I get 5 and 9/15, but 9/15 can be simplified because the greatest common factor of 9 and 15 is 3. And 9 divided by 3 is 3, and 15 divided by 3 is 5, and I'll bring over the 5 wholes. So my final simplified answer is 5 3/5. Now it's your turn to practice. Pause the video and solve the problem. When you found your answer, click play. Here you have 2½ divided by 1/4. So you first need to change the mixed number to an improper fraction. 2 times 2 is 4, plus 1 is 5, over 2, divided by 1/4. Keep the first fraction unchanged, and then switch the division to multiplication, and flip the second fraction over, so it becomes its reciprocal. So 1/4 becomes 4 wholes, and then multiply. 5 times 4 is 20, and 2 times 1 is 2, and 20 divided by 2 is 10. So the answer is 10. Now follow along as I solve this problem. Here I have 2 3/4 divided by 1 1/2. I need to convert both of the mixed numbers to improper fractions. 4 times 2 is 8, plus 3 is 11, over 4, divided by 2 times 1 is 2, plus 1 is 3, over 2. So I have 11/4 divided by 3 halves. I'll keep the first fraction unchanged, and then I'll switch the division to multiplication, and then I'll flip the second fraction over so it becomes its reciprocal. So 3 halves becomes 2/3, and then I'll multiply like normal. 11 times 2 is 22, and 4 times 3 is 12. So I get 22 divided by 12, which I can simplify by 2, because 22 and 2 are both even numbers. 22 divided by 2 is 11, and 12 divided by 2 is 6. And I get an improper fraction, which I can convert to a mixed number by dividing 11 by 6. 6 goes into 11 one whole time, which means I'm left with the remainder of 5. So that becomes the numerator in the fraction part, and the divisor stays the denominator. So my answer as a mixed number is 1 5/6. Now it's your turn to practice. Pause the video and solve the problem. When you found your answer, click play. Here you have 3 1/2 divided by 1 1/4. So first you need to convert the mixed numbers to improper fractions. 2 times 3 is 6, plus 1 is 7, over 2, divided by 4 times 1 is 4, plus 1 is 5, over 4. So now you have 7/2 divided by 5/4. So keep the first fraction unchanged, and then switch the division to multiplication, and then flip the second fraction over so it becomes its reciprocal. And 5/4 becomes 4/5, and then multiply. 7 times 4 is 28, and 2 times 5 is 10. Now you can convert your improper fraction to a mixed number by doing 28 divided by 10. And 10 goes into 28 2 whole times, which leaves you with the remainder of 8. And 8 becomes the numerator in the fraction part, and the divisor 10 stays the denominator. So you have 2 8/10. But 8/10 can be simplified because both are even numbers, so they can be divided by 2. 8 divided by 2 is 4, and 10 divided by 2 is 5, and bring over the 2. So your final simplified answer is 2 4/5. Now it's time to practice. Pause the video and solve the word problem below. When you found your answer, click play. Alex is making pancakes and wants to divide his batter into equal portions to cook pancakes. He has 5 3/4 cups of batter, and each pancake requires 2/5 of a cup of batter. How many pancakes can Alex make from his batter? Here you need to divide 5 3/4 by 2/5. So first, convert the mixed number to an improper fraction. 4 times 5 is 20, plus 3 is 23 over 4, divided by 2/5. Keep the first fraction unchanged, and then switch the division to multiplication. Then flip the second fraction over so it becomes its reciprocal. So 2/5 becomes 5/2, and then multiply. 23 times 5 is 115, and 4 times 2 is 8. And then divide 115 by 8. 8 goes into 11 one whole time, which leaves you with the remainder of 3, and then bring down the 5. 8 goes in 4 times, because 8 times 4 is 32, which leaves you with the remainder of 3, and the divisor 8 stays the denominator. So you get 14 3/8. But here the question is, how many pancakes can he make? And clearly he doesn't have enough to make 15 pancakes, but he does have enough to make 14. So the answer is 14 pancakes. Now it's time for more practice. Pause the video and solve the word problem. When you found your answer, click play. Sophie has 25 3/4 pounds of granola that she wants to package into containers for her breakfast cafe. Each container can hold 3 1/2 pounds of granola. How many containers does she need to store all the granola? In this case, you need to divide 25 3/4 by 3 1/2. So start by converting the mixed numbers to improper fractions. 4 times 25 is 100, plus 3 is 103, over 4, divided by 2 times 3 is 6, plus 1 is 7, over 2. So now you have 103/4 divided by 7/2. So keep the first fraction unchanged. Then switch the division to multiplication, and then flip the second fraction over to make it into its reciprocal. So 7/2 becomes 2/7. Then multiply the fractions. 103 times 2 equals 206. And 4 times 7 is 28. You can simplify the improper fraction by dividing 206 and 28 by 2 because they're both even numbers. 206 divided by 2 is 103, and 28 divided by 2 is 14. Then convert the improper fraction to a mixed number by dividing 103 by 14. 14 goes into 103 7 whole times, because 7 times 14 is 98. When you subtract, you're left with the remainder of 5. And the remainder becomes the numerator in the fraction part, and the divisor stays the denominator. So you get 7 and 5/14, which means that she can fill up 7 whole containers, but she would still have some left over. But all of the granola needs to be stored, which means she needs an extra container. So she really needs 8 containers to store all of her granola. Now let's review. Here are 3 simple steps to divide with fractions. Step 1. Keep the first fraction unchanged. Step 2. Switch the division sign to multiplication. And step 3. Flip the second fraction over to turn it into its reciprocal, and then multiply the fractions. Make sure to convert any mixed numbers to improper fractions to make division easier and more straightforward. Knowing how to divide with fractions and mixed numbers is important for many everyday tasks like cooking recipes, building projects, and managing money. So what's next? Review what you learned by doing the knowledge check. Then master what you learned by doing the practice activity. Next, you'll review everything you learned about working with fractions and mixed numbers. I'll see you there. In this lesson, you'll learn all about decimal place values. So let's get started. So what is a decimal? Decimals are another way to write numbers that aren't whole. They include a dot to separate the whole part from the part that's less than a whole. Decimals help us talk about parts of things, like cents with money, or measurements that aren't exact whole numbers. For example, you can use decimals when you write numbers like half, pi, or $8.75. Now let's talk about how to read decimals. First, you read the whole number part. The digits to the left of the decimal point represent the number of whole things you have. For example, in the number 275.918, the 275 is the whole number part. It's like having $275. Next, you have the decimal point. This is the little dot in the number that separates the whole number part from the decimal part. Then you have the decimal part. The digits to the right of the decimal point represent the part of something that's less than a whole. For instance, in the number 275.918, the 0.918 is the decimal part. It's like saying you have a tiny bit more than 91 cents. Now let's talk about the tenths place. The first digit to the right of the decimal point represents the tenths. It's 1/10 of a whole, so it's 10 times smaller than a whole. So in the number 0.345, the 3 is 3/10. If you think of it like money, it's like having 3 dimes. If you wanted to visualize 3/10, it would look like this. It would be a whole divided into 10 equal parts, and 3 of those parts would be filled in. So as a fraction, you would write that as 3/10, or 3/10, which equals the decimal 0.3, or 3/10. Now it's time to practice. Pause the video and choose the best answer. When you found your answer, click play. What is the digit in the tenths place in the number 4.5032? In this case, the tenths place is to the right of the decimal, So that means the 5 is the digit in the tenths place. So the answer is B. Now let's get more practice. Pause the video and find the best answer. When you found your answer, click play. What is the value of the digit 3 in the number 4.389? In this case, you want to find the value of the digit, and in this case, the digit is 3, which is in the tenths place. So to write 3/10, you would write that as 0.3. So the correct answer is C. Now let's talk about the hundredths place. The second digit to the right of the decimal point represents hundredths. It's 1/100th of a whole, so it's 100 times smaller than a whole. In our example, the 4 in 0.345 is 4/100ths, which is like having 4 cents. To visualize a hundredth, you can take a whole square and divide it into 100 equal squares, which as a fraction would be written as 4 over 100, or 4/100ths, which as a decimal would be 0.04. Now it's time to practice. Pause the video and solve the problem. When you found your answer, click play. What is the digit in the hundredths place in the number 6.2189? The hundredths place is 2 digits to the right of the decimal. So in this case, the 1 is in the hundredths place. So the answer is C. Now let's get some more practice. Pause the video and solve the problem. When you found your answer, click play. What is the value of the digit 6 in the number 7.362? In this case, the 6 is 2 decimal places to the right of the decimal point, which means it's in the hundredths place. So that 6 really represents 6/100ths, which is written 0.06. So the answer is A. Now let's talk about the thousandths place. The third digit to the right of the decimal point represents thousandths. It's 1/1000th of a whole, so it's 1,000 times smaller than a whole. So in the number 0.345, the 5 is 5/1000ths. To visualize 5/1000ths, imagine a whole square divided into 1,000 equal little parts. So as a fraction, that would be 5 out of 1,000, or 5/1000ths, which as a decimal equals 0.005. Now it's time to practice. Pause the video and solve the problem. When you found your answer, click play. What is the digit in the thousandths place in the number 9.7243? The thousandths place is 3 digits to the right of the decimal point. So in this case, the digit 4 is in the thousandths place. So the answer is D. Now it's time for more practice. Pause the video and solve the problem. When you found your answer, click play. What is the value of the digit 9 in the number 4.7298? In this case, the digit 9 is in the thousandths place because it's 3 digits to the right of the decimal point. And 9/1000ths as a decimal would be written as 0.009. So the answer is B. Now let's talk about writing decimals in expanded form. Just like with whole numbers, you can rewrite decimals in expanded form to show the place value of every digit. Here we have the number 275.918. The 2 is in the hundredths place, so it represents 200. The 7 is in the tens place, so it represents 70. The 5 is in the ones place, so it represents 5. Then you have 9, which is in the tenths place, so it represents 9/10ths, or 0.9. Then you have 1, which is in the hundredths place, so it represents 1/100th, or 0.01. Finally, you have 8, which is in the thousandths place, so it represents 8/1000ths, which is 0.008. Now it's time to practice. Pause the video and solve the problem. When you found your answer, click play. Write the number 397 thousandths in expanded form. So start by writing the number 0.397. It's best to put a 0 before the decimal point for a number less than 1. This way, the decimal point isn't mistaken for a speck of dirt on the paper. Then we can write the place value of each digit. First you have 0 ones, so you leave that blank. And then you have 3/10ths, which as a decimal would be 0.3. Then you have 9/100ths, which as a decimal would be 0.09. Finally, you have 7/1000ths, which as a decimal would be 0.007. So the answer is B. Now it's time for more practice. Pause the video and solve the problem. When you found your answer, click play. Write the number 285 thousandths in expanded form. So start by writing the number 0.285. Here you have 0 ones, so you can go ahead and skip it. Then you have 2/10ths, which is written 0.2, plus 8/100ths, which is 0.08, plus 5/1000ths, which is 0.005. So the answer is D. Now let's talk about equivalent decimals. Zeros all the way to the right after the decimal do not change a number's value. So you can add or remove zeros at the end of any decimal without changing the number's value. For example, 2.5 has the same value as 2.50. In other words, 2 5/10ths is equal to 2 50/100ths. In this case, the added 0 at the end does not change the number's value. Next you have 0.30, which has the same value as 0.3. In other words, 30/100ths is equal to 3/10ths. In this case, removing the 0 at the end of the decimal does not change the number's value. Now it's time to practice. Pause the video and solve the problem. When you found your answer, click play. Which decimal is equal to 2/1000ths? Remember, you can add a 0 at the end of any decimal without changing the number's value. So you can add a 0 after the 2, which means that 2/1000ths is equal to 20/10,000ths. So the answer is D. Now it's time for more practice. Pause the video and solve the problem. When you found your answer, click play. Which decimal is equal to 800,000ths? Remember, you can remove the zeros at the end of a decimal without changing the number's value. So in this case, you can remove the 2 zeros at the end of the decimal without changing the number's value. So 800,000ths is equal to 8/10ths. So the answer is C. Now let's review. Decimals are another way to write numbers that aren't whole. They include a point to separate the whole part from the part that's less than a whole. As you move to the left, the place values get 10 times larger. As you move to the right, the place values get 10 times smaller. For example, 1/100th is 10 times smaller than 1/10th. Decimals help you talk about parts of things, like cents with money or measurements that aren't exact whole numbers. For example, you can use decimals when you write numbers like half, pi, or $8.75. So what's next? Review what you learned by doing the knowledge check. Then master what you learned by doing the practice activity. In the next lesson, you'll learn how to round to the nearest decimal place value. I'll see you there. In this lesson, you'll learn how to round decimals to the nearest place value. So let's get started. So why does rounding with decimals matter? Rounding with decimals is a handy life skill that helps you quickly get close estimates. It also helps you avoid having to deal with lots of decimal places. For instance, rounding makes it easier to work with money. Imagine you have $12.78. Rounding to the nearest dollar makes it 13. Rounding also makes numbers friendlier for everyone. For instance, the number pi is approximately 3.141592, which is a mouthful. Rounding it to 3.14 or 3 14/100 simplifies it. Imagine you're at a grocery store and you want to quickly estimate the total cost of your items. You have a few items in your cart. You want to buy a carton of strawberries for $2.49, which rounds down to $2. And you also want to buy a bag of potatoes, which costs $1.89, which rounds up to $2. And finally, you want to buy a carton of milk, which costs $3.79, which rounds up to $4. When you add up your estimates, 2 plus 2 plus 4, you get a total of $8. So you'll spend about $8 on your grocery trip. So how do you round with decimals? Rounding with decimals is very similar to rounding with whole numbers. First, you want to find the digit in the place you're rounding to, and then you want to look at the digit to the right. If that digit is 5 or more, round up. If it's 4 or less, round down. Then round and cut off the extra digits. For example, to round 4 7/10 to the nearest ones place, you need to first find the digit in the ones place, which is 4. And then you need to look at the digit to the right, which is 7. Since 7 is 5 or more, you need to round the ones digit up, which means you need to add 1 to the 4. 4 plus 1 is 5, and the 7 becomes a 0, which gives you 5.0. But the 0 at the end of a decimal does not add any value, so you can get rid of it, which means that 4 7/10, when rounded to the nearest ones or whole place, is approximately equal to 5. You'll notice the squiggly equal sign, which we use when rounding, because this symbol means approximately equal to. Now follow along as I solve this problem. Round 2 4/10 to the nearest ones place. In this case, I need to start by identifying the digit in the ones place, which is 2. And then I need to look at the digit to the right, which is 4. Since 4 is 4 or less, I need to round down, which means the 2 stays the same and the 4 becomes a 0. But once again, I can get rid of the 0 at the end of the decimal because it doesn't add any value. So 2 4/10 when rounded to the nearest whole place is approximately 2. A helpful saying to remember the rounding rules is 5 or more, raise the score. 4 or less, let it rest. Now it's your turn to practice. Pause the video and round 5/10 to the nearest whole or ones place. When you found your answer, click play. To round 5/10 to the nearest ones or whole place, you first need to find the digit in the ones place, which is 0, and then look at the digit to the right, which is 5. Since 5 is 5 or more, you need to round up, which means you need to add 1 to the ones place. So 0 plus 1 equals 1, and the 5 becomes a 0. Since the 0 at the end of a decimal doesn't add any value, you can get rid of it, which means 5/10, when rounded to the nearest ones or whole place, is approximately equal to 1. Now it's time for more practice. Pause the video and solve the word problem. When you found your answer, click play. Marco is measuring the length of a piece of string using a ruler and finds it to be 17 4/10 centimeters long. He needs to round this length to the nearest whole centimeter. What is the correctly rounded length? In this case, you need to round the measurement to the nearest whole place, or the nearest whole number. So the number in the ones place is 7. So look to the digit to the right, which is 4. Since 4 is 4 or less, you need to round down, which means the 7 stays the same, and the 4 becomes a 0. And you can get rid of the 0 after the decimal. So the answer is 17 centimeters, which is A. Now follow along as I solve this problem. Round 3 14/100ths to the nearest tenths place. In this case, I need to round the number to the nearest tenths place, so I first need to identify the digit in the tenths place, which in this case is 1. And then I need to look at the digit to the right, which is 4. Since 4 is 4 or less, I need to round down, which means the 3 and the 1 stay the same, and the 4 becomes a 0. But I can get rid of the 0 at the end of the decimal. That means 3 14/100ths, when rounded to the nearest tenths place, is approximately equal to 3 1/10. Now it's your turn to practice. Pause the video and round 17/100ths to the nearest tenths place. When you found your answer, click play. To round 17/100ths to the nearest tenths place, you first need to find the digit in the tenths place, which is 1, and then look to the digit to the right, which is 7. Since 7 is 5 or more, you need to round up, which means you need to add 1 to the 1/10, which means you get 0.20, and you can drop the 0 at the end of the decimal. So 17/100ths, when rounded to the nearest tenths, is approximately equal to 2/10. Now it's time for more practice. Pause the video and solve the word problem. When you found your answer, click play. Beatrice is timing how long it takes for a water tank to fill up, and she measures it to be 67 59/100 seconds. She needs to round this measurement to the nearest tenth of a second. What is the correctly rounded time for the water tank to fill up? In this case, you need to round to the nearest tenth. So you need to first identify the digit in the tenths place, which in this case is 5. Then you need to look at the digit to the right, which is 9. Since 9 is 5 or more, you need to round up, which means you need to add 1 to the 5, which means you'll get approximately 67.60, and then you can drop the 0 at the end of the decimal. So 67 59/100ths, when rounded to the nearest tenth, is approximately 67 6/10. So the answer is C. Now follow along as I solve this problem. Here I need to round 3 279/100ths to the nearest hundredths place. So I first need to identify the digit in the hundredths place, which in this case is 7. And then I need to look at the digit to the right, which is 9. Since 9 is 5 or more, I need to round up, which means I need to add 1 to the 7, which means I'll get 3.280, and drop the 0 at the end of the decimal. So 3 279/1000ths, when rounded to the nearest hundredth, is approximately 3 28/100ths. Now it's your turn to practice. Pause the video and round 453/1000ths to the nearest hundredth place. When you found your answer, click play. To round 453/1000ths to the nearest hundredths place, you first need to identify the digit in the hundredths place, which is 5, and then look to the digit to the right, which is 3. Since 3 is 4 or less, you need to round down, which means the 5 stays the same. So you get 0.450, and drop the 0 at the end of the decimal, which means 453/1000ths, when rounded to the nearest hundredths, equals 45/100ths. Now it's time for more practice. Pause the video and solve the word problem. When you found your answer, click play. Ivan, a pharmacy technician, is measuring liquid medicine for a prescription. The syringe shows a measurement of 5 673,000 milliliters. He needs to round this measurement to the nearest hundredths place. What is the correctly rounded volume of the liquid medicine? In this case, you need to round to the nearest hundredth place. So you first need to identify the digit in the hundredth place, which in this case is 7. And then look to the digit to the right, which is 3. Since 3 is 4 or less, you need to round down, which means the 7 will stay the same. So you get 5.670 and drop the 0 at the end of the decimal. So 5 673 thousandths, when rounded to the nearest hundredths place, is approximately 5 67 hundredths. So the answer is B. Now follow along as I solve this problem. Round 1.9354 to the nearest thousandths place. Since I'm rounding to the nearest thousandths place, I need to identify the digit in the thousandths place, which in this case is 5. So I need to look at the digit to the right, which is 4. Since 4 is 4 or less, I need to round down, which means the 5 will stay the same. So I'll get 1.935 and 0. And then I can drop the 0 at the end of the decimal. So 1.9354, when rounded to the nearest thousandths place, is approximately 1 935 thousandths. Now it's your turn to practice. Pause the video and round 0.7536 to the nearest thousandths place. And when you found your answer, click play. To round 0.7536 to the nearest thousandths place, you first need to identify the digit in the thousandths place, which in this case is 3. Then look to the digit to the right, which is 6. Since 6 is 5 or more, you need to round up, which means you need to add 1 to the 3. So you'll get 0.7540 and drop the 0 at the end of the decimal. So 0.7536, when rounded to the nearest thousandths place, is approximately 754 thousandths. Now it's time for more practice. Pause the video and solve the word problem. When you found your answer, click play. Claudia is measuring the diameter of a tiny bead, and her caliper displays a measurement of 2.1385 millimeters. She needs to round the measurement to the nearest thousandths place. What is the correctly rounded diameter of the bead? In this case, Claudia needs to round to the nearest thousandths place, so you first need to identify the digit in the thousandths place, which in this case is 8. Then look to the digit to the right, which is 5. Since 5 is 5 or more, you need to round up, which means you need to add 1 to the 8, which gives you 2.1390 and drop the 0 at the end of the decimal. So 2.1385, when rounded to the nearest thousandths place, is approximately 2 139 thousandths. So the answer is D. Now let's review. Rounding decimals is a handy life skill that helps you quickly get approximate answers. It also helps you avoid headaches from dealing with lots of decimal places. Follow these steps to round with decimals. First, find the digit of the place you're rounding to. Then look at the digit to the right. If that digit is 5 or more, round up. If it's 4 or less, round down. Then round and cut off the extra digits. Here is a helpful saying to remember the rounding rules. 5 or more, raise the score. 4 or less, let it rest. So what's next? Review what you learned by doing the knowledge check. Then master what you learned by doing the practice activity. In the next lesson, you'll learn how to compare and order decimals. I'll see you there. In this lesson, you'll learn how to compare and order decimals. So let's get started. So why does this matter? Comparing and ordering decimals is a fundamental math skill that you can use in real life. For example, You use it when comparing prices of items with decimals to find the best deal. You also use it when deciding where to buy gas based on the price per gallon. And finally, you also use it when comparing interest rates when saving or borrowing money with a loan. So how do you compare decimals? When comparing decimals, you should start by looking at the digits from the left, the whole number part, and then move to the right, the decimal part, because the place values to the left are bigger than the place values to the right. Follow these steps to compare decimals. First, line up your decimals so the place values are on top of each other. Then compare the digits from left to right. Once you see different digits, forget about the rest. For example, let's compare these decimals. Here we have 7 and 23 hundredths compared to 4 and 985 thousandths. To compare these decimals, line up the decimal place values so they're on top of each other. Then work left to right. In the ones place, we have 7 and 4, and 7 is bigger than 4. So that means 7 and 23 hundredths is greater than 4 and 985 thousandths. Next we have 5 and 398 ten-thousandths compared to 5 and 124 thousandths. So first we need to line up the decimals so they're on top of each other. Then we need to compare the digits from left to right. Starting with the ones place, we have 5 and 5, so we move to the tenths place, 0 and 1. 0 is less than 1, which means that 5 and 398 ten-thousandths is less than 5 and 124 thousandths. Now follow along as I solve this problem. Compare 2 and 69 hundredths with 2 and 690 thousandths. I'll start by lining up the decimal points so I can compare the decimal places. Here I can add a placeholder 0 at the end of the first decimal. Then I can work from left to right, starting with the ones place. 2 and 2 are the same, 6 and 6 are the same, 9 and 9 are the same, and 0 and 0 are the same. So that means 2 and 69 hundredths is equal to 2 and 690 thousandths, which makes sense because the 0 at the end of a decimal does not add any value, so you can get rid of it. And 2 and 69 hundredths is equal to 2 and 69 hundredths. Now it's your turn to practice. Pause the video and solve the comparison. When you found your answer, click play. Here you need to compare 0.30700 with 0.307. So start by lining up the decimals on top of each other. Here you can add placeholder zeros at the end of the second decimal. Then compare the digits from left to right, starting with 0 and 0, 3 and 3, 0 and 0, 7 and 7, 0 and 0, 0 and 0, which means that the decimals are equal, which makes sense because you can get rid of the zeros at the end of the first decimal because they don't add any value. As you can see, 307 thousandths is equal to 307 thousandths. Now follow along as I solve this problem. Compare 14 and 2 hundredths with 8 and 679 thousandths. I'll start by lining up the decimals on top of each other. And then I can add a trailing 0 at the end of the first decimal and a leading 0 at the beginning of the second decimal. Then I can compare the digits from left to right. 1 is bigger than 0, which means that 14 and 2 hundredths is greater than 8 and 679 thousandths. Now it's your turn to practice. Pause the video and solve the problem. When you found your answer, click play. Here you need to compare 3 and 986 thousandths with 5 and 100th. Start by lining up the decimals. In this case, you can add a trailing 0 at the end of the second decimal. Then compare the digits from left to right. Here you have 3 and 5. 3 is less than 5, which means that 3 and 986 thousandths is less than 5 and 100th. Now follow along as I solve this problem. Here I need to compare 3.1295 with 3.130. I'll start by lining up the decimals. In this case, I can add a trailing 0 to the second decimal. Then I need to compare the digits from left to right. 3 and 3, 1 and 1, 2 is less than 3. So that means the first decimal is less than the second decimal. And remember, when we're comparing, we always compare the decimal on the left to the decimal on the right. And if you're not sure about which sign to put, just think of the less than and greater than symbols as hungry alligator mouths that always want to eat the bigger number. Now it's your turn to practice. Pause the video and solve the problem. When you found your answer, click play. Here you have 7.081 compared to 7.0908. So start by lining up the decimals. In this case, you can add a trailing 0 to the first decimal. Then compare the digits from left to right. 7 and 7, 0 and 0, 8 is less than 9, which means the first decimal is less than the second decimal. So 7 and 81 thousandths is less than 7 and 908 10,000ths. Now follow along as I compare these decimals. Here I have 0.8561 compared to 0.85497. I'll start by lining up the decimals. Here I can add a trailing 0 at the end of the first decimal. Then I need to compare the digits from left to right. 0 and 0 are equal, 8 and 8, 5 and 5, and 6 is greater than 4, which means the first decimal is greater than the second decimal. Now it's your turn to practice. Pause the video and solve the problem. When you found your answer, click play. Here you need to compare 0.108597 with 0.1085, so start by lining up the decimals. In this case, you can add trailing zeros at the end of the second decimal. Then compare the digits from left to right. 0, 0, 1, 1, 0, 0, 8, 8, 5, 5, and 9 is bigger than 0. So the first decimal is greater than the second decimal. Now it's time for more practice. Pause the video and solve the word problem. When you found your answer, click play. In a marine biology lab, a researcher is selecting seashells for an exhibit on ancient marine life. She wants to display the larger shell to captivate visitors. Seashell A is 5 and 98 thousandths centimeters in diameter, while seashell B is 5 and 102 thousandths centimeters in diameter. Which seashell should she choose for the exhibit? In this case, you need to compare the two decimals, so start by lining up the decimals. Then compare the digits from left to right. 5 and 5, and 0 is less than 1. That means 5 and 98 thousandths is less than 5 and 102 thousandths. So the larger seashell is the seashell B. So the researcher should choose seashell B. Now it's time for more practice. Pause the video and solve the word problem. When you found your answer, click play. A team of chemists is comparing the concentrations of two substances in a lab experiment. Substance X has a concentration of 98 thousandths molarity, while substance Y has a concentration of 1300ths molarity. Which substance has the lower concentration? In this case, you need to compare the decimals, so line them up. Here you can add a trailing zero at the end of the second decimal. Then compare the digits from left to right. 0 and 0. 0 is less than 1, which means that 98 thousandths is less than 1300ths. So substance X has the lower concentration. Now follow along as I solve this problem. Here I need to order the decimals from greatest to least, or largest to smallest. So I'll start by lining up the decimals. And then I'll add trailing zeros. Then I'll compare the digits from left to right, asking myself which is bigger. I'll start with the ones place. 0, 0, 0, 0. Then I have 8, which is the biggest digit in the tenths place. So 8 tenths is the largest decimal. Then I have 4 and 4. So I have to keep going. 9 and 9, 1 and 3. And 3 is greater than 1. So the second largest decimal is 493 thousandths. So the third largest decimal is the decimal on top, which means that the decimal on the bottom is the smallest. Which makes sense because it has 1/10, which is less than 4 and 8. So to write out the decimals from greatest to least, I would start with the biggest decimal, which is 8 tenths, which is greater than 493 thousandths, which is greater than 0.4917, which is greater than 0.11643. So this is the order of the decimals from greatest to least, or largest to smallest. Now it's your turn to practice. Pause the video and order the decimals from greatest to least. When you found your answer, click play. To order these decimals from greatest to least, or largest to smallest, start by lining up the decimals. Then add placeholder zeros. Then compare the digits from left to right, asking yourself which digit is bigger. 0, 0, 0, 0. And 9 is the largest digit in the tenths place. So the largest decimal is 96 hundredths. And then you have 7 and 7. So keep going. 0 and 0, 4 and 4, and 3 is bigger than 2. So the second largest decimal is the decimal on top. And the third largest decimal is the decimal on the bottom. And the smallest decimal is the decimal that has 1/10, which makes sense because 1 is less than 7 and 9. Now you can write the decimals from greatest to least, starting with 96 hundredths, which is greater than 0.7043, which is greater than 0.70429, which is greater than 0.170 15. So these are the decimals listed from greatest to least, or largest to smallest. Now it's time for more practice. Pause the video and solve the word problem. When you found your answer, click play. In a chemistry lab, students conducted an experiment to measure the melting point of different substances. Each substance was heated under controlled conditions, and the temperature at which it melted was recorded. The table below displays the recorded melting points. Determine the order of substances from the highest to the lowest melting point. In this case, you need to order the melting points from greatest to least, or highest to lowest. So start by lining up the decimals. Then add placeholder zeros. Then compare the digits from left to right. 7, 7, 7, 5, 5, 5, and 3 is bigger than 2, so the highest melting point is 75 and 3/10. Then keep going with the other two. 2 and 2, 9 is greater than 7, so the second highest melting point is 75 and 29/100, which means the lowest melting point is the decimal on top. So to list the melting points from highest to lowest, start with 75 and 3/10, which is greater than 75 and 29/100, which is greater than 75 and 278 thousandths. So substance Y has a higher melting point than substance Z, which has a higher melting point than substance X. So the order from highest to lowest is substance Y, then substance Z, then substance X. Now follow along as I solve this problem. Here I need to order the decimals from least to greatest, or smallest to largest. So I'll start by lining up the decimals. And then I'll add placeholder zeros. Then I'll compare the digits from left to right, asking which digit is smaller. So here I have 0, which is less than 2 and 3. So the smallest decimal is the first decimal. Then I have 2 and 2. So I have to keep going. 4 and 4, 5 and 5, and 1 is less than 7. So the next smallest decimal is the decimal on the bottom, followed by 2 and 457 thousandths, which means 3 and 97/100 is the largest decimal, which makes sense because 3 is bigger than 2 and 0. Now I need to list out the decimals from least to greatest, starting with the first decimal, which is less than 2.4518, which is less than 2 and 457 thousandths, which is less than 3 and 97/100. So this is the order of the decimals from least to greatest, or smallest to largest. Now it's your turn to practice. Pause the video and solve the problem. When you found your answer, click play. Here you need to order the decimals from least to greatest, or smallest to largest. So start by lining up the decimals. Then add placeholder zeros. Then compare the digits from left to right, asking which digit is smallest. Here you have 0, 0, and 0, so keep going. And then you have 4, which is less than 6, so this is the smallest decimal. Then you have to keep going. 6 and 6, 9 and 9, 1 and 1, and 2 is less than 8. So the next smallest decimal is this one, which means the third smallest decimal is the one on top. And the largest decimal is the 1 and 100th, which makes sense because 1 is bigger than 0. So now you need to list the decimals from least to greatest, starting with 0.47526, which is less than 0.69127, which is less than 0.6918, which is less than 1 and 100th. So this is the order of the decimals listed from least to greatest, or smallest to largest. Now it's time for more practice. Pause the video and solve the word problem. And when you found your answer, click play. In a scientific research project, 3 researchers were asked to compare the molecular weights of different compounds. The table below displays the molecular weights each researcher found. Arrange the compounds in ascending order based on their molecular weights, from the lowest to the highest. Here you need to compare the molecular weights, so start by lining up the decimals. Then add placeholder zeros. Then compare the digits from left to right, asking which digit is smallest. So here you have 1, 1, and 1, and 4 is less than 5, so the smallest decimal is 14 and 9300ths. And then keep going. 5 and 5, and 0 is less than 2. So the next decimal would be 15 and 87 thousandths, which means the largest decimal would be 15 and 26 hundredths. So to arrange the molecular weights from lowest to highest, start with 14 and 93 hundredths, which is less than 15 and 87 thousandths, which is less than 15 and 26 hundredths. So the order of the molecular weights of the compounds from least to greatest would be compound X, which is less than compound Y, which is less than compound Z. So the order from least to greatest would be X, then Y, and then Z. Now let's review. Comparing and ordering decimals is a fundamental math skill that has real-life uses, such as comparing prices of items with decimals to find the best deal, and comparing interest rates when saving or borrowing money with loans. Follow these steps to compare decimals. First, line up your decimals. Then compare the digits from left to right. Once you see different digits, forget about the rest. So what's next? Review what you learned by doing the knowledge check. Then master what you learned by doing the practice activity. In the next lesson, you'll learn how to add and subtract decimals. I'll see you there! In this lesson, you'll learn how to add and subtract decimals. So let's get started. Let's take a look at an example where you use adding and subtracting decimals in the real world. Jenna was out grocery shopping after work, trying to stick to her budget. She added up the prices of the items she had in her cart. A bag of rice for $2.75, chicken breast for $5.25, and a bottle of olive oil for $6.45. Using her phone's calculator, she added these costs together. $2.75 plus $5.25 plus $6.45 equals $14.45. Jenna now needed to see how much money she had left in her budget. She started with $30 and subtracted the total cost of her groceries. $30 minus $14.45 equals $15.55. Jenna realized that she had $15.55 left to spend while staying within her budget, making it easier for her to manage her expenses during her shopping trip. So how do you add and subtract decimals? It's like regular addition and subtraction with whole numbers. The key is to make sure you line up the decimal points directly on top of each other. That's it. Here we have 15 7/10 plus 2 36/100. So first, I'll start by lining up the decimals. So I'll write 15 7/10, and then I'll write 2 36/100 below it, making sure I line up the decimals one on top of the other. Then I can add a placeholder 0. Now I can add up the digits. 0 plus 6 is 6. 7 plus 3 is 10, so I'll put 0 and regroup the 1. 5 plus 2 is 7, plus 1 is 8. And then I'll bring down the 1. And then I'll bring down the decimal directly below in my answer. So the answer is 18 6/100. Now follow along as I solve this problem. Here I have 5 1,000 plus 23 7/10. So I'll start by writing the first decimal, and then placing the second decimal directly below, making sure to line up the decimals. And then I'll add placeholder zeros. In this case, I can add a leading 0 in the decimal on top and 2 trailing zeros to the decimal on the bottom. Then I can add like normal. 1 plus 0 is 1, 0 plus 0 is 0, 0 plus 7 is 7, 5 plus 3 is 8, and 0 plus 2 is 2. Then I'll bring down the decimal directly below in my answer. So the answer is 28 701,000ths. Now it's your turn to practice. Pause the video and add the numbers together. When you found your answer, click play. Here you have 6 plus 74 and 125 thousandths. In this case, it would be easier to list the number with more decimal places first. So you have 74 and 125 thousandths plus 6. And in this case, every whole number in the ones place has an imaginary decimal to the right. And then you can add 3 placeholder zeros. Now add like normal. 5 plus 0 is 5, 2 plus 0 is 2, 1 plus 0 is 1, 4 plus 6 is 10, so bring down the 0 and regroup the 1, 7 plus 1 is 8. Then bring down the decimal directly below in your answer. So the answer is 80 125 thousandths. Now it's time for more practice. Pause the video and solve the word problem. When you found your answer, click play. Samantha is getting ready for the new school year, and she needs to buy some school supplies. She wants to buy a backpack for $28.50, a set of colored pencils for $4.75, and a notebook for $2.99. How much will Samantha spend in total on these school supplies? In this case, you need to add up the numbers together, starting with $28.50. Then add $4.75, and finally add $2.99. As you can see, it's important to line up your decimals directly on top of each other. If it helps, you can add leading zeros. Now add like normal. 9 plus 5 is 14, so 4 regroup the 1. 9 plus 7 is 16, plus 5 is 21, plus 1 is 22. So bring down the 2 and regroup the 2. 2 plus 4 is 6. Plus 8 is 14. Plus 2 is 16. Bring down the 6 and regroup the 1. 2 plus 1 is 3. And then bring down the decimal directly below in your answer. So in this case, Samantha will spend $36.24. Now follow along as I solve this problem. Here I'm subtracting 7/100 from 9. Since I'm subtracting, I need to write the bigger number first, which is 9. So I'll write 9, and then I'll add a decimal to the right of the ones place, followed by 2 placeholder zeros. And then I'll subtract 7/100, making sure to line up my decimals directly on top of each other. And then I can subtract like normal. I can't take away 7 from 0, and I can't borrow from 0, so I have to keep going. I can't subtract 0 from 9, so I'll regroup the 9 and make that 8, and then the 0 becomes a 10, and then I need to regroup again, so the 10 becomes a 9, and the 0 becomes a 10. Now I can subtract. 10 minus 7 is 3, 9 take away 0 is 9, and 8 take away 0 is 8. And then I'll bring my decimal directly below in my answer. So the answer is 8 93/100. Now it's your turn to practice. Pause the video and solve the problem. When you found your answer, click play. Here you have 7 11/100 minus 4/10. So start by writing the bigger number on top, which is 7 11/100 minus 4/10, making sure you line up your decimals directly on top of each other. If it helps, you can add a placeholder 0 to the bottom decimal. Then subtract like normal. 1 minus 0 is 1, but here you can't take away 4 from 1, so you need to regroup from the 7. So the 7 becomes a 6, and the 1 becomes an 11. 11 take away 4 is 7, and 6 take away 0 is 6. And then bring down your decimal directly below in your answer. So the answer is 6 71/100. Now it's time for more practice. Pause the video and solve the word problem. When you found your answer, click play. Tommy is saving up to buy a new bike. He has saved $275.50 so far, but he needs to subtract the cost of a video game he just bought, which was $39.99. How much money does Tommy have left for his bike fund after buying the video game? In this case, you need to start with the amount that he saved, which was $275.50. And then you need to subtract the cost of the video game, which was $39.99, making sure you line up your decimals directly on top of each other. Then subtract like normal. Here you can't take away 9 from 0, so move to the next decimal place. Once again, you can't take away 9 from 5. And the same is true for the ones place. You can't take away 9 from 5, so move to the tens place. Here you can take away 3 from 7, so you can regroup from the 7, which becomes 6. And then the 5 becomes 15. But then you need to regroup again, so the 15 becomes 14. And the 5 becomes a 15. But you need to regroup again, so the 15 becomes a 14, and the 0 becomes a 10. Now you can subtract. 10 take away 9 is 1. 14 take away 9 is 5. 14 take away 9 is 5 again. 6 take away 3 is 3. And bring down the 2. And then bring down your decimal directly below in your answer. So Tommy still has $235.51 saved up for his bike. Now let's review. Adding and subtracting with decimals is like regular addition and subtraction with whole numbers. The key is to make sure you line up the decimal points directly on top of each other. Start by arranging the numbers so the decimal points line up, adding placeholder zeros if it helps. Then add and subtract normally, and make sure to put the decimal directly below in the answer. Knowing how to add and subtract decimals is important in real life because it helps you manage money, like budgeting for groceries or calculating expenses, which helps you spend and save money wisely. So what's next? Review what you learned by doing the knowledge check. Then master what you learned by doing the practice activity. In the next lesson, you'll learn how to multiply decimals. I'll see you there. In this lesson, you'll learn how to multiply decimals. So let's get started. First, let's take a look at a real-world use of multiplying decimals. At a bustling farmer's market, Emily needed to calculate the cost of her purchases. She bought 2 5/10 pounds of ripe tomatoes at $2.99 per pound and 1 2/10 pounds of fresh strawberries at $3.49 per pound. To determine her total, she multiplied the weight of each item by its price per pound and added them up for her final bill. Knowing how to multiply with decimals made shopping a breeze. Now let's talk about a shortcut when multiplying decimals by factors of 10. Decimals are based on factors of 10, so moving a decimal place to the right is the same as multiplying by 10. So when multiplying by 10, move the decimal to the right. When you multiply 15 thousandths by 10, that's the same as moving the decimal one place to the right. So that becomes 15 hundredths. To multiply 15 hundredths times 10, once again move the decimal place to the right. So that becomes 1 5/10. To multiply 1 5/10 times 10, move the decimal one place to the right. So that becomes 15. Another example is multiplying 3 729 thousandths times 10. Since you're multiplying by 10, which only has one zero, you move the decimal point only one place to the right. So that gives you 37 29 hundredths. To multiply the same number by 100, which has two zeros, you would move the decimal point two places to the right, which gives you 372 9/10. To multiply the same number by 1,000, which has three zeros, move the decimal point three places to the right, which gives you 3,729. Now follow along as I solve this problem. Here I have 456 thousandths times 10. Since I'm multiplying by 10, which has one zero, I'll move the decimal one place to the right, which gives me 4 56 hundredths. Now it's your turn to practice. Pause the video and solve the problem. When you found your answer, click play. Here you have 76 32 hundredths times 100. Since you're multiplying by 100, which has two zeros, move the decimal point two places to the right, which gives you 7,632 and 0/10. So how do you multiply decimals when you're not multiplying by a factor of 10? First, multiply the numbers like you normally do, without worrying about the decimal points. And unlike adding and subtracting with decimals, you do not need to line up the decimals when multiplying. So here you need to multiply 2 75 hundredths times 4. So first multiply 4 times 5, which is 20. So write down 0 and regroup the 2. 4 times 7 is 28, plus 2 is 30. So bring down the 0 and regroup the 3. 4 times 2 is 8, plus 3 is 11. Next, check the total number of decimal places in the numbers that you multiplied. Here you have 2 decimal places, 1, 2. And 4 is a whole number, so it does not have any decimal places. So starting from the right, move the same number of decimal places to the left, and put the decimal point there in the answer. So 1, 2, and then add your decimal point. so the answer is 11. Now follow along as I solve this problem. Here I have 75 hundredths times 13 and 2 tenths. In this case, it would be better to put the number with more digits on top. So I'll write 13 and 2 tenths times 0 and 75 hundredths. You'll notice that I lined up the last digits in each number to the far right, so they're on top of each other. Even though you need to line up the decimals when adding and subtracting them, you do not need to line up your decimals when you're multiplying them. Now I can multiply like normal. 5 times 2 is 10, so I'll bring down the 0 and regroup the 1. 5 times 3 is 15, plus 1 is 16, so I'll bring down the 6 and regroup the 1. 5 times 1 is 5, plus 1 is 6. And then I'll add a placeholder 0. And then I'll do 7 times 2, which is 14, so I'll bring down the 4 and regroup the 1. 7 times 3 is 21, plus 1 is 22, so I'll bring down the 2 and regroup the 2. 7 times 1 is 7, plus 2 is 9. And I don't need to multiply the 0 across, because I'll just get all zeros. Now I can add the partial products. 0 plus 0 is 0. 6 plus 4 is 10, which is 0. Regroup the 1. 6 plus 2 is 8, plus 1 is 9. And I'll bring down the 9. And then I need to ask myself, how many decimal places do I need in my answer? Well, in this case, I have 1, 2, 3 decimal places in the numbers that I multiplied. So starting from the right, I need to move over 3 decimal places. 1, 2, 3. Which means my answer is 9 and 9 tenths, because I don't need the trailing zeros. Now it's your turn to practice. Pause the video and solve the problem. When you found your answer, click play. Here you have 3 and 49 hundredths times 15 hundredths. And you'll notice that you need to line up the last digits in each number. Now you can multiply like normal. 5 times 9 is 45, so bring down the 5 and regroup the 4. 5 times 4 is 20, plus 4 is 24, so regroup the 2. 5 times 3 is 15, plus 2 is 17. Then add a placeholder 0. Now do 1 times 9 is 9, 1 times 4 is 4, and 1 times 3 is 3. You don't need to multiply by the last 0, so add up your partial products. 5 plus 0 is 5, 4 plus 9 is 13, so regroup the 1. 7 plus 4 is 11, plus 1 is 12, so regroup the 1 again. 1 plus 3 is 4, plus 1 is 5. Now to add the decimal point, you need to count the total number of decimal places in the numbers you multiplied, which is 1, 2, 3, 4. So starting from the right, move the decimal point 4 places to the left. 1, 2, 3, 4. And you can add a leading 0. So the answer is 0.5235. Now it's time for more practice. Pause the video and solve the word problem. When you found your answer, click play. You need to purchase 24 5/10 pounds of almonds, and the price per pound is $8.99. What will be the total cost of the almonds? In this case, you need to multiply 24 5/10 times the cost per pound, which is $8.99. Once again, you do not need to line up your decimals when multiplying. 9 times 5 is 45, so regroup the 4. 9 times 4 is 36, plus 4 is 40, so regroup the 4. 9 times 2 is 18, plus 4 is 22. Then add a placeholder 0. 9 times 5 is 45, so regroup the 4. 9 times 4 is 36 plus 4 is 40, so regroup the 4 again. 9 times 2 is 18 plus 4 is 22. Now you need to add 2 placeholder zeros. 8 times 5 is 40, so regroup the 4. 8 times 4 is 32, plus 4 is 36, so regroup the 3. 8 times 2 is 16, plus 3 is 19. Now you can add up your partial products. 5 plus 0 plus 0 is 5. 0 plus 5 plus 0 is also 5. 2 plus 0 plus 0 is 2. 2 plus 2 is 4, plus 6 is 10, so regroup the 1. 9 plus 1 is 10, plus 2 is 12, so regroup the 1 again, and 1 plus 1 is 2. To put the decimal point in the correct spot in your answer, you need to find the total number of decimal places in the numbers you multiplied. Here you have 1, 2, 3 decimal places. So starting from the right, you need to move 3 decimal places to the left. 1, 2, 3. So you get 220 and 255 thousandths. Since you need to find the total cost, you need to round your answer to the nearest hundredth or the nearest cent. The digit in the hundredth place is 5, so you need to look to the right, which is 5 thousandths. Since 5 is 5 or more, you round up, which means the 5 hundredths become 6 hundredths. So when rounded, the answer would be $220.26. Now let's talk about leading and trailing zeros. Trailing zeros at the end of a decimal do not change its value. For example, 1 and 20 hundredths is equal to 1 and 2 tenths. The same is true for leading zeros before a decimal point, which also do not change a number's value. For example, 0.4 is equal to 4 tenths. So, will you get the same answer if you multiply without the leading and trailing zeros? Well, let's take a look. First, let's multiply 1 and 20 hundredths times 0.4. 4 times 0 is 0, 4 times 2 is 8, and 4 times 1 is 4. Then add a placeholder 0. 0 times 0 is 0, 0 times 2 is 0, and 0 times 1 is 0. Now let's add up the partial products. 0 plus 0 is 0, 8 plus 0 is 8, 4 plus 0 is 4, and bring down the 0. Now we need to add 1, 2, 3 decimal places in our answer. 1, 2, 3. So the answer is 0 and 480 thousandths. Now let's multiply the numbers without the trailing and leading zeros. So we have 1 and 2 tenths times 4 tenths. So 4 times 2 is 8, and 4 times 1 is 4. Now we need to add 1, 2 decimal places. 1, 2. Now you can add a leading zero. As you can see, you get the same answer because 480 thousandths is really the same as 48 hundredths. So either way works. You can either multiply with or without the trailing and leading zeros. Now follow along as I solve this problem. Here I have 60 hundredths times 8 and 4 tenths. In this case, I'll rewrite this as 8 and 4 tenths times 6 tenths, because we don't need the leading or trailing zero in the first decimal. Now I can multiply like normal. 6 times 4 is 24, so I'll regroup the 2. 6 times 8 is 48, plus 2 is 50. Now I need to add 1, 2 decimal places in my answer. 1, 2. So my answer is 5 4/100ths. Now it's your turn to practice. Pause the video and solve the problem. When you found your answer, click play. Here you can rewrite the problem as 9 8/10ths, since you don't need the trailing zero at the end of the first decimal, times 12/100ths, since you don't need the leading zero at the beginning of the second decimal. Now you can multiply like normal. 2 times 8 is 16, so regroup the 1. 2 times 9 is 18, plus 1 is 19. Then add a placeholder 0. 1 times 8 is 8, and 1 times 9 is 9. Now you can add the partial products. 6 plus 0 is 6. 9 plus 8 is 17, so regroup the 1. 9 plus 1 is 10, plus 1 is 11. Now you need to find the total number of decimal places in the numbers you multiplied. 1, 2, 3. So you need to move the decimal point 3 places to the left. 1, 2, 3. So the answer is 1 176 thousandths. Now it's time for more practice. Pause the video and solve the word problem. When you found your answer, click play. A spice shop sells saffron in packets, with each packet containing 15 2/10 ounces of saffron. If the cost is 60 cents per ounce, how much does it cost to buy 1 packet of saffron? In this case, you need to multiply the number of ounces in each packet, which is 15 2/10, times the cost per ounce, which is 60 cents. But here you can get rid of the leading and trailing zeros. So that becomes 6/10, and then you can multiply them. 6 times 2 is 12, so regroup the 1. 6 times 5 is 30, plus 1 is 31, so regroup the 3. And 6 times 1 is 6, plus 3 is 9. Now you need to add your decimal in the answer. So count the number of decimal places in the numbers you multiplied. 1, 2. So move the decimal place 2 places to the left. 1, 2. As you can see, the total cost of 1 packet would be $9.12. Now let's review. Decimals are based on factors of 10. So moving a decimal place to the right is the same as multiplying by 10. Follow these steps to multiply decimals. First, multiply the numbers like you normally do, without worrying about the decimal points. Remember, when multiplying, you do not need to line up the decimal points. Once you get your answer, check the total number of decimal places in the numbers that you multiplied. Then, starting from the right, move the same number of decimal places to the left and put the decimal point there in the answer. As a shortcut, you can drop any leading or trailing zeros to make multiplication easier. Knowing how to multiply decimals is important in real life because it helps you calculate expenses and income, ensuring you spend and save wisely. So what's next? Review what you learned by doing the knowledge check. Then master what you learned by doing the practice activity. In the next lesson, you'll learn how to divide decimals. I'll see you there. In this lesson, you'll learn how to divide with decimals. So let's get started. First, let's talk about dividing decimals by factors of 10. Decimals are based on factors of 10, so moving a decimal place to the left is the same as dividing by 10. So to divide by 10, you move the decimal to the left. So first we have 15 divided by 10, and any whole number has a decimal to the right of the ones place. So if we divide by 10, we need to move the decimal 1 place to the left. So 15 divided by 10 equals 1 5/10. If you take 1 5/10 and divide it by 10, once again you need to move the decimal point 1 place to the left. So the answer is 15/100ths. To divide 15/100ths by 10, once again, move the decimal point one place to the left, which gives you 15 thousandths, and so on. Here's another example. Here you have 372 9/10 divided by 10, which has 1 0. So you move the decimal place one space to the left, which gives you 37 29/100. If you take the same number and divide it by 100, which has 2 zeros, you'll move the decimal point two places to the left, 1, 2, which gives you 3 729 thousandths. If you take the same number and divide it by 1,000, which has 3 zeros, you'll move the decimal point three places to the left, 1, 2, 3, which gives you 0.3729. Now follow along as I solve this problem. Here I have 45 6/10 divided by 10. In this case, I'm dividing by 10, which has 1 0. So I need to move the decimal point one place to the left, which gives me 4 56/100. Now it's your turn to practice. Pause the video and solve the problem. When you found your answer, click play. Here you have 7,632 divided by 100. In this case, you're dividing by 100, which has 2 zeros, which means you need to move the decimal point two places to the left. And remember, every whole number has a decimal to the right of the ones place. So you need to move the decimal two places to the left, 1, 2, which means you get an answer of 76 32/100. Now let's review the parts of a division problem. On a recent road trip with friends, you covered expenses like fuel, tolls, and accommodations, totaling $325.60. There were 5 of you on the trip. How much should each person pay if you split the expenses? The amount you're dividing into, or the dividend, goes inside the division house. So in this case, the dividend would be the total cost, which is $325.60. The number you're dividing by, or the divisor, goes outside and in front of the division house. So in this case, you're splitting the bill amongst 5 friends, so the divisor is 5. The answer, or quotient, to the division problem goes above the roof of the division house. In this case, the quotient is $65.23, which is the cost per person. Now let's talk about dividing into decimals. So in step 1, you first want to move the decimal directly up and above the roof of the division house. So in this case, I'll move the decimal directly above the roof. And then I would divide like normal. 3 goes into 5 one whole time, which means you get a remainder of 2. And then I'll bring down the 1. And 3 goes into 21 7 times, which means I'm left with a remainder of 0. So the answer is 1 7/10. And if you want to check if your answer is correct, you can always multiply the quotient by the divisor to get the dividend. So you can do 1 7/10 times 3. 3 times 7 is 21, so bring down the 1 and regroup the 2. 3 times 1 is 3, plus 2 is 5. In this case, I have one decimal place in the numbers that I multiplied, so I should have one decimal place in my answer, which means the answer is 5 1/10, which is the same as the dividend inside the house, which means the answer is correct. Now follow along as I solve these problems. Here I have 71/100 divided by 2. So I need to start by moving the decimal directly up. And then I can divide like normal. 2 cannot go in a 0, so I'll write a 0 on top. 2 goes into 7 3 whole times, and 3 times 2 is 6, which means I have a remainder of 1, and then bring down the 1. 2 goes into 11 5 times. 5 times 2 is 10, which means I'm left with the remainder of 1. But in this case, I can't leave it as a remainder, so I need to keep going, and I can always add trailing zeros to any number without changing the value. And then I'll bring down the 0. 2 goes into 10 5 times. 5 times 2 is 10, which means I'm left with the remainder of 0. So my answer is 355 thousandths. Next I have 54 thousandths divided by 9. Once again, I need to move the decimal directly above the house. 9 goes into 0 0 times. Once again, 9 goes into 0 0 times. 9 cannot go into 5, so I'll write 0 again. And 9 goes into 54 6 times, because 6 times 9 is 54, which means I'm left with the remainder of 0. So my answer is 6 thousandths. Here I have 36 divided by 8, and any whole number has a decimal place to the right of the ones place, which I can then bring up above the division house. And then I can divide like normal. 8 goes into 3 0 times, and 8 goes into 36 4 times, because 4 times 8 is 32, which means I'm left with the remainder of 4. And once again, I have to keep going, so I can add a trailing 0 to 36. And then I'll bring it down. 8 goes into 40 5 times. 5 times 8 is 40, so I have a remainder of 0, which means my answer is 4 5/10. Now it's your turn to practice. Pause the video and solve the problems. When you found your answers, click play. Here you have 15 hundredths divided by 6. So first you need to bring up the decimal directly above the division house. Then divide like normal. 6 goes into 0 0 times. 6 goes into 1 0 times. And 6 goes into 15 2 times. 2 times 6 is 12, which means you're left with the remainder of 3. But you have to keep going, so you can add a trailing 0, and then bring it down. 6 goes into 30 5 times, because 5 times 6 is 30, which means you're left with the remainder of 0. So the answer is 25 thousandths. Next you have 68 thousandths divided by 4. So first bring up the decimal directly above the division house. Then divide like normal. 4 can't go into 0, 4 can't go into 0 again, and 4 goes into 6 one whole time, which means you're left with the remainder of 2. Then bring down the 8. 4 goes into 28 7 times, because 7 times 4 is 28. So you're left with the remainder of 0, which means the answer is 17 thousandths. Last you have 97 divided by 5. And 97, like any whole number, has a decimal point to the right of the ones place, which you can then bring up in your answer. Then divide like normal. 5 goes into 9 one whole time, which gives you a remainder of 4. Then bring down the 7. 5 goes into 47 9 whole times, because 9 times 5 is 45, which means you're left with the remainder of 2. Then add a trailing 0, and then bring it down. 5 goes into 20 4 times, because 4 times 5 is 20, which means you're left with the remainder of 0. So the answer is 19 4/10. Now it's time for more practice. Pause the video and solve the word problem. When you found your answer, click play. 3 friends decided to dine at a local restaurant. Their delicious meal cost $54.27, including tax and tip. They want to divide the dinner bill equally among themselves. How much should each person pay? In this case, you need to divide the total cost, which is $54.27, by the number of people that are splitting it up, which is 3. Then bring up the decimal above the division house and divide like normal. 3 goes into 5 one whole time, with a remainder of 2. Then bring down the 4. 3 goes into 24 8 times, because 8 times 3 is 24, which means you're left with the remainder of 0. Then bring down the 2. And 3 does not go into 2, so write a 0 above the 2. And then bring down the 7. 3 goes into 27 9 times, because 9 times 3 is 27, which means you're left with the remainder of 0. So each person should pay $18.09. Now let's talk about dividing by decimals. In this case, we have 3 divided by 75 hundredths. In step number 1, make the divisor a whole number by moving its decimal to the right, and remember how many places you moved it. In this case, the divisor is 75 hundredths, so I need to move the decimal point 2 places to the right. In step number 2, move the decimal in the dividend, which is inside the division symbol, the same number of places to the right, and you might need to add zeros. Any whole number has a decimal to the right of the ones place, so I need to move the decimal 2 places to the right. 1, 2, which means I need to add 2 placeholder zeros. So I can rewrite the problem as 300 divided by 75, and then divide like normal. 75 cannot go into 3 or 30, but 75 goes into 300 4 times, because 4 times 75 is 300, which means we have a remainder of 0. So the answer is 4. Now follow along as I solve these problems. Here I have 1 7/10 divided by 5 hundredths, so I need to move the decimal point in the divisor 2 places to the right. And then I need to do the same for the dividend, 1, 2, which means I need to add a placeholder 0. So I can rewrite the problem as 170 divided by 5. And then I can divide like normal. 5 can't go into 1, and 5 goes into 17 3 times, because 3 times 5 is 15, which leaves me with the remainder of 2. Then I can bring down the 0. 5 goes into 20 4 times, because 4 times 5 is 20, which leaves me with the remainder of 0. So my answer is 34. Next I have 3 3/10 divided by 6/10, so I need to move the decimal point in the divisor 1 place to the right, and then I'll do the same in the dividend. So I can rewrite the problem as 33 divided by 6, and then divide like normal. 6 can't go into 3, and 6 goes into 33 5 times, because 5 times 6 is 30, which leaves me with the remainder of 3, but I need a decimal answer, so I have to keep going. So I'll add a decimal to the right of the ones place in the dividend, and then bring it directly up in the answer. And then I'll add a trailing 0, and then I'll bring it down. 6 goes into 30 5 times, because 5 times 6 is 30, which leaves me with the remainder of 0. So the answer is 5 5/10. Last, I have 7/10 divided by 3 5/10. So I need to move the decimal point in the divisor 1 place to the right, and I'll do the same in the dividend. So I can rewrite the problem as 7 divided by 35. And every whole number has a decimal point to the right of the ones place, which I can then bring up above the division symbol and into my answer. Then divide like normal. 35 does not go into 7. Then I'll add a trailing 0. 35 goes into 70 2 times, because 2 times 35 is 70, which leaves me with the remainder of 0. So my answer is 2/10. Now it's your turn to practice. Pause the video and solve the problems. When you found your answers, click play. Here you have 1 8/100 divided by 9/100. So move the decimal point in the divisor 2 places to the right. And do the same in the dividend, which gives you 108 divided by 9. And 9 can't go into 1. 9 goes into 10 one whole time, which means you're left with the remainder of 1, and then bring down the 8. 9 goes into 8 2 times, because 2 times 9 is 18, leaving you a remainder of 0. So the answer is 12. Next you have 3/10 divided by 6/10. So once again, move the decimal point in the divisor 1 place to the right, and do the same in the dividend, which means you have 3 divided by 6, and 6 can't go into 3. So put a decimal point to the right of the 3 and then bring it up in your answer. Then add a trailing 0. 6 goes into 30 5 times, because 5 times 6 is 30, leaving you a remainder of 0. So the answer is 5/10. Last, you have 85/100 divided by 2 5/10. So you need to move the decimal point in the divisor 1 decimal place, and then do the same in the divisor, and then bring it directly up in your answer. That gives you 8 5/10 divided by 25. And 25 can't go into 8. Then bring up your decimal point. 25 can go into 85 3 times, because 3 times 25 is 75, which means you're left with the remainder of 10. Then add a 0 and bring it down. 25 goes into 100 4 times, because 4 times 25 is 100, which leaves you with the remainder of 0. So the answer is 34/100. Now it's time for more practice. Pause the video and solve the word problem. When you found your answer, click play. A pharmacist has 8 25/100 milliliters of medicine. Each patient needs to receive a dosage of 1 5/10 milliliters. How many patients can receive a dosage from the available medicine? In this case, you need to divide 8 25/100 by 1 5/10. So you need to move the decimal point in the divisor 1 place to the right, and then do the same in the dividend. Now you can rewrite the problem as 82 5/10 divided by 15. Next, bring up the decimal point above the division symbol and into your answer. Now divide like normal. 15 can't go into 8, and 15 goes into 82 5 times, because 5 times 15 is 75, which leaves you with the remainder of 7. Then bring down the 5. 15 goes into 75 5 times, because 5 times 15 is 75, which leaves you with the remainder of 0. In this case, the pharmacist only has enough medicine for 5 doses and not quite 6. So the answer would be 5 patients. Now let's review. Decimal division is useful in various real-life situations, such as splitting restaurant bills, travel expenses, and grocery costs with family and friends. When dividing into decimals, move the decimal point in the dividend straight above the roof of the division house. Add zeros if necessary, and then divide like normal. To divide by decimals, change the divisor into a whole number by moving its decimal point to the right. Then move the dividend's decimal point the same number of places to the right, moving it above the division symbol, and then divide like normal. So what's next? Review what you learned by doing the knowledge check. Then master what you learned by doing the practice activity. In the next lesson, you'll learn how to convert fractions and mixed numbers to decimals. I'll see you there. In this lesson, you'll learn how to convert fractions and mixed numbers to decimals. So let's get started. First, let's talk about some real-life uses. You might need to convert a fraction to a decimal while shopping to compare discounts. For instance, if one item is a fourth off and another is a third off, converting these fractions to decimals can make it easier to see which discount is better. Since 1/4 is equal to 25 hundredths and 1/3 is equal to 33 hundredths, it's clear that you'll save more with a 1/3 discount than 1/4 off. So how do you convert fractions to decimals? Fractions are really division problems in disguise, so to convert a fraction to a decimal, just divide its numerator on top by its denominator on the bottom. For example, to convert 1/2 to a decimal, you would divide 1, which is on top, by 2, which is on the bottom. You can think of pushing the numerator on top to the right so it falls inside the division house. Remember, every whole number has a decimal to the right of the ones place, which you can bring up in your answer. And then divide like normal. 2 can't go into 1, so add a trailing 0. And 2 goes into 10 5 times, because 5 times 2 is 10, which leaves a remainder of 0. So 1/2 is equal to 5/10. To convert 1/4 to a decimal, divide 1 by 4. And remember, every whole number has a decimal to the right of the ones place, so bring it up in your answer. 4 doesn't go into 1, so add a trailing 0. 4 goes into 10 2 times, because 2 times 4 is 8, which leaves a remainder of 2. So keep going by adding a trailing 0 and bringing it down. And 4 goes into 20 5 times, because 5 times 4 is 20, which leaves a remainder of 0. So 1/4 as a decimal is 25 hundredths. Now we have 3/3. So 3/3 is really 3 divided by 3. And 3 goes into 3 one whole time, with the remainder of 0. So 3/3 simplifies to 1. So once again, to convert a fraction to a decimal, divide the numerator on top by the denominator on the bottom. So 3/8 is equal to 3 divided by 8. And remember that every whole number has a decimal to the right of the ones place, which you can bring directly up, and then divide like normal. 8 doesn't go into 3, so add a 0. 8 goes into 30 3 times, because 3 times 8 is 24, which leaves a remainder of 6. So add another trailing 0. Then bring it down. 8 goes into 60 7 times, because 7 times 8 is 56, which leaves a remainder of 4. So add another trailing 0 and bring it down. 8 goes into 40 5 times, because 5 times 8 is 40, which leaves a remainder of 0. So 3/8 as a decimal is equal to 375 thousandths. Now follow along as I solve these problems. Here I need to convert the fractions to decimals. And remember, top-light or proper fractions, which have a numerator on top which is less than the denominator on the bottom, should convert to decimals less than 1. For example, 1/8, which is really 1 divided by 8. And remember, every whole number has a decimal to the right of the ones place, which I can bring up directly above in the answer. And then I'll divide like normal. 8 can't go into 1, so I'll add a trailing 0. 8 goes into 10 one time, which leaves a remainder of 2. So I'll add another trailing 0, and then I'll bring it down. 8 goes into 20 two times, because 2 times 8 is 16, which leaves a remainder of 4. So I'll add another trailing 0, and then bring it down. 8 goes into 40 5 times, because 5 times 8 is 40, which leaves a remainder of 0. So 1/8 as a decimal is 125 thousandths. Next I have the fraction 4/5, which is the same as 4 divided by 5. And I need to add a decimal to the right of the ones place, and then bring it up. And then divide like normal. 5 can't go into 4, so I'll add a trailing 0. 5 goes into 40 8 times, because 8 times 5 is 40, which leaves a remainder of 0. So 4/5 as a decimal is 8/10. Now it's your turn to practice. Pause the video and solve the problems. When you found your answers, click play. Here you need to convert the fractions to decimals. So 7/10 is the same as 7 divided by 10. So add a decimal to the right of the ones place and bring it up. Then divide like normal. 10 can't go into 7, so add a trailing 0. 10 goes into 70 7 times, because 7 times 10 is 70, which leaves a remainder of 0. So 7/10 as a decimal is 0.7, or 7/10. Next you have 3/4, which is the same as 3 divided by 4. So add a decimal to the right of the ones place, and then bring it up. 4 can't go into 3, so add a trailing 0. 4 goes into 30 7 times, because 7 times 4 is 28, which leaves a remainder of 2. So add another trailing 0 and bring it down. 4 goes into 20 5 times, because 5 times 4 is 20, which leaves a remainder of 0. So 3/4 equals 75 hundredths, which makes sense, because 3/4 is like 3/4, which is equal to 75 cents. Now follow along as I solve these problems. Here I need to convert the fractions to decimals. But remember, top-heavy or improper fractions, which have a numerator on top which is greater or larger than the denominator on the bottom, should convert to decimals greater than 1. For example, 3/2, which is 3 divided by 2. And 2 goes into 3 one time, which leaves a remainder of 1. So I need to add a decimal to the right of the ones place, and then bring it up in my answer. Then I'll add a trailing 0 and bring it down. 2 goes into 10 5 times, because 5 times 2 is 10, which leaves a remainder of 0. So 3/2 is equal to 1 5/10. Next I have 11/5, which is the same as 11 divided by 5. And then I can divide like normal. 5 can't go into 1, but 5 goes into 11 2 times, because 2 times 5 is 10, which leaves a remainder of 1. So I'll add a decimal to the right of the ones place, and then bring it up in my answer. And then I'll add a trailing 0 and bring it down. 5 goes into 10 2 times, because 2 times 5 is 10, which leaves a remainder of 0. So 11/5 is equal to 2 2/10. Now it's your turn to practice. Pause the video and solve the problems. When you found your answers, click play. Here you need to convert the fractions to decimals. So divide the numerator on top by the denominator on the bottom. So 17/10 becomes 17 divided by 10. And 10 can't go into 1, but 10 goes into 17 one time, which leaves you with the remainder of 7. So add a decimal to the right of the ones place, then bring it up in your answer. Then add a trailing 0, and then bring it down. And 10 goes into 70 7 times, because 7 times 10 is 70, which leaves you with the remainder of 0. So 17 tenths is equal to 1 7/10. Next you have 9 fourths, which is the same as 9 divided by 4. And 4 goes into 9 2 times, which leaves you with the remainder of 1. So add a decimal to the right of the ones place and bring it up in your answer. Then add a trailing 0, and then bring it down. 4 goes into 10 2 times, because 2 times 4 is 8, which leaves you with the remainder of 2. So add another trailing 0, and then bring it down. And 4 goes into 20 5 times, because 5 times 4 is 20, which leaves a remainder of 0. So 9 fourths as a decimal is equal to 2 25/100ths. Now let's talk about fractions with the denominator of 10, 100, or 1,000. When you have a fraction with the denominator of 10 or 100, that means you'll divide the numerator by 10 or 100. When you divide by 10, move the decimal one space to the left. So 27 tenths would be 27 divided by 10. So move the decimal one place to the left, which gives you 2 7/10. When you divide by 100, move the decimal 2 spaces to the left. So 27 hundredths is equal to 27 divided by 100. So move the decimal 2 places to the left, which gives you 27 hundredths. When you divide by 1,000, move the decimal 3 places to the left. So 27 thousandths is equal to 27 divided by 1,000. So move the decimal 2, 3 places to the left. So that gives you 27 thousandths. Now follow along as I solve this problem. 57 tenths is the same thing as 57 divided by 10. So move the decimal one place to the left, which gives you 5 7/10. 33 hundredths is the same as 33 divided by 100, which means you need to move the decimal 2 places to the left. 2, which means you'll get 33 hundredths. 9 thousandths is the same as 9 divided by 1,000, which means you need to move the decimal point 3 places to the left, which is 1, 2, 3. So that'll give you 0.009, or 9 thousandths. Now it's your turn to practice. Pause the video and convert the fractions to decimals. When you found your answers, click play. Here you have 3 thousandths, which is 3 divided by 1,000. So move the decimal point 3 places to the left. 1, 2, 3, which gives you 0.003, or 3 thousandths. 21 hundredths is 21 divided by 100. So move the decimal point 2 places to the left. 1, 2, which gives you 0.21, or 21 hundredths. Last you have 7 tenths, which is 7 divided by 10, which means you need to move the decimal 1 place to the left, which gives you 0.7, or 7/10. Now let's talk about repeating decimals. A repeating decimal is a number with a pattern of digits that goes on forever after the decimal point, like 0.3333, where 3 repeats endlessly. To show this, put a bar over the repeating digits. For example, 0 3/10 with a bar over the 3 to show that it repeats over and over. For example, here we have the fraction 1/3, which is the same as 1 divided by 3. 3 can't go into 1, so add a decimal to the right of the ones place and bring it up. Then add a trailing 0. 3 goes into 10 3 times, because 3 times 3 is 9, which leaves a remainder of 1. Then add another trailing 0 and bring it down. 3 goes into 10 3 times, because 3 times 3 is 9, which leaves a remainder of 1. So add another trailing 0 and bring it down. As you can see, it'll keep going forever and ever in an endless loop. So to write this as 0.3 with the bar over the 3 to show that the 3 repeats forever. Now follow along as I solve these problems. Here I need to convert the fractions to decimals. So 2/3 would be 2 divided by 3. And 3 can't go into 2, so I'll add a decimal to the right of the ones place and then bring it up in my answer. And then I'll add a trailing 0. 3 goes into 20 6 times, because 6 times 3 is 18, which leaves a remainder of 2. So I'll add another trailing 0 and bring it down. And 3 goes into 20 6 times, because 6 times 3 is 18, which leaves a remainder of 2. And as you can see, it will go on forever and ever. So I can rewrite this repeating decimal as 0.6 with the bar over the 6 to show that it repeats forever. Next I have 13/9, which is the same as 13 divided by 9. And 9 can't go into 1, but it goes into 13 one time, which leaves a remainder of 4. So I'll add a decimal to the right of the ones place and then bring it up. And then I'll add a trailing 0 and bring it down. 9 goes into 40 4 times, because 4 times 9 is 36, which means I'll have a remainder of 4. So I'll add another trailing 0 and bring it down. And 9 goes into 40 4 times, because 4 times 9 is 36, which leaves a remainder of 4. So once again, it'll keep going forever and ever. So 13/9 is approximately 1.4 with a line over the 4 to show that it repeats forever and ever. Now it's your turn to practice. Pause the video and solve the problems. When you found your answer, click play. Here you need to convert the fractions to decimals. So 7/11 is the same as 7 divided by 11. And 11 can't go into 7, so add a decimal to the right of the ones place and then bring it up in your answer. Then add a trailing 0. 11 goes into 70 6 times, because 6 times 11 is 66, which leaves a remainder of 4. Then add a trailing 0 and bring it down. 11 goes into 44 3 times, because 3 times 11 is 33, which leaves a remainder of 7. Then add a trailing 0, and then bring it down. 11 goes into 70 6 times, because 6 times 11 is 66, which leaves a remainder of 4. So add another trailing 0, and then bring it down. And 11 goes into 40 3 times. And as you'll see, the pattern keeps repeating forever and ever. So I can rewrite this as 0.63 with a line on top of the 6 and the 3, because both digits repeat forever and ever. Next you have 7/3, which you can rewrite as 7 divided by 3. And 3 goes into 7 2 times, because 2 times 3 is 6, which leaves a remainder of 1. So add a decimal after the ones place and bring it up in your answer. Then add a trailing 0 and bring it down. 3 goes into 10 3 times, because 3 times 3 is 9, which leaves a remainder of 1. Add another placeholder 0 and bring it down. And 3 goes into 10 3 times, because 3 times 3 is 9, which leaves a remainder of 1. And as you can see, the pattern will repeat over and over again. So this repeating decimal can be written as 2.3 with the line over the 3 to show that it repeats forever. Now let's talk about how to convert mixed numbers to decimals. A mixed number is a whole number plus a proper fraction. For example, 3/2 is the same as 3 wholes plus 1/2. To convert a mixed number to a decimal, you can do it in two ways. Option 1 is to divide the fraction part to turn it into a decimal and then add the decimal to the whole number. Or in option 2, you can convert the mixed number to an improper fraction and then divide like normal. Now follow along as I solve these problems. Here I need to convert the mixed numbers to decimals. Here I have 3 2/5. In this case, I'll use option 1. So I'll first convert the fraction part to a decimal. 2/5 is the same as 2 divided by 5. And 5 can't go into 2, so I'll add a decimal to the right of the ones place and bring it up. Then I'll add a placeholder 0. And 5 goes into 20 4 times, because 4 times 5 is 20, which means I'm left with the remainder of 0. So 2/5 equals 4/10. And then I need to add that to the whole number. So 3 plus 4/10 equals 3 4/10. So 3 2/5 as a decimal equals 3 4/10. Next I have 6 1/9, and in this case I'll use the second option, which means I'll convert the mixed number to an improper fraction and then divide like normal. 9 times 6 is 54, plus 1 is 55, and the denominator stays the same. That gives me 55/9, which is the same as 55 divided by 9. And 9 can't go into 5, but 9 goes into 55 6 times, because 9 times 6 is 54, which means I'm left with the remainder of 1. So I'll add a decimal to the right of the ones place and bring it up, and then I'll add a trailing 0 and bring it down. 9 goes into 10 1 time, which leaves a remainder of 1. As you can see, the pattern will keep repeating, so I'll put a bar over the 1 to show that it repeats forever. So 6 1/9 as a decimal is 6 1/10 repeating. Now it's your turn to practice. Pause the video and solve the problems. When you found your answers, click play. Here you have 4 3/8. So if you follow option 1, you can first convert the fraction part to a decimal by dividing 3 by 8. And 8 can't go into 3. So add a decimal to the right of the ones place and bring it up. Then add a trailing 0. 8 goes into 30 3 times, because 3 times 8 is 24, which leaves a remainder of 6. Then add another trailing 0 and bring it down. 8 goes into 60 7 times, because 7 times 8 is 56, which leaves a remainder of 4. Then add another trailing 0 and bring it down. And 8 goes into 40 5 times, because 5 times 8 is 40, which leaves a remainder of 0. So when you add the whole number and the decimal together, you get 4 375,000. So 4 3/8 as a decimal is 4 375 thousandths. Here you have 11 5/6. And here you can use the second option, which is to convert the mixed number to an improper fraction and then divide to get the decimal. So 6 times 11 is 66, plus 5 is 71, over the same denominator, which is 6. And 71/6 is the same as 71 divided by 6. And 6 goes into 7 one time, which gives you a remainder of 1. Then bring down the 1. And 6 goes into 11 one time, which leaves you with the remainder of 5. So add a decimal to the right of the ones place and bring it up in your answer. Then add a trailing 0 and bring it down. And 6 goes into 50 8 times, because 8 times 6 is 48, which leaves you with the remainder of 2. So add another trailing 0 and bring it down. And 6 goes into 20 3 times, because 3 times 6 is 18, which leaves you with the remainder of 2. So as you can see, 3 will keep repeating. So I'll put a line or bar over the digit 3. So 11 5/6 as a decimal is equal to 11 83/100 with the bar over the 3 to show that the 3 repeats forever. Now let's review. Fractions are really division problems in disguise. So to convert a fraction to a decimal, just divide the numerator on top by the denominator on the bottom. To convert a mixed number to a decimal, you can do it in 2 ways. In option 1, you can divide the fraction part to turn it into a decimal and then add the decimal to the whole number. In option 2, you can convert the mixed number to an improper fraction and then divide to find the decimal. Converting fractions and mixed numbers to decimals is important for easy comparisons and calculations in everyday tasks like cooking and shopping. So what's next? Review what you learned by doing the knowledge check. Then master what you learned by doing the practice activity. In the next lesson, you'll learn how to convert decimals to fractions and mixed numbers. But before you do, make sure to watch the video on how to use a calculator to convert a fraction or mixed number to a decimal. I'll see you there. In this lesson, you'll learn how to use a TI-30XS multi-view calculator to convert fractions and mixed numbers to decimals. So let's get started. First, you'll learn how to convert the fraction 3/8 to a decimal. Remember, fractions are really division problems in disguise. So to convert a fraction to a decimal, divide the numerator on top by the denominator on the bottom. So to convert 3/8 to a decimal, all you have to do is divide 3 by 8, and then click Enter. As you can see, 3/8 is equal to 375 thousandths. Another way to do this on the calculator is to use the N over D button. So you can press N over D, and then type in the numerator, which is 3, and then the down arrow, and then the denominator, which is 8, and then press the right arrow button, and then press the toggle button, which is just above the Enter button. Then press Enter. As you can see, the calculator converts 3/8 to the decimal 375 thousandths. There is a third way to convert a fraction to a decimal, and once again you need to use the N over D button. Then enter the numerator of 3, and then the denominator of 8. Then press the right arrow button, and then press the second button, and then the table button to activate the fraction to decimal and vice versa function, which is F to D. Then press Enter. Once again, the calculator converts the fraction to a decimal. Now it's your turn to practice. Pause the video and use the calculator to convert the improper fraction 11/5 to a decimal. And when you found your answer, click play. First, you can divide 11 by 5. So type in 11, and then press the division button, and then 5, and then press Enter. As you can see, 11/5 equals 2 2/10. Another way to do that is to use the N over D button, or the numerator over denominator button, and then enter the numerator, which is 11, and then the down arrow, and then the denominator, which is 5. Then press the right arrow, and then press the toggle button, which is just above the Enter button. Then press Enter. As you can see, the calculator converts the fraction to an equivalent decimal. There is one more way to do it, which is to press the N over D button and then enter the numerator and the denominator, and then press the second button and then the table button to activate the fraction to decimal and vice versa function. Then press Enter. Once again, you can see that 11/5 is equivalent to 2 2/10. Now it's time to practice with repeating decimals. So first, let's convert the fraction 1/3 to a decimal. I can start by pressing 1 and then the division button, and then 3 and then press Enter. As you can see, I get a decimal with the repeating digit. So in this case, you can write that as 0.3 with the bar over the 3 to show that it repeats forever. The same can be done using the other two methods. You can press the N over D button and then enter the numerator of 1 and then the down arrow and then the denominator of 3 and then the right arrow. Then press the toggle button above the Enter button. Then press Enter. Once again, you get a repeating decimal. Lastly, you can use the third method, which is to press N over D, then enter the numerator and denominator, and then press second and then the table button. Then press Enter. Once again, you get a repeating decimal, which you can rewrite as 0.3 with the bar over the 3 to show that it repeats forever. Now it's your turn to practice. Pause the video and use a calculator to convert the improper fraction 13/9 to a decimal. When you found your answer, click play. Here you can divide 13 by 9, then press Enter. As you can see, you get 1.4 with 4 repeating. So you can rewrite that as 1.4 with the bar over the 4 to show that that digit repeats forever. Another way to do it is to press N over D, then enter the numerator of 13 and then the down arrow button and then the denominator of 9, and then the right arrow button, and then press the toggle button, which is above the Enter button. Then press Enter. You can also use the third method, which is to press N over D and then enter the numerator and denominator, and then press the second button and the table button. Then press Enter. Once again, you get a repeating decimal, which is 1.4 with the bar over the 4 to show that it repeats forever. Now let's practice converting a mixed number to a decimal. One way to do this is to convert the fraction part to a decimal like we've been practicing. For example, the mixed number 3 2/5 can be converted to a decimal by first converting 2/5 to a decimal. So you can do 2 divided by 5, which equals 4/10, and then add the whole number. So do plus 3, which equals 3 4/10. Another way to do this is to use the U over ND function, which is for mixed numbers. So first, press the second button, and then the N over D button, and then enter the whole number, which is 3, and then the right arrow, and then enter the numerator of 2, and then press the down arrow, and then the denominator of 5. Then press the right arrow. Then press the toggle button, which is just above the Enter button, and then press Enter. A third way to do this is to press the second button, and then the N over D button, and then enter the whole number, which is 3, and then press the right arrow, and then the numerator of 2, and then the down arrow and the denominator of 5, and then the right arrow. Then press second, and then press the table button. Then press Enter. Once again, you can see that the mixed number 3 2/5 is equivalent to the decimal 3 4/10. Now it's your turn to practice. Pause the video and use the calculator to convert the mixed number 11 5/6 to a decimal. When you found your answer, click play. To convert the mixed number 11 5/6 to a decimal, you can first convert the fraction part to a decimal by dividing 5 by 6, which equals 0.83333, which repeats. So you can rewrite that as 0.83 with the bar over the 3 to show that it repeats. But remember, you also have to add the whole number, which is 11. So do plus 11, which equals 11 83/100 with a bar over the 3. Another way to do this is to press the second button and then the N over D button and then enter the whole number, which is 11, and then the right arrow, and then enter the numerator of 5, and then the down arrow, and then the denominator of 6, and then the right arrow. Then press the toggle button above the enter button, then press enter. A third way to do it is to press the second button, and then the N over D button, and then enter the whole number, and then the numerator and denominator, and then press the second button again, and then the table button. Then press enter. Once again, you can see that 11 5/6 equals 11 83/100 with a bar over the 3 to show that it repeats forever. Now you know at least 3 different ways to use the TI 30XS Multiview Calculator to convert fractions and mixed numbers to decimals. In this lesson, you'll learn how to convert decimals to fractions and mixed numbers. So let's get started. It's important to know how to convert decimals to fractions and mixed numbers because it helps you work with measurements in everyday life. Since place values are based on factors of 10, decimals can be rewritten as fractions with a denominator of 10, 100, 1,000, 10,000, and so on. For example, the decimal 0.7 can be rewritten as the fraction 7 over 10. The decimal 0.53 can be rewritten as the fraction 53 over 100, and the decimal 0.129 can be rewritten as the fraction 129 over 1,000. So how do you convert a decimal to a fraction? First, count the decimal digits. Then, put that many zeros after the number 1, and that's your denominator. Then drop the decimal point, and that's your numerator. Finally, simplify the fraction if possible. For example, let's write 0.5 as a fraction. First, count the decimal places, and 0.5 has 1 decimal place. So add a 0 after 1, so the denominator becomes 10. Then drop the decimal from the original number, so 0.5 becomes 5, which is the numerator. Then write the fraction, which is 5 over 10, or 5/10, which can be simplified by a factor of 5. And 5 divided by 5 is 1, and 10 divided by 5 is 2. So 5/10 simplifies to 1/2. So 5/10 as a decimal is equal to 1/2 as a fraction when simplified to lowest terms. Now follow along as I solve these problems. Here I need to rewrite the decimals as fractions in lowest terms. And remember, a fraction in lowest terms can't be simplified further. First, I have 2/10, which has 1 decimal place. So I'll rewrite the denominator as 10, because it has 1 0. And then I'll drop the decimal, which becomes the numerator. So that becomes 2. And 2/10 can be simplified, because 2 and 10 are even numbers, so they're both divisible by 2. And 2 divided by 2 is 1, and 10 divided by 2 is 5, which can't be simplified further. So 2/10 is equal to 1/5 as a fraction. Next I have 73/100, which has 2 decimal places. So the denominator is 100, which has 2 zeros. And then I'll drop the decimal from the original number, so that becomes 73 as the numerator. In this case, 73/100 cannot be simplified. So that's the final answer. Last, I have 125,000, which has 3 decimal places. So the denominator will be 1,000, which has 3 zeros. And then I'll drop the decimal to get the numerator, which is 125. In this case, the numbers end in 5 and 0, which means that both numbers are divisible by 5. and 125 divided by 5 is 25, and 1,000 divided by 5 is 200. Once again, both numbers end in 5 or 0, which means that they too are divisible by 5. And 25 divided by 5 is 5, and 200 divided by 5 is 40. And once again, the numbers end in 5 or 0, which means I can divide by 5 again. And 5 divided by 5 is 1, and 40 divided by 5 is 8. So 125 thousandths as a fraction is 1/8. Now it's your turn to practice. Pause the video and solve the problems. When you found your answers, click play. Here you need to rewrite the decimals as fractions in lowest terms. First you have 8/100ths, which has 2 decimal places, so the denominator will be 100, and the numerator will be 8. And 8 and 100 are both divisible by 4. 8 divided by 4 is 2, and 100 divided by 4 is 25. And 2 25ths cannot be simplified further. So 8/100ths as a fraction is 2 25ths. Next you have 7/10ths, which has 1 decimal place. So the denominator will be 10, and the numerator will be 7. And 7/10ths cannot be simplified. So that's the final answer. Last, you have 375 thousandths, which has 3 decimal places, so the denominator will be 1,000. And the numerator will be 375. Here both numbers end in 5 or 0, which means they're both divisible by 5. (375) divided by 5 equals 75, and 1,000 divided by 5 is 200. And once again, they end in 5 or 0, so divide by 5 again. And 75 divided by 5 is 15, and 200 divided by 5 is 40. And once again, both numbers end in 5 or 0, so keep dividing by 5. 15 divided by 5 is 3, and 40 divided by 5 is 8. So 375 thousandths as a fraction simplifies to 3/8. Now it's time for more practice. Pause the video and solve the word problem, and when you found your answer, click play. A machinist needs to set a machine part to be precisely 625 thousandths inches thick. However, the machine displays measurements in fractions, not decimals. What fraction represents 625 thousandths inches? 625 thousandths has 3 decimals, which means the denominator will be 1,000, which has 3 zeros. And when you drop the decimal, the numerator will be 625. Here the numerator and denominator end with 5 or 0, so they're both divisible by 5. 625 divided by 5 equals 125. And 1,000 divided by 5 is 200. Once again, they end in 5 or 0, so I can divide both by 5. 125 divided by 5 is 25, and 200 divided by 5 is 40. Then they both end in 0 or 5 again, so I'll divide both by 5. And 25 divided by 5 is 5, and 40 divided by 5 is 8, which means that 625 thousandths is equal to 5/8 of an inch. Now let's talk about how to convert decimals larger than 1 to mixed numbers. First, find the whole number part before the decimal point. Then, Write down the decimal part as a fraction. The number of decimal places will tell you the denominator. For example, 25 hundredths as a decimal becomes 25 hundredths as a fraction. Then simplify the fraction if possible. In this case, 25 hundredths simplifies to 1/4. Finally, put the whole number and the simplified fraction together to make a mixed number. For instance, 3 and 25 hundredths is 3 and 1/4 as a mixed number. Now follow along as I solve these problems. Here I need to rewrite the decimals as mixed numbers. And remember, a mixed number is a whole number and a fraction combined. For example, 4½ Here I have 3 and 25 hundredths, and the whole part is 3, and the fraction part is 25 hundredths, which is 25 over 100. And in this case, I can simplify both the numerator and denominator by 25, which is their greatest common factor. 25 divided by 25 is 1, and 100 divided by 25 is 4, which gives me the fraction 1/4, and then I'll bring over the whole number. So 3 and 25 hundredths is equal to 3 and 1/4 as a mixed number. Next I have 1 and 9/10, which is 1 and 9 over 10. And 9/10 cannot be simplified, so the answer is 1 and 9/10. Last, I have 14 and 875 thousandths, which is 14 and 875 over 1,000. In this case, I can divide the numerator and denominator by their greatest common factor, which is 125. 875 divided by 125 is 7, and 1,000 divided by 125 is 8, which gives me the fraction 7/8, and then I'll bring over the whole number. So my answer is 14 and 7/8. Now it's your turn to practice. Pause the video and solve the problems, and when you found your answers, click play. Here you need to rewrite the decimals as mixed numbers. And first, you have 4 and 6/10, which is 4 and 6 over 10. 6 and 10 are both even numbers, so they're both divisible by 2. 6 divided by 2 is 3, and 10 divided by 2 is 5, which gives you the fraction 3/5, and then bring over the whole number. So the answer is 4 and 3/5. Next you have 19 and 263 thousandths, which is 19 and 263 over 1,000. And 263 thousandths cannot be simplified. So the answer is 19 and 263 thousandths. Last, you have 9 and 75 hundredths, which is 9 and 75 over 100. Here, I can simplify the fraction part because the greatest common factor of 75 and 100 is 25. And 75 divided by 25 is 3, and 100 divided by 25 is 4. So that gives you the fraction 3/4. And then bring over the whole number. So the answer is 9 and 3/4. Now it's time for more practice. Pause the video and solve the word problem. And when you found your answer, click play. You want to buy a bag of apples that weighs 1 4/10 kilograms. However, the scale shows weights in mixed number format rather than decimals. What is the weight of the bag expressed as a mixed number? In this case, you have 1 and 4/10, which is 1 and 4 over 10. And 4 and 10 are both even numbers, so they're both divisible by 2. 4 divided by 2 is 2, and 10 divided by 2 is 5, which gives you the fraction 2/5, and then bring over the whole number. So 1 4/10 as a decimal is equal to 1 2/5 as a mixed number. So the bag of apples weighs 1 2/5 kilograms. Now let's review. It's important to know how to convert decimals to fractions and mixed numbers because it helps you work with measurements in everyday life. Since place values are based on factors of 10, decimals can be rewritten as fractions with the denominator of 10, 100, 1,000, 10,000, and so on. Just make sure to simplify your answer if possible. So what's next? Review what you learned by doing the knowledge check. Then master what you learned by doing the practice activity. In the next lesson, you'll learn how to compare and order decimals and fractions. I'll see you there. In this lesson, you'll learn how to convert decimals to fractions and mixed numbers using a TI-30XS multi-view calculator. So let's get started. First, I have the decimal 2/10, which is 0.2. And then to convert the decimal to a fraction, I can press the toggle button just above the enter button. Then I'll press enter. As you can see, the calculator converts 2/10 to 1/5, which is the fraction in lowest terms. Next I have 73/100, which is 0.73, but instead of using the toggle button, I'll convert the decimal to a fraction a different way. I'll press the second button, and then I'll press the table button to activate the fraction to decimal or decimal to fraction function. Then I'll press enter. As you can see, the calculator converts 73/100 as a decimal to the fraction 73/100, which is in lowest terms. Now it's your turn to practice. Pause the video and use a calculator to convert 8/100 and 7/10 to fractions. And when you found your answers, click play. First you have 8/100, which is 0.08. And then press the toggle button just above the enter button. Then press enter. As you can see, 8/100 as a decimal is equal to 2/25 as a fraction in lowest terms. Next you have 7/10, which is 0.7. This time you can use the second button and then press the table button to activate the fraction to decimal and decimal to fraction function. Then press enter. As you can see, the decimal 7/10 is equal to the fraction 7/10. Now let's practice converting decimals greater than 1 to mixed numbers. First I have 3 and 25/100. First I need to convert the decimal to an improper fraction by pressing the toggle button over the enter button. Then I'll press enter. As you can see, I get the improper fraction 13/4. To convert that to a mixed number, I'll press the second button and then the x to the 10 to the nth power button to activate the fraction to mixed number function. Then I'll press enter. So 3 25/100 is equal to 3 1/4 as a mixed number. Next I need to convert the decimal 1 9/10 to a mixed number, but this time I'll press the second button and then the table button to activate the fraction to decimal function. Then I'll press enter. As you can see, the calculator gives me an improper fraction of 19/10, which I can convert to a mixed number by pressing the second button and then the x times 10 to the nth power button to activate the fraction to mixed number function. And then I'll press enter. As you can see, 1 9/10 as a decimal is equal to 1 9/10 as a mixed number. Now it's your turn to practice. Pause the video and use a calculator to convert 4 6/10 and 19 263 thousandths to mixed numbers. And when you found your answers, click play. Here you have the decimal 4 and 6/10. So you can convert that to an improper fraction by pressing the toggle button. Then press Enter. To convert the improper fraction to a mixed number, press the second button and then the x times 10 to the nth button to activate the fraction to mixed number function. Then press Enter. As you can see, 4 and 6/10 as a decimal is equal to 4 and 3/5 as a mixed number. Next you have the decimal 19 and 263 thousandths. And then you can press the second button and then the table button to activate the fraction to decimal or decimal to fraction function. Then press Enter. As you can see, you get an improper fraction, which you can convert to a mixed number by pressing the second button and then the x times 10 to the nth button to activate the fraction to mixed number function. Then press Enter. So the decimal 19 and 263 thousandths as a mixed number is equal to 19 and 263 over 1,000. Now you know how to convert decimals to fractions and mixed numbers using a TI 30XS Multiview calculator. In this lesson, you'll learn how to compare and order fractions and decimals. So let's get started. The first step when comparing and ordering fractions and decimals is to convert the fractions to decimals. If you have fractions, change them into decimals by dividing the numerator on top by the denominator on the bottom. For example, here we have 7/9 compared to 75/100. 7 divided by 9 gives us the decimal 0.7 with the 7-digit repeating forever. When I compare that with 75/100, I need to line up the decimals one on top of the other and then compare the digits from left to right. So I'll line up the 75/100 underneath, making sure that the decimals line up. In this case, since the 7 is repeating, I can add a 7 in the hundredths place. Now I can compare left to right. First I have zeros, which are the same, then I have 7s, which are the same, and 7 is bigger than 5, which means that 7/9 is bigger or greater than 75/100. Now follow along as I solve this problem. Compare 6/10 to 2/3. Which of the following statements is true? Here I need to compare the decimal 6/10 with the fraction 2/3. And 2/3 as a decimal is 2 divided by 3, which gives me 0.6 repeating. In this case, I can add a 6 in the hundredths place, and I can add a 0 to the decimal on top. Then I can compare left to right. 0 and 0, 6 and 6, and 0 is less than 6, which means the decimal 6/10 is less than 2/3. And remember, the hungry alligator mouth or Pac-Man always wants to eat the bigger number. So the answer is A. Now it's your turn to practice. Pause the video and solve the problem. When you found your answer, click play. Here you need to compare the fraction 5/2 to the decimal 2 and 53/100. And 5/2 is the same as 5 divided by 2, which gives you the decimal 2 and 5/10. And in this case, I can add a trailing 0 to the decimal on the bottom. Now I can compare left to right. 2 and 2, 5 and 5, and 0 is less than 3. Which means that 5/2 is less than 2 and 53/100. So the answer is C. Now follow along as I solve this problem. Here I need to compare the mixed number 2 and 1/3 to the decimal 2 and 35/100. And here I can convert 1/3 to a decimal, which is 1 divided by 3, which gives me 2.3 repeating. And then I can compare that to the decimal 2 and 35/100. And since the 3 is repeating, I can add a 3 in the hundredths place. Now I can compare left to right. 2 and 2, 3 and 3, and 3 is less than 5, which means that 2 and 1/3 is less than 2 and 35 hundredths. So the answer is B. Now it's your turn to practice. Pause the video and solve the problem. And when you found your answer, click play. Here you need to compare the mixed number 3 and 2/5 to the decimal 3 and 4/10. You can convert the 2/5 to a decimal by dividing 2 by 5, which gives you 3 and 4/10, which is equal to 3 and 4/10. So 3 and 2/5 is equal to 3 and 4/10. The answer is D. Now follow along as I solve this problem. The value of x, y, and z are as follows. X equals 3/5, y equals 5/3, and z equals 1 5/10. Which comparison statement is true? Well, I'll start by converting the fractions to decimals. And 3/5 as a decimal is 6/10. And 5/3 is 1 6/10 with the 6 repeating. And z is just 1 5/10. So I'll line up the decimals and compare them. In this case, it looks like I need to compare them from least to greatest. So 0 is less than 1 and 1. So the 6/10 is the smallest. And then I need to compare the 5/10 and the 6/10. And 5 is less than 6. So the next smallest number is 1 5/10. And the largest number is 1 6/10 repeating. So to list them from least to greatest, I'll start with x, which is less than z, which is less than y. So the answer is C. Now it's your turn to practice. Pause the video and solve the problem. And when you found your answer, click play. The values of A, B, and C are as follows. A is 11/7, B is 1 379 thousandths, and C is 1 3/8. Which comparison statement is true? Start by converting the fractions to decimals, and 11/7 is approximately equal to 1.571. And B is just 1 379 thousandths. And C converted to a decimal is 1 375 thousandths. Now you can line up the decimals and compare them from left to right. In this case, it looks like you need to compare them from greatest to least. So starting from the left, you have 1, 1, and 1. So keep going. And 5 is bigger than 3. So the greatest number is 11/7. And then keep going with the other two decimals. 7 and 7, and 9 is greater than 5. So the next largest number is 1 379 thousandths, which means the smallest number is 1 3/8. So to order the values from greatest to least, start with 11/7, which is A, which is greater than 1 379 thousandths, which is B, which is greater than 1 3/8, which is C. So the correct answer is D. Now follow along as I solve this problem. Which of the following lists the rational values from least to greatest? Here I need to convert the fractions and mixed numbers to decimals. And 1 2/3 is the same as 1 6/10 with the 6 repeating. And 3/2 is the same as 1 5/10. Now I need to line up the decimals and then compare them from left to right. In this case, I can add trailing zeros to the end of the first decimal and sixes to the second decimal. And then I can add trailing zeros to the last decimal. Now I can compare them. 1 and 1 and 1 and 1. 5 and 5, 6 and 6. And 5 is less than 6, so I'll keep going. And 0 is less than 8. So the smallest value is this one, followed by the one on top. And then I'll keep going with the other two decimals. 0 is less than 6, which means 1 6/10 is smaller than the decimal below it. And then I'll write in the original values. So to order them from least to greatest, I'll start with 3/2, and then I'll write the decimal 1 587,000ths, and then the decimal 1 6/10, and then the mixed number 1 2/3. So the answer is C. Now it's your turn to practice. Pause the video and list the rational values from greatest to least. And when you found your answer, click play. Here you need to list the values from greatest to least. So you need to convert the mixed numbers and fractions to decimals. And 2 1/5 is the same as 2 2/10. And 1/3 is equal to 0.3 with the 3 repeating. Now you can line up the decimals. In this case, you can add trailing zeros to the top two decimals. And then you can add a 3 to the bottom decimal. Now compare from greatest to least, working left to right. And 2's are bigger than 0's. So keep going. And 2 and 2 are equal, and 5 is bigger than 0. So the greatest value is this one, followed by the value on top. And then keep going with the other two decimals, 3 and 3. And 3 is bigger than 0. So the next value is the bottom one. And the smallest value is this one. Now we write the decimals with their original value. So to order the values from greatest to least, I'll start with 2 25/100ths, followed by 2 1/5. Then I'll put 1/3, followed by the decimal 3/10. So the answer is A. Now let's review. Comparing fractions and decimals can be done in 2 steps. First, convert any fractions or mixed numbers to decimals. Then compare the decimals by lining them up and then comparing left to right. Comparing and ordering fractions and decimals helps you see their relative sizes, which is useful when shopping, building things, and cooking. So what's next? Review what you learned by doing the knowledge check. Then master what you learned by doing the practice activity. Next, you'll review everything you learned about fractions and decimals.